I think in the paucity of time we will start. So good morning everyone. My name is Ahmed. I'm part of the organizing team here at Zak. I'll quickly introduce the Zak World of Façades conference series to you. It's our first time here in Calgary, which means that it's the first time that people have heard of this event, but I'll just take a couple of minutes to introduce the event. So we've been organizing this conference series since 2012. We've finished around 212 editions in 49 countries as on date. So this is our first one in Calgary. It's our 10th one in Canada. We've had editions in Montreal, in Vancouver, in Toronto. And it's just the third event which we are ever doing during an active snowfall. So most part of the time it's in good weather, but seems like this is normal for Alberta and Calgary. So we have these events for 2026. They're all across the globe. It started with one country, then went to another country, and we quickly realized that there's a lot of scope to organize facade-specific events globally. Most of the places we went never had a facade conference, which made it easier for us to go to several places. We go to several countries which I never heard of until last year. Albania, which is somewhere in Europe, but the kind of projects which are there in Albania is unbelievable. Albania has 70 under construction towers which are over 150 meters. It puts most of mainland Europe to shame, which is predominantly adaptive reuse or renovation projects. So Albania, Uzbekistan, which is a jewel in Central Asia, Georgia, these are places, these are vacation destinations basically, but there's lots of migration happening there, lots of boom happening there. I think these are the places where there's a lot of momentum in terms of construction in that part of the world happening. And of course, we have the usual suspects with our events in New York, London, and other places. We went to Cyprus, we did Greece last year. So lots of places we organize this event, and it's the same format, but the content varies from every location. We talk what's more topical to that respective city and that region, and I think today's program is also a reflection of that. Intentionally kept it projects
it's recording.
In Alberta,
I tested it.
So that there's a connect. There's no point talking about something which happens in China or in the Middle East, checking out projects you probably can't build them here. So I think our conference team has put up an excellent program today, which features presentations by architects, by facade engineers, building science engineers, manufacturers, and of course,
there's
featuring different set of people. So this is our event lineup for 2026, and again these events are all thanks to our event partners. For 16 of them, I'll take a moment to introduce all of them, starting with Rayners, who are our presenting partners. So those who don't know Rayners is a Belgium company. They are into aluminium door, window and curtain wall systems. They've been a strong supporter of this conference series in Canada and then globally. So they are our presenting partner. Like Rayners, we've got 15 other partners who are all having a tabletop display in the exhibit area. So please do network with them during the course of the day, in the networking breaks, during the lunch, etc. And our associate partner, so it's AFC. So AFC is a distributor of several products. They've got fiber cement cladding, they've got terracotta, and a couple of other stuff that they distribute. A lot of European cladding products. Alucoil is from Spain. Alucoil is an ACM manufacturer. They are known for their non-combustible solution and their honeycomb solutions. Cosentino is another Spanish company. Their facade cladding product is called Tecton. It was initially a kitchen top surface which was then engineered to be used on the external facade. You need to fix a product like that, and Yacht is a company from Germany which gives the fixing solutions for rain screen cladding solutions. Engineered Assemblies is from Canada. They are a distributor of several cladding materials, so terracotta, fiber cement, clay, slate, you name it. They've got a wide range of solutions. Innova is also from Canada, so they are specialists in custom curtain wall solutions. Glass Curtain, again another Canadian company. So they've got an interesting product, which is a fiberglass-based curtain wall system, which is basically controlled for these kind of weather conditions when it goes down to -30, -40. You'll be hearing from them later today. Hydro is from Norway. So Hydro is one of the leading global aluminium extrusion companies. Longboard is another Canadian company, so they've got wood finish aluminium cladding solutions. Lumon is a company from Scandinavia, so they've got these balcony glazing solutions for residential and commercial buildings. MSI has ceramic cladding solutions, and they are partnering with Aesthetics, who are basically giving the rain screen system to fix the ceramic cladding. So they are jointly participating together. NBK is from Germany. NBK are one of the world leaders in terracotta solutions. Sound Solutions is again a distributor of several cladding products, fiber cement, terracotta, and so many other products. I think they keep adding a product every time we do an event. Vitro Architectural Glass, I think formerly known as PPG Glass, one of the global leaders in coated glass solutions. They're known for their double silver, triple silver, and now even the quadruple silver glass. Bridgman is a glass fabricator out of British Columbia. So they are also exhibiting with us here after being with us a couple of times in Vancouver. Our next event in the North American series is in Phoenix. So we're going to Phoenix for the first time. Again, nobody's ever done a facade engineering conference in Phoenix, we've been told. So Phoenix is going to be our next event in North America. We had an event in Los Angeles last week. So Phoenix is next week. Vancouver is our second largest event in Canada. So Toronto is our largest event, and Vancouver is our next largest event, followed by Montreal. And of course, our two large events actually in the North American region are in New York and Toronto, which is from the 7th and 14th of October, respectively. So this is what we do. We organize these events globally. We do around 25, 26 events in 23 countries in one calendar year, so there's a lot. I think not many people had pushed us for Calgary, but we jumped last year and said we're going to do Calgary. I think our sponsors have come out and supported us. These events are recorded, which means that all presentations which are allowed to be shared with you would be on a YouTube link, which will reach you a week to 10 days from now, along with the feedback form. So please do fill up that feedback form. It helps us improve our events. And also you can watch the YouTube recording. So that's it from me. My role ends here. The boring part's over. I think we'll get to the exciting part. I'd like to call upon today's event host and convener, Lisa Gibson. She's from Colliers. She's going to be hosting today's event and be taking you through until the end of the day. So take care, and I hope all of you enjoy today's storytelling. Thank you.
Good morning. I don't know about the rest of you, but I'm pretty excited about today. Maybe the coffee hasn't kicked in yet. So I am going to share a little bit about myself and about Colliers project leaders to get us started. So Lisa Gibson. So I am a principal in the Colliers Project Leaders office here in Calgary. And what does Colliers Project Leaders do? Well, we are project managers who represent owners. We are owners' representatives advocating for the client in all these kinds of projects we're going to talk about today. Oh, sorry. I have to change my own slide. Excuse me for 1 second while I figured that out. Sorry. No, know, someone told me this would be a good icebreaker if I screwed up something technical in the beginning. So check. Excellent. So Colliers is a Canadian company. Our parent company is international, but the part of Colliers that I work for is Canadian. And we have offices across the country supporting projects, representing owners, coast to coast. Almost 1,000 people. I mean, maybe some of you have even worked with us before. When I say owner's representative and project management services, we have a number of other services that we provide that support projects. So everything from the very early, we don't even know if we have a project yet. So whether that is a business case or a feasibility study or grant application, all the way through to construction solutions, which is what you could do if you don't want to hire a general contractor quite yet. Furniture, equipment, planning, and move readiness, which started truly based in healthcare, but has grown to support any kind of project. And then infrastructure advisory, which runs across the life cycle of projects from start to finish. And then we have a really special group at Colliers, which is IPD and Lean. And that supports collaborative contracts. So not just IPD, but progressive design build and alliance model. And then provides lean coaching and lean support to a project. I would be remiss to not talk about a couple of amazing projects that we've worked on here in Calgary. So the first being the Central Library, which I'm sure most of you are familiar with, and if you have not seen the Central Library, you need to check it out. It is stunning. By show of hands, does everybody know the Central Library? Yay. Okay. Well, there's a couple of you. You probably should go check it out. And then currently, we are working on the Glenbow Museum. And you're going to hear more about this particular project in one of the presentations today. But these are the kinds of projects, these ones that change the face of Calgary, that invest in the culture of Calgary, that create spaces for people to come together and celebrate what the city is. And the Glenbow Museum is an amazing example of that. So stay tuned and come and see it when it opens in 2027. So I have a couple of boring housekeeping notes now to share before we move on to our first presentation. So there will be coffee breaks. There will be a lunch hour. I strongly encourage you all to network. I know a lot of people in this room, but if I don't know you, I am expecting that you will come and introduce yourself to me. The venue, the Westin, is asking that we don't bring lunch back into this room. Things like coffee, snacks, that's totally fine. And if you're collecting continuing education credits, there is a sign-up sheet somewhere at the registration desk. So you can sign up and get your credits that you need. So I think we're ready to start with our first presentation. So I am looking for Michael Henderson and Michael Depp.
Good morning, everyone. I'm Michael Henderson. This is Michael Dubb. We're two of many Michaels that worked on this project. I'm representing HCMA. Michael Dubb's representing of architecture. And this project is done in association with Faulkner Brown for the city of Edmonton and is located on Treaty 6 territories in that region. So I'm going to start off by walking you through some of the planning. I know this is a facades conference, but the facade piece really does drive a lot with the planning. And so Michael's going to bring you home at the end with kind of the facade-oriented piece. But I wanted to just set the stage a little bit on how the project came to be and what some of the drivers were. What sets this project slightly apart from other recreation centers is that it houses a velodrome. This indoor competition level track is intended to serve the local cycle community as well as the general community at large. And while cycle tracks are certainly beautiful forms, they are challenging objects to navigate around. They're essentially single-use structures where athletes reach speeds of up to 85 kilometers an hour and have slopes of about 45 degrees. These forms are very large, and it is a continuous loop with a highly calibrated surface. This makes the large area in the center, the infield, a challenge to access and to use effectively. So the high performance nature of the track is a barrier for recreational use, but the track itself is a literal barrier to access and to other uses within the infield. For this reason, velodromes often use a network of subterranean corridors to access that interior space. So our site was really a reminder that the building needed to have a community focus. Coronation Park was originally conceived as a formal civic landscape. And today it is a mature and well-loved community park that hosts a range of modernist architecture. Within this context, our goal was to make an enormous building, usually the domain of a handful of athletes, into an extension of the public realm, a recreation hub for the community and a good architectural neighbor. The story really begins with the site, where the formal symmetry of the original planning had been eroded by buildings over time. Our building's edge reinforces the original pathways, geometries, and axis. Our strategy was simple: locate the building in the central location that respects the original planning principles, but creates focus within the new context. We manipulated the landscape and created a landform, carved out spaces within the raised landscape, and allowed the space within to spill out into the park. From the new heart of the site, we used the carved spaces to create and reinforce important connections to landscape and buildings. Finally, the cycle track and running track sit atop the community spaces below, and we're using the landscape as a literal podium. Looking at the planning from top down, we see the track as a continuous loop. It's unbroken. We wrap the cycle track with a running track, leaving space between the two. This space becomes the zone for vertical structure, movement, program, and visible connections. Here we see the vertical structure that supports the roof, vertical movement, and program like spectator seating. The infield, typically a high-performance zone, can be difficult to access for anyone other than cyclists. We improve access by carving away half the infield and connecting the upper area to the floor below. This allows the recreational user to navigate unobstructed and allows visual access between both zones. The cyclist D is the staging ground before cyclists access the track itself. Non-cyclists access the infield via the lobby, through the urban court, up a social stair, and to the infield. The ground floor hosts the balance of the community users. Entry is from the plaza to the east and directly onto the lobby and reception area. The urban court is a playful counterpoint to the strict layout and dimensions of the courts and tracks found above. There's exercise and fitness together with a bouldering wall adjacent to that urban court, all with views out to the landscape. There's child minding, washrooms and change rooms, and bike storage and partner spaces buried in the landscape. A physical connection is made to the adjacent pool via a link. In triathlon mode, swimmers can access the cycle and running tracks using this partially buried link. So in plan, the building elements are organized around the rigid and prescribed geometries of the track. But manipulating these geometries in 3 dimensions and carving out floor plates gives the building its responsive and dynamic expression. This is an image of how this planning is being realized, the physical and visual connection from the carved spaces in the infield. And here showing how we maximize connections between program elements side to side and floor to floor.
I'm going to talk a little bit now about the second level, the upper level, and then also the construction process. So here you can see the cycle track under construction, and then the building being built around it at the same time. Talking about this because the cycle track in many ways was the inspiration for the design of the enclosure as well. They're very unique constructions, a lot of nuance, a very complex surface, but ultimately they're pretty rudimentary, built out of straight pieces of timber. These kind of ribs, radiating ribs, describing the profile like a boat, and then over top of that, laminated on top, is 2x2 spruce pieces that are then just nailed into place. But a lot of complexity coming out of a very simple process. So we took that as inspiration for how to create volume of the building. The upper roof form was conceived of as a replication of the running track profile, oval, rotated 90 degrees. And then we were kind of right-sized that form for structural spans. And we arrived at this form of a perfect circle sitting on top of the oval. The roof structure then became the overlap between the oval and the circle. So you can see that pillow-shaped form in the center becomes the central roof of the building, which is then supported by 4 stair cores. Here you can see that central roof structure. There's 100-meter long trusses in one direction and bridging trusses in the other direction. And those are supported by a perimeter ring beam, that box beam that then sits upon the stair cores. And here you can see those stair cores include vertical circulation for the building, but then also vertical surfaces. And here you can see it under construction. Stair cores acting essentially as table legs for this central structure. The ring beam being supported by that, and then the trusses spanning off the ring beam. Here, this is our kind of central table structure. Now around that, it is our building skin and enclosure. It essentially is a shrink-wrapped surface that spans between the running track and the upper roof volume. And here you can hopefully see the connection to the cycle track construction, where we thought of it as a complex surface that is built out of straight pieces and standard and similar components. So this is a cross-section through the kind of shorter side of the building. You can see the outer skin is leaning outwards versus the kind of longer section across the building where the outer skin leans inwards to bear upon the upper roof. The cycle track is kind of suspended in the middle there, protected by this outer enclosure. And so here you see the radiating ribs over the top of that same diagram describing the form, which are then skinned in a twisting enclosure form. So the resulting shape of this these variant ribs rating around is quite dynamic. If you look at the dashed line that you can see overlaid, that would essentially be what it would be if it was just extruded upwards. If you've ever been to the National Cycling Center in Ontario, in Milton, that's essentially what they built there. In our instance, we're interested in the idea of reducing the perceived volume of the building within the mature park, and also using this kind of shrink-wrapped volume in order to manage drainage and roof shedding in a predictable way. So similar to the cycle track, we're interested in kind of the simplicity of how the skin could become a structural surface as well. So in this case, we used a unique product. It's a mass timber product. It's called a mass plywood panel. It's plywood that's essentially about 3 inches thick, and they come about 5 feet wide, and they go up to 60 feet long. These huge sheets. And in this instance, we're treating them, the skin also, the sheeting also as structure. So these panels create a structural diaphragm that kind of locks, that makes the whole shape rigid, locks it into place. And in order to do this, because they're flat sheets of plywood, we had to make sure that our form was what we call developable, meaning it could be unrolled into a totally flat surface. So this is what the shape of the roof looks like if you unroll it like a sheet of paper. And this became a way that we could predictably lay out both the sheeting that you see on the bottom, and then the top is the layout of the cladding that will sit up over top of it. And we could manage where things like snow clips and gutters would run, and where the setting points would be. And this logic was useful during construction. This was a shop drawing that was submitted for the mass plywood using the same logic. So good for takeoff, but then also planning the installation.
You're fine, so just make sure you're
Here, this is a mock-up that we did of the plywood panels going in over the ribs. Clark Builders built this. Shout out to Clark Builders, they did a great job. And then the ribs being installed around the central structure. Here you can see the varying angles as they radiate around the central structure. And at the ends, where they lean in the most. Components, the essential geometry, even though the geometry changes, the components remain the same. This is an image of the plywood skin being kind of draped over the ribs. It all went quite smoothly. This is a product by Flores brothers. And over top of the plywood, skin, the mass plywood skin, is the membrane that you see on the left going in, and then an outboard insulation and girt on the right you can see going in. We worked with our building envelope consultants, RJC, on this. Great job. And then below that, the curtain wall, which is always kind of leaning out. So here you can see the kind of variation of geometry as you move around the building. Our philosophy was that the components of the building and the assemblies would be always the same, regardless of where you were in the around where you were in the building, but that there would just be unique conditions for where those assemblies kink and intersect. This shows the elevations from the two different sides of the building. The one highlight here, how the glass kind of swells up on the two sides of the building and then descends down on the other two sides. And that's in order to kind of create a structural drainage for the building. There's no sloped insulation anywhere in this building. All drainage and shedding is managed through the geometry. And so this would be a detail of what one of those kinks in the geometry looks like. You can see on the left where it's leaning out, and then it's just, it adapts as the geometry leans in to kind of collection points of drainage. And this is a section through one of those ribs. It's never as effortless as it ultimately looks. If you, at the top section there, the sheathing essentially, because the sheathing is structural, because it acts as a diaphragm, it has to bear consistently or continuously on the rib. But at the top of the rib, the sheathing is at an angle to the rib, versus when you go down to the bottom of the same rib, it's kind of perpendicular. So the sheathing is twisting along the length of the element. So we had to create custom kind of variable depth shims that were CNC'd and welded into each rib for every single rib in the building. So a lot of work to make sure that it structurally works. But then the end product, you don't see that difficulty. It all looks quite effortless. Here you can see the kind of direct connection between the construction of the cycle track and the construction of the envelope. This is just for the glass folks here. There's an internal balustrade that runs around the inside of the cycle track that's 2 meters high. We had to design this to withstand the worst possible loading, which was a pacing motorcycle running at 80 kilometers an hour, hitting this glass guard perpendicular. And so we ended up with a fairly sizable internal glass guard. Ultra clear glass, it was great. Flynn did a great job on it. This is the running track as you move around the building where it's leaning out. And you can see where it's leaning in. So, totally different loading situations, but the components remain the same, approach to detailing remains the same. We did a lot of explorations for what the appropriate material for the exterior might be. Won't get into all of it, but we eventually settled on a kind of chemically colored stainless steel product that we liked because it had a variability in how it looked depending on the conditions. I'll just talk here over the sheet. You can see that over the girts would be a low profile steel sheeting that then allows us to fasten into it wherever we need to for our shingles here. You can see these photos are taken about 30 seconds apart from the same place, essentially, and you can see how the color of the shingles changes dramatically depending on light conditions. So we liked how the product enhanced it emphasized the variability of the geometry. Here you can see the aerial photograph of it built, showing that kind of variable color. It's got a PV array on the roof that's it's LEED Gold building, very airtight. At the ground level, it's consistently 360 degrees of curtain wall, triple glazed, leaning outwards, views out, but then also at nighttime views in. And here you can kind of see the end product where the berms that Michael was talking about earlier kind of set the continuous public realm podium below, the kind of 360 degree curtain wall around the perimeter of it, and then sitting on top of that, our twisting roof, or our twisting enclosure. And with that, pass on to the next speaker. Thank you, everyone.
There, it's on. I think that Michael Squared deserves a special clap because they were the very first ones to come out. And it does remind me of something I forgot to mention before, which is at the end of each session, the people who spoke in that session come back up here for a photo and a special thank you from Zak. Dwelling was listening to that presentation, I thought, this is the perfect time for a couple of dad jokes. Or mom jokes, maybe? So why don't windows tell lies? Because they're just too transparent. Why did the crane go to school? To lift its grades, of course. What do you call, this one is related to the next presentation. What do you call the child of an engineer? A trust fund baby. And on that note, we're going to move on to the next presentation, which is Paul Carter, Project Director, Building Sciences with WSP, and Christian Flores, Senior Project Manager, Building Sciences with WSP, on advancing enclosure performance with offsite construction.
Good morning, everybody. I am Paul Carter, and this is Christian Flores. We are both building envelope consultants with WSP. And today we're going to be talking about how we can use prefabricated panelized wall systems to achieve high performance building envelopes. I'll start by talking about why prefabricated wall assemblies are becoming more common, and then Christian's going to go into what these systems are and how to use them on projects. So market drivers, there are converging forces that are making these systems become economically viable. So I'm going to go through what those are. First, we've got a housing supply shortage. I think this is pretty well known. It's in the media almost every day. CMHC has done a projection as to what we need to get housing affordable again, back to 2004 kind of affordability levels. We need almost 3.5 million extra units of housing by 2030. And Build Force Canada has done a projection on what it will take in terms of labor force to build those units, and we need another 500,000 laborers. This is happening at the same time as there's an attrition. A large number of the workforce is retiring, and then there's competition with other sectors like manufacturing, industry, that are making it hard to build up the labor force for construction. McKinsey and Company has done a study looking at markets around the world and where prefabricated systems gain the most traction, and it's at this kind of junction between labor and housing shortages. This is where the projects really become viable to use modular construction, including prefabricated walls. And this is because of productivity. Using prefabricated assemblies really gets the labor into a controlled environment in a factory instead of on site where you've got slowdowns from weather, construction sequencing, and so forth. You've got higher quality. It's just more efficient to build off-site in terms of labor. And this will address Canada's kind of productivity slowdown, which is really led by the construction industry. This will help innovate the construction industry and lift it out of kind of a productivity slump. It's the largest sector in terms of labor business, how our labor hours worked. So it's kind of critical that we address this for Canada's economy. Buildings need to be enclosed quickly. This speeds up the construction schedule, which saves a lot of money in terms of general conditions and gets that building operating and producing revenues sooner. We also have mass timber becoming very popular, and enclosing these structures is important so they don't get damaged by water. And prefabricated wall assemblies are perfect for quickly enclosing buildings. Buildings are getting taller, and these images here show that housing starts are predominantly now apartments, and they're focused in our largest cities where density is high and buildings become taller. It's just not practical to do a site-built wall assembly on a very tall building, and these prefabricated assemblies are much more practical. And then at the same time, our energy codes are getting more stringent. Classically, we would use window wall and curtain wall to enclose our high-rise buildings. These are at the limit of their performance right now, and these changing energy codes are kind of going to tip the industry towards prefabricated wall assemblies, which can achieve much higher performance than window wall and curtain wall. And finally, this is a kind of a illustration of how these market forces are coming together. This is a project in New York City where you have a severe housing shortage. The cost of housing is very high. And you've also got labor costs that are very high due to the requirement for unionized labor on most construction projects. It's a taller building and needs to be enclosed quickly because it's occupied. And all these forces kind of converge together to make it economically viable. There's also a code requirement in place here, which is the local law 97 in New York City, which requires existing buildings to meet energy targets. So all these pressures kind of are combining to make panelized wall systems viable. And all these pressures are present in a lot of our Canadian markets as well. So I guess the final point that I want to make is that the knowledge and the technology to build these systems is also here. So the time is ripe for prefabricated wall assemblies. I think we're going to be seeing them a lot more on our projects. So now I'll pass it to Christian. He's going to go through what these systems are and how to use them on a project.
Thanks, Paul. Hello. Hi, everyone. So today I'll be talking about our recent experiences with prefabricated facades. And in our experience, there are many types of prefabricated facades that are currently being used in conventional construction. If you think about a simple punched window that is pre-assembled in a shop and delivered to site, with increasing complexity, we have unitized curtain wall, precast, or insulated metal panels. So the idea of prefabrication isn't new. It's just the level of prefabrication is existing because of the market factors that Paul just talked about. So I'll be talking specifically about large format wall panels, or mega panels, as they're also called, and how their design and QA/QC can affect building performance. So here's a classic one that most should be familiar with. This is the aluminum window wall. It's made of aluminum frames that are punched and cut in the shop, glazed. Spandrels are insulated with insulated back pans. And it's very popular all over major cities in Canada. And the biggest reason for that is that it's a very cost-effective approach to enclose tall buildings. You don't need a large crew, just a couple of folks, some membrane sealant, and they can hand bomb these into place and quickly enclose the building envelope. They're relatively simple to manufacture, but they have a ceiling in terms of their thermal performance. There is lots of thermal bridging going on with these types of systems. All that aluminum framing basically leaks out all the heat from the building. And in our experience, these types of systems end up maxing out or at around R value of R8 effective once you start considering all those thermal bridges. And that effective R value just isn't cutting it anymore for newer energy codes that are coming out. So energy codes are moving towards requiring absolute metrics like the thermal energy demand intensity, or TEDI value. The TEDI is basically a value that describes the amount of heat required to, the amount of energy to heat a building. And that number is mostly dependent on the thermal performance of your facade. In the BC Energy Step Code for a residential building in Climate Zone 5, they are requiring now at the lowest tier to meet a TEDI value of 45. In the Toronto Green Standard version 4 for residential high-rise construction, you need to meet a TEDI value of 50. There are also different funding initiatives for development that have TEDI requirements. And there are also, of course, the voluntary high-performance standards like ZCB, Zero Carbon Building Standard, and Passive House. And in our experience, when you're looking at a high-rise residential building that needs to meet a TEDI value of 50, you essentially need to provide an effective R value of R10 for your walls, which window wall typically cannot achieve. BC Housing published this Energy Step Code design guide that provides some options on how to achieve those higher R values for tall buildings. They include cast-in-place concrete walls, insulated concrete precast panels, and steel stud with exterior insulation. The challenge with these options is that they require a lot of exterior access to the building during construction, which for a high-rise is a major logistical and cost factor. You can prefabricate steel stud walls with sometimes with membrane and cladding, but they're generally very heavy and require tower cranes to install. And for high-rise construction, crane time is a very important factor. This is why many manufacturers have started to develop or have developed large format panelized walls, sometimes called mega panels, because they are very large. They can extend to about 30 feet long or multiple stories high. Basically, the limit on the dimensions of the panel is what you're legally allowed to put on the road and truck to site, which is around 10 feet for one of the dimensions of the panel. These are newer types of systems that we're seeing, but they're based on a tried and true technology. They mostly use the unitized curtain wall details for panel joints, and they can achieve much higher thermal performances, as we'll see. So excuse the rough sketch here, but a lot of these systems are under NDA for their transition details. But they're, like I said, they mostly rely on unitized curtain wall details, such as male and female coupling mullions and chicken head stack joints. They require minimum site installation, basically only where these stack joints come together. You have to seal on site. And the great thing about them is that you can install an exterior insulated rain screen wall to a tall building without needing much exterior access. And that allows you to use thermally broken cladding supports and continuous insulation. And for that reason, these panels can achieve R values of R30 and above. Now, these can get fairly heavy, and so a tower crane still might be needed. And that is why some manufacturers have also developed what we can call medium format panelized walls that still use the same type of gasketed unitized curtain wall details at panel connections, but they're smaller, so they can be at times hand installed depending on the weight, or with the use of slap mounted mini cranes or spider cranes, that you can see in the image here. These panels can achieve R values of up to R20 in our experience. So when you start considering using these panels in your projects, you need to start with the right system early on in design. Now, these are newer systems, so many people aren't familiar with them. And as Paul mentioned, they are now starting to be used in deep retrofit projects. So trying to improve the thermal performance of existing buildings, specifically with overcladding, with an overcladding approach. So that is taking a prefab panel and hanging it onto an existing wall and increasing the thermal performance significantly. This approach has been a topic of a lot of research in the decarbonization space, And now we're seeing how it's actually being implemented. But like I said, these systems are fairly new, and many designers aren't familiar with them. So WSP worked with the Atmospheric Fund, TAF, which is a nonprofit retrofit accelerator in Ontario, to study these systems in the local market and pre-qualify them for use in retrofit projects. We came up with a list of panelized system technical performance requirements. So mostly they focused on the envelope performance, so thermal performance R values, air and water tightness, but also whether they're able to integrate window systems, lots of other panel attributes like embodied carbon, the range of panel sizes that manufacturers can provide, and how applicable they are to retrofit projects where your existing walls might be or will be not plumb, and how they can tolerate that those dimensions. In the end, the intent of that project was to produce a list of pre-qualified systems that building owners can use in their upcoming retrofit projects. And to date, we've pre-qualified four pre-assembled panelized systems, which are more geared towards Part 9 construction. They're mostly combustible wood frame panels, and 3 pre-engineered panelized systems, which are more applicable to Part 3 buildings. And if you want more information on this, you can go to the TAF website where this roster and our report is found. So similarly, in new construction, we need to identify the limitations and the constraints of the panelized system that is being considered as the basis of design. For us, that typically looks like establishing the effective thermal performance of the facade through preliminary design energy models, so that we get an effective R value and window U value. Depending on where the design is at that stage, we look at floor heights and suite layouts to see where the vision glass needs to go and where the opaque panels need to go. And ideally, the general contractor is part of the team at this point, so they can provide input on whether there are specific site constraints, like we need to be able to fit these panels in a construction hoist, for example. After that, then we can run a parametric analysis to optimize the panel sizes. So this is a model that we did in Rhino, and using our Grasshopper workflow, we can in real time toggle the dimensions of the panels, the clear field thermal transmittances, the R values, the thermal bridging psi values, and in real time in the box on the bottom left, you can see the effective R values changing as we optimize the design, keeping in mind the architectural intent of the project. So in order to implement these types of systems in your project, you need to keep in mind there might be additional risks with this kind of prefabrication. With, for example, unitized wall, you have aluminum frames, glazing, gaskets, and sealants that need to be reviewed in the shop. But once you start moving to large format panelized walls, you're starting to add sheathing membranes, cladding clips, subgirds, and cladding. That all will be happening off-site. So there's a lot more attention that needs to be paid to the plant QA/QC. So typically, we go to the plant and we review every aspect of the assembly process. Depending on the project and the system being used, the critical joints may be tested in the lab or in the field or both. The QA/QC plan also needs to include how these panels are transported and stored on site. So the image on the left that you see there is an example of a large format wall panel that had to be trucked without the insulation and cladding on because it just wouldn't fit on the truck. It was then stored on site for an extended period of time. And the white membrane that you see behind those cladding clips is actually a Tremco ExoAir membrane, but you probably can't tell because it was exposed to UV for so long, it needed to be completely replaced. Similarly, once these panels are installed, we need to start reviewing how they come together. Any prefabricated system will still include some level of site work and in terms of connecting the panels together. With unitized curtain wall type based systems, we're looking to see how those stack joints are joined together and sealed, for example. And typically we will, as part of the installation QA/QC, we will run a water and air leakage test on site. So to summarize, there is lots of prefabrication already inherent in conventional construction. We need to keep in mind that prefabrication is not a new topic. It is really the level of prefabrication that is changing. And the reason why it's changing is because of all the market drivers that Paul covered. The development of these large format panelized systems are largely based on understood technologies like the unitized curtain wall transitions. And so they are new but understood and well tried and true details. It is important to understand what kind of panel you're using early on in your design so that you understand what constraints come along with it and how that will impact your architectural design of the facade. And understand that there may be additional risks involved with this high level of prefabrication that need to be managed with a well thought out QA/QC program. That's it. Thank you.
Thanks so much. I actually wanted to acknowledge that you mentioned the labor shortage, because I think that's such an important piece of the ecosystem that we're all in, to be thinking about that and how, as engineers and architects, there are things you can do that might have a positive impact on the labor shortage piece. So I thought that was great that you mentioned that. Thanks. And also learned something about the risks of modular, that some of those things I did not know. So next, we have sustainability from every angle in the building envelope. So please welcome Jordi, whose last name I'm so afraid I'm going to butcher that I'm not going to say it.
It's always butchered, so I accept everything.
How do you say it?
The French pronunciation would be Marasse. You could say Marasse. Marasse, okay. It's all fine.
Jordi Marasse.
Hello, everyone. As mentioned, I'm Jordi Marasse. I'm Project Consulting Director for Rayners North America. We're going to speak to you today about sustainability, largely kind of asking the question, what makes a sustainable building to you? First, I'll take a few slides to briefly explain about who is Rayners in case you're not familiar. The first thing that we like to emphasize about our company is that we are a family business. Rayners is the last name. We were founded 60 years ago by the man in the top photo, Jan Rayners. Company's owned nowadays by the 5 Rayners buildings that you see in the bottom photo, 20% each. Company's managed by a board of directors, which consists of the 5 Rayners siblings and 5 external parties who help to keep things nice and objective. We're a company with global presence, specializing on local expertise. So you see our campus, our headquarters in Duvel, Belgium, indicated on the map. We have sales in more than 80 countries globally and a legal on-the-ground presence in more than 40. You see a bit the evolution or growth of the company, starting from around the 2010 mark. That's the point at which we took the decision to go global, and probably when you started to see and notice Rayners products popping up into the North American market. That's also around the time that I got involved with the products, back then as an installer, moving from there to a fabricator, and then to Rayners itself. As of last year, we're 1.1 billion Canadian annual turnover and approximately 2,700 employees worldwide. The turnover is generated by variable revenue streams, but primarily the products. We do offer a wide range of products consisting of windows, doors, sliding and folding systems, facades, stick curtain wall, unitized, custom solutions for projects, complementary solutions such as sunshades, building automation systems for smart buildings, so on and so forth. I like to say that our standard products are like living organisms, if you want. For example, the CW50 stick facade curtain wall product, it's going to be, the catalog will be updated maybe 5 to 10 times per year, constantly canceling old articles, launching new ones, making modifications, refinements as we learn from market to market, project to project, decade to decade even. Of course, we're in the construction industry. It's a highly regulated field. Everything we do has to be constantly tested, validated, proven. One of the nice things about being a family company is you can take a decision to say, okay, we want to work, for example, with our partners, UL and Intertech, for testing locally, but we don't want to rely upon them for their capacity or lack thereof. So we're going to invest in our own. We have now the world's largest research and testing center in the private sector of aluminum worldwide. Our end client, if you want, are the fabricators, or what you might know as the glazing contractors. We supply to them, of course, the systems, windows, doors, profiles, finishing, rolling, etc. We also provide the digital tools, software, CNC machine equipment in the shop, marketing, showroom, so on and so forth. We really try to provide the entire ecosystem around production of the Rayners product. And we extend that partnership out to basically all of the project stakeholders in the construction industry, inclusive of architects, developers, engineers, etc. This is actually what my department is specifically focused on. We offer many digital tools and things like that for you. Also, a unique shared virtual reality experience where you can assess your project designs in one-to-one scale and perspective in our VR cave, which is free. Speaking a bit on our mission statement, and I think that this kind of directly ties into the sustainability topic. Our mission is, together we improve the living and work environment of people now and for generations to come. We blend design, technology, and digitalization in innovative solutions that add value and inspire our partners to create sustainable buildings. And our motto is together for better. I want to focus on one specific sentence within that mission statement, which touches on 2 points that I think are very important to the sustainability conversation. Those are together. We are all part of a value chain in the construction industry. When it comes to sustainability, we all have our own part to play. And for generations to come, like I mentioned, we're a family-based company. Companies directed by Rayners siblings who foresee that their children's grandchildren will someday be the directors of Rayners Aluminum too. So building a company that's always forward-thinking, sustainable, and built to last for the next generations is core to the DNA of Rayners. I'm going to return to this map for just a brief moment so we can kind of highlight my problem, if you want. That's the North American market. So we work for Rayners North America. My team, we're focused on supporting the markets of Canada, US, and Mexico. This is an unfathomable physical distance, and it's an incredibly complex market to support. And one of the large reasons for that is that we have so many different climate zones, so many different local particularities and specificities. For example, in Vancouver, we see a big push for the operational carbon, focusing on Passive House. We see a significant growth there. On Miami, for example, the focus is on hurricane-rated products and impact resistance, so on. Winnipeg, you have negative 50-degree weathers, so it's about coming up with modularity in facades so that you can prefabricate and install in the 2 months that you have to enclose the building, basically. Southwest, it's all about ultra minimalism, etc. It's our goal as a local team to get to these markets, to understand the pulse of these markets, who are the players, what's going on, how can we play a part. And really what we want to do is be a proponent of change and push these markets to consistently develop as well. And so, like I said, core to our DNA is the sustainability topic. We'd like to bring the sustainability topic, for example, to Calgary, the oil capital of Canada. And we're told pretty consistently by our partners and stakeholders that, okay, you can talk about the sustainability topic here, but unfortunately, nobody cares. And unfortunately, that's the reality. We do understand that there is an economic equation. We do understand that sustainability in the end needs to be driven on a regulation level, needs to be mandatory, or people won't do it. But for me, it's a little bit disheartening in a way, because at the end, I think we can all find a reason why we should care about sustainability. What is my reason? This is it. This is my daughter. She's about to be 8 years old. And this is really what the sustainability conversation is all about, right? It's about acting now so that we can have an impact on the people that stand to inherit this earth from us, so that they can enjoy the same beauty and opportunity that we did. And don't get me wrong, things are changing. It's changing a little bit slowly, but for example, in Toronto, there's a big push to decarbonize existing building stock by retrofitting for net zero. So we're contributing a little bit on that level. Christian, WSP, is responsible for this project. This is another project, BCIT, Tall Timber Student Housing. I see actually Brian is in the crowd somewhere. I posted the RDH LinkedIn post recently announcing this building achieved the zero carbon building standard. However, with all of these initiatives, the sustainability topic still looms over our heads like a massive tidal wave. And this poor guy in the photo, this is you as a company. You have two choices. One, do nothing, get swallowed by the wave. Or two, take the energy of the wave and allow it to propel yourself forward. We need to acknowledge here, everybody in this room, that we play a part in an industry that has a tremendous impact on the planet. Buildings use 50% of the world's resources, create 35% of all waste, produce 39% of all CO2, and consume 50% of all energy. This is loose approximated data, but approximately 80% of the North American building stock is currently considered to be energy inefficient, which is driving two major revolutions. Number one, sustainability in the circular economy, and number two, the energy efficiency and renovation, which is really speaking to the dichotomy of embodied carbon versus operational carbon. What goes into the embodied carbon, or the blue block? Yeah, a bunch of things: material reuse and recycling, designing for disassembly, circular supply chain management, waste minimalization, etc. What goes into the operational carbon topic? I think you guys are well familiar. It's about phasing out fossil fuel heating systems, integrating renewable energy solutions to the buildings, and accelerating building renovation. What we want to emphasize, though, please don't take a tunnel vision view on the sustainability topic. We do see that this is a consistent issue within the industry that's actually a barrier to progress, let's say. And I don't mean to pick on anybody in the room, but for example, the fiberglass window. This is for sure an excellent system when it comes to cold climate thermal physics. Absolutely. It's probably the best solution. There's no thermal bridging, etc. It definitely contributes to the operational carbon aspect. But this is a non-recyclable material. So all of these green windows and all of these green buildings, if they're doomed to the landfill, how sustainable is it? So we again ask, what really makes a building sustainable to you? Is it the energy efficiency of the facade? Is it extreme weather resilience to keep up with the climate changes? Is it responsible sourcing of low carbon building materials? I would even throw in affordability, for example. Sustainability can't be something that is only available to the rich few. It has to be accessible to everybody, or they stand to get left behind. And this is exactly why it's important to see things from every angle. The industry has largely been focused in the past on reducing the operational carbon on buildings. This is the biggest lever we have to pull to make the biggest impact. It's the lowest hanging fruit, if you want to say it like that. But what we see is that by reducing the operational carbon, decreasing the size of that green block. We're using more materials. Triple glass, for example, that third pane of glass, it has an intense embodied carbon impact. Double skin facades, aluminum, steel, glass components, etc. And we see that the blue block is rising. And the focus now becomes, how can we reduce the size of that blue block? And in reality, the optimal solution is always a trade-off between the two. Operational embodied carbon, they are in direct conflict. You have additional insulation, glass, etc. into the walls to make the building perform better. You have to calculate this. How can we reduce the blue block? Well, it's simple, right? Just add recycled aluminum content, you have instant decarbonization. Unfortunately, it's not the reality. You see here this blue circle. This is the total global aluminum demand. You see here the small circle basically shows you that 36% of that global aluminum demand can be met with recycled aluminum content, which essentially means that more than 63% of total aluminum demand must still come from primary extrusion sources. There's a finite amount of recycled aluminum content in the world. You can, as a product manufacturer, claim that your system is 90% recycled aluminum content. That's great, but monopolizing that supply, meaning your number going down while somebody else's goes up, it's not actually helping the issue holistically. It's a zero-sum game. So we like to think big picture with integrity and 360 degrees to the sustainability topic. I'm going to talk about a few points which, I'll have to go quickly because we can't go through everything in thorough detail, but starting from design to recyclability of the building. Eco-design, for example, what is it? It's attention to weight and material use, rationalization of components. This is something that we're extremely busy with these days. We're optimizing wall thicknesses to adjust for actual loads that the systems are expected to see to lower the embodied carbon of the products. We're optimizing our fittings, fasteners, accessories as much as possible to reuse them across systems, reuse them within systems. We're also getting much smarter about designing systems to reutilize aluminum half scales, thermal strips in smart ways to come up with different systems from the same components, if you'd like to say. We're also designing for assembly, disassembly, and reuse. WSP just spoke pretty thoroughly about the prefabrication aspect. I think another good example is that BCIT tall timber student housing project. This was a mass timber construction in Vancouver, rainy Vancouver. We don't want the mass timber exposed long to the water. How can we address that? You have a prefabricated system, modular, built in the workshop, controlled environment that's ready to be delivered on site to follow the mass timber in lockstep. Energy efficiency, of course, we can support you there. We have the certified low energy solutions, passive house certified components, master line 10, 8, concept wall 50, 60, slim wall 35. We also have non-certified systems achieving passive house levels, project specifically, Highfinity, master patio, so on. And we recently launched the Timber Wall 50. I think this product, it's an Aluwan timber facade system. It's going to, in my opinion, bring in a benefit on the embodied carbon level, utilizing timber instead of aluminum to the inside. And on the operational carbon front, it's going to help as well, as we expect this to be a passive house certified system as well once certification is complete. We're also designing to maximize solar gains as much as possible by using ultra-minimalistic systems, Slimline 38, Highfinity, Slim Wall 35, etc. And we're designing for extreme weather resilience as much as possible. We need to recognize that extreme weather is the new normal. We're seeing it more and more on a global scale, also locally. We will see more floods, more earthquakes, more hurricanes. It's coming. The big push within the North American market right now is on the hurricane-rated systems. We see a huge demand, basically all of the south and east of North American market seeking Miami-Dade certified products and also Florida Building Code WIDS 3. To understand the scale of the demand for these, this is basically everywhere the wind zone 3 applies. It's essentially the entire south and east board of North America. We're designing for cradle to cradle. If you want to get a quick check on product disassembly, reuse, recycling capability, etc., please ask for the cradle to cradle certifications. Basically, this measures the recyclability of products and the ability to reuse them. We have 15 such certified products. And of course, we're working on lowering the carbon of our building materials, primarily aluminum and the thermal breaks. The reality is, aluminum is one of the most circular materials on Earth. The average lifespan of aluminum is greater than 50 years. 75% of all aluminum ever made is still in circulation, and 95% of aluminum gets recycled. We do offer something like 50% on average recycled aluminum content across our product mix, but like I alluded to, we don't think that this solves the problem. We also need to focus on lower primary carbon aluminum. Right now our impact is at about 3.31 CO2 per kg. To put that number into context, here you see the global average, 15.2 CO2 per kg, the European average 10.48, Rayner's 3.31. So you could say we're already doing a pretty good job, but it's always about how can we get lower and lower and lower. By 2030, we expect to be at 2.81 CO2 per kg per our Science-Based Targets Initiative. Thermal break material, I'll speak very quickly on, but more than 70% of our thermal break material is considered low carbon and or recyclable. We also have tools now that can help you to calculate the embodied carbon of your project-specific design with your specific product mix. So if you want to understand what is the embodied carbon impact of our material as it pertains to your project, we can support you with this. And responsible sourcing, I think this is a big one too. We have had historically a decent amount of traceability, let's say from the moment that the aluminum was procured on London Metal Exchange to the moment that it's installed on the building. What we didn't have was visibility into what happened before that. How was the bauxite extraction done? Where did the bauxite come from? Who mined it? For example, was this mined by slaves? Because that's not very sustainable either. So we joined the Aluminum Stewardship Initiative, which is really pushing to create a complete visibility, traceability on the entire scope of aluminum from extraction to recycling, focusing on human rights, etc. Traceability of information. Guys, please ask for EPDs. Sustainability is no longer a topic that needs to be adjudicated on gut feel. We do have data, we have documentation, information. Please request it. We also offer Digitrace. This is a digital passport on products. Basically, it allows end user to have complete traceability of their products all the way back to its origins. And I put up this slide last because I think it really helps to drive home the point and the issue that we're facing. What started this massive tidal wave? Well, it was the Paris Climate Agreement, basically in 2015. All the member states got together. They said we need to decarbonize by 2030. We need to get net zero before 2050. But they also said we can't rely only on the countries, the governments themselves to do this. We also need to incentivize the private sector. How are we going to do that? We introduced SBTI. SBTI, Science-Based Targets Initiative, basically follows the Paris Climate Agreement in lockstep, but it's a voluntary corporate framework around it. Right now, where they show the expected target, 590 kilograms CO2 per square meter, we see based on LCA analysis that we're more or less in that target. But what we also see in comparing also with LCA done by University of Toronto, LCA done by various Canadian real estate organizations is that our best current concrete and timber buildings get us to about 2030 on this scale. We don't seem to have many solutions for after that. So we all need to play our part in the sustainability topic together for better. Thank you.
Thanks, Jordi. So I have to say that presentation pulled at my heartstrings a little bit, talking about the fact that we're all in this together, recognizing the global community that our industry now operates in, the importance of sustainability. So yeah, I really appreciate those things being mentioned because I think they're so important. And it's not just because I go to Green Drinks every month. And if you know, you know. Next, we have a couple of architects coming up here. Kevin Bridgman, partner with KPMB. Oh, they're already here. Look at you, you're so efficient. And Tyler Hall, associate with KPMB, talking about the Workland Center transformation, which is also an important one to Colliers.
Thank you for inviting us here to Calgary to present an incredibly important project for us as a practice, but also for your city. Slight spoiler alert, this is what we're going to be talking about as the end result. But Tyler and I wanted to give you an insight into the why. Why does it look this way? A building like this gives us a chance to tell a story. A public building, a civic building can tell a story. It's very different than the facades of an elegant office tower or residential project. We're not here to the non-architects in the room, we're not here to make your lives difficult. We do love to challenge you, but this may give you some insight as to why are these architects drawing this. But I should credit, the industry, the trades, the fabrication, the suppliers. We do love working alongside you. I realize I don't have the flicker. Is there a flicker here? Okay. First, credits, because this project is a collaboration. The incredible team at CMLC here in Calgary, Alex Sarian and his team. I got it. I think we're good.
Your microphone is off, so you have to stay on this one.
I have to stay on this one. Oh, up to you.
If you give me a sec.
Sure.
Hopefully. You're muted. Yes. No, you're not.
That better? Okay. Hopefully you heard all of that. The team at Workland Center, Tyler and I are with KPMB. A really important collaborator on our project team is Tawau Architects here in Calgary. They're an Indigenous design firm led by Wanda Della Costa. We'll touch on that in a moment. And an incredible team. Some of our friends from Hindle Architects are here in the audience. Another amazing design practice here in Calgary. We'll go quickly just to orient you where this is. Hopefully all of you have seen the hoarding, you've seen the cranes. We were walking around on some of the first concrete pours yesterday. It could not be more central to your city on Stephen Avenue. We have Stephen Avenue to the south of our site, the C train to the north, the municipal building looks right onto the building site. It's adjacent to Olympic Plaza, beloved open space here in Calgary. And of course, your incredible library on the other side. So it's really on this incredibly public thoroughfare. And as a design challenge, it really has no front. It's a multi-sided site. People come at it from every direction. There's no room to hide. And lastly, the site to the south, labeled B there, that's the existing Arts Commons site built in the 80s. And so this site sets up a real transformation for your city, for the Calgarians here, and allows Workland Center to evolve from a kind of landlocked building, the red brick building in the center there between the two heritage projects, to a campus and really evolve as an organization for the arts. And we came on board before there was a plaza design and before there was even a plaza team. But we knew that with our expansion footprint there beside Teatro, we knew that whatever we did had to embrace that public plaza. It was going to be the backdrop to all of the civic events and civic excitement that was happening on that site. So a lot of opportunity, but also a lot of pressure. But as I mentioned, today we wanted to talk about the story behind the design, because that, for us, the facade is a continuation of the concept of the building. Typically, when you start with a project, you start to look at this is a theater. There's two new theaters on this site. So typically you would start looking at other theaters, as precedents as you start to gain design momentum. But with Tawau and Wanda on our team, we started somewhere completely different, not someplace we've ever started before. We've done other projects with indigeneity, but this was another level of indigenous consultation and embedded indigenous design input. So we didn't look at those theater precedents. We instead asked ourselves, and Wanda had a great term, they like to be a disruptor to that design process. So we looked at how do we root the craft of the building, the spirit of the building, how do we connect it to land? How are those buildings built and how do they connect to place? And that began a really amazing period of research led by Tawau's team. And we looked across Canada at the earliest buildings where people came together. How did those structures feel? How did they sit on the land? How did they draw people in? And that led to a real kind of incredible design starting point for us. We learned about ways cladding can be layered with elegant materials, rugged materials, exposed structure, a really simple way to bend and make shapes and make curves using those natural materials. And we moved away from performing arts terminology and we started to refer to this place as a lodge. And that spirit of coming to a campfire to share and tell stories, that's what a performing arts building can be. And so that kind of activating a kind of more active stance, a lodge is more active and community-based versus maybe if you say lobby, that's somewhere where you go to wait for something to happen. And that research led to 6 key design drivers. Again, we didn't have a design at this point. We were kind of setting up the why for us. It sat on axis with City Hall. There's all kinds of important discussions and dialogues that can happen between city politics, provincial politics, and the arts community and the city and the civic. That southeast corner was a key orientation point. The pink circle in the corner there, it can connect up to the sky. Sky connections are very important to the Indigenous community. It has to connect to the land of the plaza and the open space. And so again, before we even had a design, we knew the spirit of what we wanted to achieve as a team. We wanted a building that could relate to sunlight, but also be a beacon in the evening as people come to the theater and are drawn into maybe to the arts for the first time. I think the arts can suffer a challenge where people feel it's not for them. And so for us to make a building, and for those of you that have heard Alex Sarian speak so eloquently about the power of the arts and community, you'll know the kind of leadership we were getting. So as we were situating 2 very large boxes, the pink is the 1,000-seat hall. There's also a 200-seat kind of black box theater. The scheme started to form, and we were using all of that research to drive these design decisions. And so the yellow is kind of how the public flows around the site. And again, leaning on all of that research, how can the structure be really rugged and exposed and textural and feel handmade and feel crafted and feel familiar but new. And so just as we still sketch by hand, contrary to maybe popular belief, we knew that southeast corner had to be this lantern. And so leading into, well, what does this have to do with facades? We were setting up an opportunity for ourselves to design a facade that needed daylight to come in, and then in the evening for light to glow outwards, to be that kind of beacon, that sacred fire, that campfire glow that draws people in together. And you might say that that's a lot to ask for a facade, but that's what we were setting ourselves up for. And that's what we were striving to achieve, so that when people come to the building, we want them to feel something. We want them to feel those ideas. We were also studying the building formally. It's a big program to put on a space like that, but we really wanted the building to kind of lean back away from the plaza, defer to the trees. How can we get trees as close to the building as possible? We also rely on in-house data tools, and we studied how the forms, when you start to lean and sculpt the corners and soften the edges, how is the light going to hit that facade, and when and where are the opportunities for us to then start to make moments of transparent glazing. I should say it was never going to be an all-glass building. You see a lot of all-glass buildings. We had performance metrics to hit. I'm glad some of the previous speakers touched on sustainability. We do have sustainable targets to hit. Performing arts, cultural projects in general, you have to take care of them. This is a long-term investment, and so the energy costs to keep a building like that going, are way heavily on our minds as we're designing that facade. But as I pass off to Tyler, who's going to walk you through kind of technically how we, and again, continuing the concept of connecting to ground and place, you can see how the kind of design section starts to come into focus here, and how that public space, the curving canted space around the outside, is that kind of public lodge around these very technical theater boxes where all that the storytelling is taking place. I'll pass to Tyler.
Great, thanks very much, Kevin. Click this to advance. Yeah. Great, thanks. So I think Kevin's done a really compelling job of making us understand why the building is the way it is. I think what I'm going to try to do is walk you through the process that we took for rationalizing how we approached designing a facade for, that's curved and sloping. So one of the first things that we did is Kevin and I, with the help of a student, we designed a physical model. And again, this is something that we still do in-house, maybe surprising, but it was a great tool for us to understand and test our intuitions, right? So we were looking at the flat portions of this, which were fairly easy to figure out, but then as we put the model together on the curves, there was geometric issues, problems that we were confronted with early on, and so there was an early act of making even in this kind of maquette process. As we were going through that, we were starting to think of the look and the feel and the fabrication of the whole thing. So we were riffing on this fairly simple idea of a language of fins that was fastened through brackets to an aluminum backer panel. So, I mean, building off what Jordi just said, we chose aluminum purposefully thinking about the end of life use of this material. We purposefully avoided the use of ACM so that at the, when this building's decommissioned, the facade could be taken off, carefully recycled and put back into the supply stream. But back to the form, we were trying to achieve this kind of handmade, bespoke texture to the building that spoke of the craft of the indigenous precedents that Kevin had mentioned, and trying to find a way to do that in a contemporary language that was affordable and logical and could go up quickly. So we played with a series of battens of varying shapes and forms, and through playing with their patterning, their density, their and the way that light interacts with them and the way that you perceive them as a person as you walk through the site, you can kind of embody the building with a lot of life and dynamism and activity. We went back to making after that first process. So early on, this was in the DD phase still, we were working with a fabricator to build a mock-up. So this is a sheet of drawings that we sent, and it describes some of the early assumptions. It made us commit to things. At the top there in the middle, you can see where we landed on for the fin shapes. So they're just kind of a piece of break-shaped aluminum. We provide a little routed edge so we get a very sharp corner. They have three different profiles. One is thin, one is kind of mid, and one is wider. And through their patterning, you can create all sorts of different effects on the facade. this was also an opportunity to address the horizontal members. So our facade was broken up into kind of 4 bands. We committed to the geometry for the horizontal banding there. We knew that it would have to be in a slope to allow for drainage, give it a drip edge. You know, it also serves the purpose of not allowing birds to roost on it. And this was also a point where we were starting to think about fastening, fabrication, how the facade is tied back to the building structure. Part of that process was thinking about, you know, committing to the look and feel of the building. So again, going back to what Kevin said at the beginning, we wanted the building to feel very honestly rooted in its place, and we wanted it to reflect the historical and present culture of the city. So we looked to the landscapes surrounding Calgary for inspiration, for texture and on texture and coloration. So like whether it's the Rocky Mountains, the way that shadow and light falls over them, the color of the green, or the Badlands, or even just the coloration, the natural warm tones of the agricultural landscapes that surround the city. This is where the inspiration for the look of the building came from. So if you can see that in the top left drawing there, an early study of just kind of how we're using this eyedropper technique to draw colors from the natural world. I'm showing 5 colors there. We probably looked at 50 or more at the beginning. We narrowed it down to the 2 in the bottom left drawing. So we've got a dark green backdrop to this building that references the colors of the shadows of the boreal forest, and then a more natural wood-toned speckle paint that recalls kind of natural building materials. It's based loosely on the coloration of the graining of cedar. So on the right-hand side, you can see a bit more of our process. We first started off with making an in-house 3D model where we tested colors. And then in the back is where you see the fabricated mock-up with that custom paint on it. And this kind of gave us a really good idea of what the facade of the building might look like. So you can see the way that the angles of those fins catch the light in different ways. So with using 2 tones of paint, we're actually able to achieve kind of 6 ranges of color. And then on the backdrop, the shadowing differs depending on the density of the fins around it. So another way that we rationalized the facade of the building was to relate it to the program of what we're looking at. So in the middle here, you see the theaters in the dark yellow, and the lighter yellow around it is our public space of the building. So these are kind of highly animated zones where we really wanted to keep where we wanted the life of the lodge to bleed out into the park and onto Stephen Avenue beside it. You can see in the upper volume moments of punctuation where we provide large windows at bars and at the event spaces for people to gather and get views out to Stephen Avenue and the plaza beyond. And then the rest of the volume is treated quite in a different way. So, sorry, Kevin, could you help me step in for a second?
Pointing out, we created a series of moments in the facade because we wanted that form to feel continuous. And yet what you're seeing here, the only curved components in a view like this are the curved horizontals. So of course, we're always up against budgets, and teams like yourselves come and look at this and have to bid on this and put a number to this. So we really needed to figure out a way to make sure that this vision of a curved building with components that ran in front of glass could actually be built and get it delivered on budget. And so you can click to the next, Tyler.
I mean, one other thing that I might point out here, thank you, Kevin.
Yeah, no problem.
So like we were using these horizontal datums to really define the curvature of the building. So like Kevin said, they move along with the form of the building and define the reading of it. Between it, we've got the bands of the vertical cladding, which actually act as a screen in front of the windows and provide amazing opportunities for filtered light to go into the lobby and also at night to be filtered out in a similarly diffuse way, creating that kind of lantern effect that Kevin had talked about earlier. Along the north and the west facades of the building, we don't have the need for as much fenestration. So these are opportunities to use our cladding system to create a very clean, sculpted form. And like Kevin said, this is all kind of an attempt to make this building not have a backside. We want it to be really great from any direction that you see it. Another way that we were trying to rationalize the geometry was to we were almost anticipating fabrication with the shaping of the floor plates of the building. So yes, it's sloping, but what we can do is we can create kind of very clean geometries out of using straight lines and arcs. And whenever possible, we were sharing the center point of those arcs between the floor plates. So the center point of these kind of conical geometries is always the same. It helped us just move through the rationalization and the fabrication process of this in kind of the most clean way that we could imagine. So because of those geometries, you can define a lot of the building using typical details. So this is a sheet that describes what happens at a solid wall. We can describe the parapet condition, we can describe the base, what happens at those horizontals. And then at the top, we map out the shape and geometries of the fins. At windows, we have another sheet of typicals where we have the challenge of we have to provide a structural support that ties back to the building, which allows the facade to hold itself together as it kind of carries over and flies over as a screen. And then there are these moments where the building delaminates from itself, which required extra attention, but through kind of careful detailing and study, we were able to figure out. And then bringing us back to the south east corner of the building, which is kind of the focal point that was highlighted in the beginning, we've got this oculus condition connecting, you're at ground, you got that big field of glazing in front of you, you can look up right to the Calgary sky. This was a particularly challenging geometry to figure out. It's cones, and then actually at the top is an elliptical thing going on, so it was amazing to try to work through, but well worthwhile, because in the end, the experience that you get, the kind of beacon that it becomes, the light that it brings, the life that it brings to Stephen Avenue and the plaza is, I think, kind of achieved through this strategy.
Yeah, and then lastly, now that there's a plaza design in place, which hopefully all of you have seen, all of that work and all of that thinking with our collaborative team and the leaders at CMLC, this soft, curving, gentle backdrop to all of the excitement that's going to be happening there, from skating to markets to concerts. It's really a powerful and kind of moving opportunity for us to contribute to your city like this. So we're incredibly proud to show this to you. And hopefully now when you see the building coming out of the ground, you'll know why these architects did what they did. And hopefully it kind of makes you feel something. So thank you.
Thank you so much. As someone who grew up in the city, I find this transformation truly amazing. And hearing, I know we talk about the art and science. I think that presentation showed how much there's art and there's science in this business. So thank you. It's time for networking. But before that, if you were a speaker in this first session, please come over to this side of the stage. And for the rest of you, go network. Have some coffee, snack. Come say hello. So let's talk about building enclosure design for wildfire resilience. And we have Brian Hubbs. Thank you.
All right. Thanks for coming out to see this. This was fairly new to me. I've been building buildings a long time, and I spend the vast majority of my time, like people in this room, probably working on non-combustible Part 5 buildings, iconic towers, museums, things like that. But then I go home at night, and I live and sleep in a Part 9 building in a forest fire zone. Right, really close to the wilderness. So this was interesting to me when we started to do a bit of research and get a bit of funding to look at this in more detail. And I promise you, if you live in a single-family home, like most of us probably do, you'll never be able to look at it the same again once I get done with this. So if you don't want to do a little bit of landscaping work, you might want to go get a sandwich and not watch this. So why do we care? People in this room, why do we care? Well, I care because RDH is all about making buildings better. And it doesn't matter why we make them better, as long as we're making them better. And I think everybody in this room watches enough social media to know that forest fire resilience is going to be a big topic moving forward. And literally, for people in this room, most people here are facade people. The last line of defense is our facade, is our enclosure. And it's a job to manage that. So we all care because we're passionate about building facades, and building facades are our last line of defense. So I made a new little logo up here for people in the room based on an old one that we all know. So when we talk about building enclosures, no different than the leaky condo days when I was here 30 years ago telling you about the problems we were having in BC with leaky condos. It's all the same culprits. It's all the same details, right? But we just have different loads. So the loads on a building for fire are how much fuel there is around the building. The loads on our building for the rest of the enclosure is where is it? Is it in a cold climate? Is it in a wet climate? Is it on a hill in Calgary? Right? Those are the ones that have the high loads. You need to design better enclosures. So I'm an enclosure engineer. I'm going to tackle this problem from an enclosure perspective. To do that, I need to teach a little bit about fire. Right? When we manage fire, we trickle down. There's forestry management. There's community forest management and maintenance. There's community level home and home landscaping that we need to do to control the fuel side of the equation. The resistance side is that last line of defense, number 4. Are we going to build things wildfire resistant or not? And right now we don't. A lot of buildings still going on that's not wildfire resistant. Here's 2 examples, right? Lytton in BC, Jasper in Alberta. So we know what happens when a wildfire gets into our communities. Once it's in our communities, it becomes structure-to-structure fires. Those are a much bigger problem to deal with than preventing it from getting into our communities. And these are catastrophic losses. So we want, there's always going to be forest fires, there's always going to be wildfires. We want to stop them from becoming catastrophic losses where cities disappear off the face of the earth. So how do buildings catch fire? Easy. 3 things. You got embers. These are the things from a forest fire far away that can travel in the wind, land on your roof, and set your home on fire if you don't have any kind of resilient construction. Radiant heat. That's when something big is burning near you. There's nothing touching. There's no flames. There's no embers. It's just getting super hot, and it combusts the thing beside it because the radiant heat gets too high. And then there's direct flame impingement. You got something on fire right beside your house. That's a whole other story. And that's often, the flames is often your structure-to-structure fire. So when we talk about a wildfire and a structure fire, right, wildfire is less intense and it's faster. So we're generally dealing with heat fluxes of 5 to 20 kilowatt hours per meter, 30 seconds to 5 minutes. That's how fast it takes for a low-level wildfire to run by. We can design for that easy. Once it becomes a structure fire, it's a different animal altogether. Heat flux intensity 30 to 50 kilowatts and duration of attack greater than 30 minutes, right? That's a whole other level of design. That's non-combustible construction, if you want to resist that. You can see here, this is the Paradise fire. You can see here, this community was lit by embers from a fire far away, well, not far away, but farther away. The community caught on fire and then singed the forest. You could see here, it didn't come in through the forest. It came in through embers, and the community singed those trees along the edges because it was so hot, right? So we want to stop the forest fire from getting into the community and starting it, even when it's not right beside it. What do our codes say? Codes are great. Let's fall back to the codes. They're good for seismic, wind, snow, radon. Great. 5,000 references in the code due to fire, mostly interior fires, part 5, that kind of thing. Exterior fire, there's 1 mention. There's 0 for wildfire, 0 for forest, 0 for wildland, and wild urban interface fires. Nothing. So we can't rely on the code. We have to develop some things that work and then put them in the code. And that's coming. That'll come. When we talk about structure fires, those are very well codified. We've got minimum distances between combustible dwellings and combustible things. We've got fire ratings. And all that design is based on a 10-minute fire department response time. In a forest fire situation where an entire community is on fire, you don't have a 10-minute response time anymore. And so even this doesn't work if your whole community is on fire. So we've got to stop the forest fire from getting in the community and burning house to house, because there's no 10-minute response time anymore. So the vast majority of wildfire disasters, the catastrophic losses, have been structure to structure spread after the forest fire has entered the community. When we look at loads, light grass to intense shrub fire is what we're talking about when we talk about resilience to catching fire due to the forest fire load. Crown fire, extreme fire, structural fire, those are all much bigger. They require, things like 1 hour fire separations, 1 hour fire ratings for wall assemblies. So when we look at a typical subdivision, we don't live in subdivisions where we have lots of space that we can clear around our structures because there's going to be neighbors. So we'll pick a building like this. This is a little tool we use internally that we developed just to look at the heat flux loads. So on this particular house, there's some trees, some shrubs. They're far enough away from the forest where they're not going to ignite. So we clear out those trees, those shrubs. That red area is where you're going to catch your house on fire due to radiant and flame impingement. So we clean those up, we cut them down. We're good. Are we good? Can we just stop worrying? No, right? Well, what happens if your neighbor doesn't do that? If your neighbor doesn't do that and he catches on fire, your building's going down too. There's nothing you can do about it. There's nothing you can clear up in between those. So it's more than just you're going to do it on your buildings and I'm going to do it on my building. It's a community response if you're in a urban interface zone. So it's a weak leak thing, just like our building enclosure. All of our enclosure problems, things are going to travel through the weakest link. That's where you're going to see problems, interfaces. When it comes to fire, you can see this is one here where in A, fire hits the fence. Fence burns to the house, destroys that first house. Fire starts at B because the forest is on fire beside B. It goes through the fence and burns down 2 more houses from B and C. Firefighters get there and action this damaged but defended building by kicking down the fence. Right? The fence is the wick that's joining all the buildings. So weakest link. So we look at the weakest links. Right? These are all the same pictures I showed you 30 years ago when I came to talk about leaky condos in BC, except they're now burnt instead of moldy. But they're all the same culprits, right? So what we thought is let's come up with a new barrier. We already know we design our buildings with an air barrier, with a moisture barrier, with a thermal barrier, a sound barrier, right? A radon barrier. Let's talk about a wildfire resistant barrier. And we can't use WRB because we already use that for water, so we're going to call it a WFRB. Okay? And we're going to look at connecting that around the building between all of our resilient components so that the whole system works. So the Institute for Catastrophic Loss Reduction has just published some new industry guidance, which we helped them create. Checklists for your property and your building itself. Good, better, best. Good is better than what's done now, but it's not going to be enough. So where you really want to live is in those green areas where you want to have best construction measures and best home ignition zone. That's where we want to design for. But what we're talking about is repairing a lot of the buildings or upgrading a lot of the buildings that are currently in use, and there are practical limitations to that, cost being the big one. They're not just 2D details. Like everything, fire doesn't care if it's in 2D or 3D, it's going to find the weakest link. So you need to draw isometric and 3D details and figure out how you're going to do all those complicated interfaces where if you have a problem, it's usually going to be one of those, right? So develop some good guidance for the industry and then test it. Here's an example here of very high risk combustible proximity landscaping, right? Not much you're going to be able to do here except for get rid of that. right? Because these buildings are not super robust when it comes to not burning down. They contain combustible materials. Right, so when you talk about good landscaping practice, this is all fire smart stuff. It's well documented, it's all good advice. Minimum, you clear the bush around your building, right? That's good. That's not enough. Right, best, when you talk about best, there's a whole pile of things to do. This is all in the guide. You can also get in touch with me if you want a longer presentation, which actually lays out all this stuff. But you're looking at that extended zone around. Now, if you look at that, that's going to incorporate your neighbors and keep doing that, right, in a normal subdivision. And then get rid of all your combustible fencing, because that's your wick. That's your weakest link. Stop it and have non-combustible things between it and your home. You can see here, these fence posts are burnt out. You know, very close to burning that house down. So when we look now, that's it for landscaping. Let's now focus on what we're all interested in this room, which is facades and building enclosures. So we talk about all these details are the things that are going to matter and make or break your system. These are all the exact same details that we talked about during the leaky condo crisis, because water got in and made things bad. The only difference is, instead of where is the building and how much rain does it get and how cold is it, it's how much fuel is around it. And you're still looking at those same details for resisting embers and resisting heat and being fire resistant. So for roofs, key requirement, right? Get all the combustible things off your roof. So do some roof maintenance. A lot of fires start by stuff in the gutters catching on fire. So gutter guards. Don't use combustible roofing. That's a pretty clear one. This is Jasper. Jasper had a covenant for a long time. You must use a cedar shake roof, right? There's a cedar shake roof. There's a metal roof. Don't need to tell you anything more. So for good practices, use a Class A rated roof. That only makes sense. For best practices, use a Class A rated roof and do all the other things you need to do to tie it into your walls and your windows and your attic ventilation. You need to have attic ventilation, right? Otherwise your roof rots. You got to do it in a way that doesn't let embers get in. And we show that. We have details that we've put on paper, but we've also tested. So this is a code-compliant soffit vent. That's what happens when a code-compliant soffit vent has a bush fire next to it. Goes right in your attic, burns your house down from the inside out. We don't want that. This is a wildfire-resistant vented soffit detail. It's not much more money, right? There's some small mesh that allows it to breathe, but doesn't let embers come in. There's some gypsum board in there. There's some non-combustible material. But it's not that much different, and it's not that much more costly. And that's what it looks like after the same fire has been applied to it. It's singed, but it's still usable. House doesn't burn down. Exterior walls, right? What are we going to make those out of? Are we going to put lots of fuel in them, like foam? Are we going to use gypsum board, Roxel, non-combustible things in them? Probably a good idea. Here's the proof. We've got vinyl, fiber cement, and wood. Vinyl has gypsum board as the sheathing. The wood has an exterior layer of Roxel, a mineral wool. Okay? Not looking good for the vinyl, but this house doesn't burn down, just all the siding burns off and you have to replace everything from the outside. Wood's starting to go. Starting to singe. And we'll do a countdown here. Fiber cement's looking pretty good. So here we are in the last few minutes of that test. It's a 20-minute test that we're doing. And you can see here, fiber cement needs a new coat of paint. The vinyls needs a new cladding and a new insulation and new everything, except for the building didn't burn down. And you see there the wood, the roof just collapsed, right? So what you build with matters. Don't add more fuel to the fire by using combustible things. This got some. So this is two claddings. They look very similar. One is wood, one is not wood, one is fiber cement. This is a much higher load than the California wildfire test. It's about 4 times the load and 4 times the length. And it has embers. And you can see what's happening there. You know, it's intuitive, but when you see this, you can't unsee it. And when you go home and look at your house tonight, you won't be able to unsee this. That's enough. That thing burns down, and there's the little pile of dust afterwards. So exterior walls best, right? 1 hour fire rating. right? Use a non-combustible insulation, use a non-combustible sheathing, use a 1 hour fire-rated assembly. And if you're anywhere close to something that may, another building, a big tree, a neighbor who might not do any landscaping, that type of thing. Right, and here are some of the details from the guide. Something you wouldn't think about, ICF and below grade walls. Concrete below grade covered with foam or formed with foam. The foam catches on fire and actually damages the concrete. So, instead of, if you protect this, you still have your foundations at least. If you don't, that concrete's quite damaged. It needs to be replaced as well. So for below grade styrofoam, you need to protect that as well. Don't leave it exposed to the fire. Elevated structures and decks. They're a big one, right? You may build a great home with good barriers. If you have a wood deck outside and the fire goes underneath that, it catches that on fire, that deck's going to catch your house on fire, no matter if you have a 1 hour fire separation between you outside and inside. So you need to strategically design decks and upgrade decks. So they're non-combustible or minimally combustible, and they have a skirt so that things can't get underneath them and start them on fire from the underside. Now the most critical link. This is my passion, windows, curtain wall. Everybody in this room, you can see the number of presenters out there or the number of exhibitors. This is the biggest deal because you may design a 1 hour wall, but if you use conventional glass, it breaks in about 30 seconds. And then wire can come right in your windows. So just like the leaky condo issue, windows are the thing we need because we want to be able to see out them. But in that, we have an Achilles heel. The glass is the weakest link. The frames actually aren't. So it doesn't take much to break glass. And if we look at the fires, when we go and look at catastrophic fires, you'll notice that the buildings, all the glass is broken and fire has gone in through those holes. It's not good. How do we prevent that? Right? It doesn't take much to break glass. We all know you get with a Neil glass, it'll break when the sunlight hits one side of it and not the other side of it. If you've got a thermal shade or some differential shading, we know the tempered glass will break at a certain point, right? So what do we use? What's some guidance? This project here, the glass broke. The fire was across the street, and still all the glass broke. Didn't fall out, but broke. So what do we use? Good. Use double glazing. Well, we already use double glazing in all the windows, and you know what? It's not good enough. So when we test these to the California standard, which is a good standard for windows, it's an 8-minute standard, but you're not putting the same kind of loads on that we do with those big wood cribs. It's about a quarter of that. When we use double glazing, both lights break in a few minutes. So it's not going to pass that test, that 8-minute test. And that's for a bushfire, like a hedge catching fire. That's not for your neighbor's house burning down or a large tree. Right, so better, we can use 2 panes of glass with 1 light tempered. This tempered resists heat better. And what I found from doing a bunch of testing here, I'll show you in a minute. You can use non-combustible screens. So the glass can break and the screen will still help keep that fire from coming right through. Vinyl windows, we've tested all kinds of vinyl windows. Some do better than others. The heavier duty European ones seem to do better. If you go to a big box store and buy those vinyl windows, they probably do the worst on all the windows we checked. So if you need a higher level, 45 minutes or an hour, you're probably default to something like shutters. And those shutters will have an automatic, maybe a string, where if it gets hot, string burns, and then the shutter closes. So an automatic closing shutter, because you might be evacuated before you get a chance to close your shutters. So this is the California wildfire resilience test for windows. It's 8 minutes long. That's the flame that you see. And that's what it looks like after we test a big box store vinyl window. Right? So not only does it break and let the fire in, it melts and burns and actually contributes to the fire. Not good. So here's some glazing we did. We did a bunch of testing on some fiberglass frames that had a fire-resistant resin and some metal frames. Those frames performed much better. And this one passed an 8-minute test, and you can see what's happened here. I put annealed on the outside and tempered on the inside. The annealed breaks almost immediately, like 30 seconds in, but doesn't fall out and protects the tempered from the big temperature swing, and the tempered doesn't break till about 8 minutes. Still, I'm talking minutes, right? Not hours. But this is the kind of thing you need to resist just a basic grass hedge fire. So it's good, it's just not best. So vinyl window frames all need to be tested. You don't want to buy a vinyl frame that hasn't been tested to the 8-minute standard. Actually, all windows should be. That's the bare minimum. That's not what I would do if I built my own home or renovate my house one day, because I can't stand to look at it anymore. This is a house fire here that we looked at. It's a breach out of vinyl window. The fire basically broke the glass. This person, it wasn't a wildfire. This was just a pile of garbage that he had outside. It burnt. It popped through that window, broke the glass, came in, and burnt from the inside out. Right? Had that been a wildfire-resistant window, that home would have survived. It was non-combustible cladding. It was stucco clad. Would have been fine. So those are the kind of things, we can reduce a lot of fires by just doing the basics, just doing good, better or best. And this is some recent testing that I did on some borosilicate glass in the fiberglass frames. We got an hour, no problem, right? Borosilicate glass is the same glass you use in your fireplace. Doesn't break due to thermal stress. It's widely available in China, where they allow that as a barrier. It's not going to prevent the curtains from catching fire due to a large fire that's pushing heat through the glass, but it is going to stop the glass from breaking and allowing the flames and embers to come in. So it's allowed in China to be used as a barrier fire rating for forest fire resilience. It wasn't allowed in North America until just recently because our fire tests are for fires that you fight in 10 minutes. And in those fires, you don't want a fireman to spray water to put the fire out, break the glass, and have more oxygen come in and get the fire going. But California just recently got rid of that hose test, and so now we can start to develop solutions based on borosilicate, where we can have glass that doesn't break because we no longer need to meet a hose test. There'll be no firefighters fighting your home fire in a large community fire like that. They're going to be busy doing other things or not going there. So there's lots of room for more research here, lots of room for innovation and new products and new booths at Zak coming up in the future. All right, we tested a bunch of shutters. We even tested just some raw fire-resistant fabrics, and they did a pretty good job. We got the big box store window to pass just by having this fire-retardant fabric in front of it. That takes the heat load, takes the flames, stops it from melting and the glass breaking and the fire from coming in. So we can do a lot with fire-retardant shutters or fire-retardant window coverings. The details matter. So how you put the window in the wall matters, right? Take the same window, put it in the wall two different ways. One's gonna do well and one isn't. So you need to think about how you're going to design those details. And finally, what can a wildfire-resistant, resilient enclosure design look like? It can look great. So this is a new Parks Canada building in Jasper. It's been rebuilt after the fires. It looks great. Doesn't look that much different, except what does it not have? It doesn't have shake roof. It's got a metal roof. It's got non-combustible cladding. It's well protected around the bottom, and there's no combustible materials around it. This is another one that looks great, I think, in California. And then my favorite one is a building we worked on in LA. And after the fires, we noticed on Google Earth that it was still there, which is great, and still relatively untouched. So this is great. This is an actual building that we didn't specifically design to be forest fire resilient, but that was. So it's always a good thing to look at those and figure out why they worked, right? You've got a ton of glazing, right? Fire should have gone right through that, right? Just the heat of that fire, but it didn't because it's facing the ocean. And it's backed onto the forest fire, right, the wildfire, with solid concrete walls. And it's backed onto its neighbors by solid concrete walls. If you take that building and turn it around so the glass faces the fire, might not have done so well. So again, we can look at this and we can look at other buildings that work, and we can make decisions for our iconic residential buildings so that they can also look like this after a catastrophic forest fire. And I'll leave it at that. Thanks very much for coming to see me today.
Thank you. I think we can all relate to the importance of climate resiliency in this part of Canada for sure, based on recent events. So next, we have Jeff Kerr, Technical Advisor, Engineered Assemblies. So come on up, maximizing sustainability through building facades.
There we go. On, check 1, 2. Good, super, thanks. Thank you very much. Good afternoon, ladies and gentlemen. Thanks for letting me speak at you. Today we're going to talk about maximizing sustainability through building facades. I'm essentially going to tell you that a building facade is probably the single most important thing that can get us towards sustainability. So this is my trigger. Bang, a little bit about Engineered Assemblies. We're a national organization. We specialize in supplying the country, ocean to ocean to ocean, with high performance building facade materials. Okay, we also specialize in speaking at least 2 very important languages. One, the language of the house of design, and the language of the field of construction. Uniting those 2 is critical in us gaining success for everybody. So it's through that grow the whole pie mindset that we're able to do that. We're also known very well for the Engineered Assemblies Design Guide, which details essentially a high performance rain screen system, everything you need to know, available for free download off our website. So today's agenda, the quest to achieve a sustainable future through building facades, because we're going to do that. And our 2 biggest hurdles are going to be design and installation. Those are our hurdles, but we can overcome those hurdles. So sustainability for today means achieving our needs without getting in the way of future generations achieving theirs. And we're going to have to do this and face the realities of the environment, the substantial dictator. Now, we have a complicated relationship with the environment, sort of a bite the hand that feeds you thing, because in terms of building things as sustainable as possible, we hope to apply the least amount of injury to the environment, but at the same time, it's the environment which challenges our facade systems more than anything else. So it's complicated. So where do facades stand in this whole mix? Well, ultimately, we'll start with materials. We have a lot of materials we can choose from in the industry. We've got things like ceramic, what some people term terracotta, but it's actually ceramic. High density fiber reinforced cement. We've got high pressure phenolic core laminate panels, natural lightweight stone like slate, something along those lines, porcelain, extruded or otherwise. There's a variety of materials that we can use to achieve these things. But one thing that they all have in common is their ability to fit within a high-performance rain screen system. Now, I say high-performance because this isn't just a traditional excellent rain screen system. It's a system that also embraces outboard insulated, thermally broken substructure. So it's doing moisture management as well as our thermal management in a passive means. Okay, and this is a traditional system which we've been working on for probably the better part of 18 years. It's also a system that Rain Screens in North America, have been working on for the past 4 years to arrive at. Canada's been doing this for a long time. So this is a decent system, and does it belong everywhere? It does. Is there a place that a high-performance rain screen system doesn't belong? No, there isn't. It always serves some things better than others, but it always serves. So this facade system that I'm talking about to achieve sustainability, our biggest component, what's the big deal with it? Well, it's the front line. It's the infantry of our buildings. So it has to combat that nasty thing, the environment we talked about, the solar heat gain, the expansion contraction through freeze thaw. It has to, all the different ways moisture comes at us, sleet, rain, snow, high winds, all those loads, it has to manage those things. And by managing those, it's going to protect the single most effective passive moisture system and our passive thermal integrity. That's what it's doing. And those are big, big jobs, because those things contribute to, it's not our facade system anymore, it's our primary passive environmental control system. It's the exactly. It's the single biggest one of the building. So this is a big job. Now, why else are facade systems important? There are aesthetic considerations. We talked about design in terms of function and form. We've got the function part. Now the form part. Yes. Is it feeding us, energizing, and inspiring us? There is an aesthetic responsibility, sociological implications, sustainability of mental health. So facades are now really important. Okay, so when we consider those, we have to take into consideration embodied energy of these things that we're bringing in. Okay, initial and recurring. When we look at initial embodied energy, that's the energy it takes to manufacture a system, get it to site, put it on a building. But recurring embodied energy is something we don't often talk about. And it's the energy it takes to repair, replace, or dispose of in landfill a system that didn't work. And why didn't it work? Largely because it wasn't designed in or installed correctly. So when we talk about the lifespan that it should achieve, let's not even bring warranty into this conversation, because in 99% of the cases, and I've seen a lot of them, when systems fail, they are generally failing on behalf of a poorly designed system, or in terms of detailing, or a poorly installed system, in which case you have no warranty. So forget warranty, let's concentrate our energy on choosing appropriate material, designing it in, and installing it properly. And maybe through that, we'll achieve durability. Now, durability is a very subjective statement, because when we look at durability, it is a function of a material and its relationship to its environment. We can't objectively look at a material and say, this is durable, this one is not. No. As Ted Keswick suggested at Façade Tectonics years ago, and he's from U of D, underwear or purlins, steel or cotton. One's good for one, one's good for the other, but you can't switch them. So are we finding the right material? Are we detailing it improperly? And are we making sure it's installed correctly? See, sustainability through design involves a big emphasis on how is it installed. And how is it installed depends largely on, yes, the quality of shop drawings. Too much of the time we settle on poor shop drawings. We need excellent shop drawings. Most of us in this room can't install an IKEA bookshelf without looking at the instructions. Think about the primary passive environmental control system of a building. We can't leave it to trades and just expect them to understand it without a great system page on the front of shop drawings that explains, for all intents and purposes, 90% of how the system goes together. So insisting on great shops instead of maybe the regurgitation of details that you included in your architectural set, but great shops that detail nothing magic, but it is complex in the sense that to have a high performance rain screen system, we need to address things like, oh yeah, the vertical hat bars that are supporting the facade skin, those things that create the passive active plenum, the thing that manages our moisture, they need to stop and start at traditional points of deflection. That's not something you're going to see in the architectural set. It doesn't belong there, but it belongs in the shop drawings. So we need to make sure we stop and start those points so that we aren't trying to hold a superstructure together by encaging it in 18-gauge metal, which is just going to get torn apart. And if we don't do that correctly, this is what we're going to get. We're going to get a failure of that primary passive environmental control system, which is going to lead to a decline in our sustainability. So to recap, we're looking at achieving great lifespan through durability of buildings, and we know what durability means, suitable materials, relevant design, installation, great shops, great training of installers. Are our current industry systems sufficient? I don't think they are, because we don't have a quality control system for something that's so important, okay? So if we had a quality control system for this thing, this big thing that leads us on a pathway to sustainability, we could draw from, there's some great tools out there, things like CSA S478, it's part of the national code. Now, municipalities and regions can draw from it if they like. It's a great system. It talks about things like serviceability and serviceable lifespan. Are we designing in and installing a system that is serviceable? If so, is it serviceable for 5 years, 20, 50, 100? How long can we service this thing for? It needs to have a great serviceable lifespan. So a lot of these tools are out there for us. So having a quality control system for facade systems would be a pathway. Where would we start with something like this? Well, we could have a contract between architect, general contractor, subtrade, It could all work on platforms that are common to people like Procore. We could have great drafting, great training. We could have details that we need to capture on site with camera photos, have them implemented into the software for people to review them on time in a real-time basis. Maybe a specification in Division 1, okay, Section 1, so nobody misses it. These are quality control systems that we're happy to discuss, certainly at our booth. It's something that would help the whole industry. And through this, we'd be able to unite the house of design with the field of construction, gain a great pathway towards sustainability, and have this super holistic relationship. My time is up. I hope you know something that you didn't know before. And I'm Jeff Kerr with Engineer Assemblies. Thank you very much.
Didn't Jeff have like the best energy in how he approached that? My goodness, such passion. It's amazing. Thank you. So no pressure, Peter. So you can please welcome Peter Dushenski. Oh no, this is the perfect person to follow. What am I saying?
Someone's got to do it.
We're going to talk about northern resilience and zero tariff facades for net zero buildings.
Thank you, Lisa.
Thanks.
Yes. Yeah, pressure. What pressure? I don't even know what pressure means. But, you know, if there was ever a day to talk about high-performance glazing systems, I think we all woke up to it. So thank you, Mother Nature, and this lovely northern front for giving us this somewhat atypical climate today. And those of you who are coming from out of town, welcome. So good afternoon, everyone. My name is Peter Dushenski, and I am the Managing Director of Glass Curtain. And we are, as many of you already know, Canada's leading manufacturer of fiberglass framed curtain wall systems. And for almost 15 years now, we've been developing and delivering building envelope solutions that leverage innovation, material science, and ultimately to elevate new projects towards our nation's energy goals, carbon targets, and really cold climate realities. And today we're going to take a closer look together at a particular project some of you I know have worked on in this room, which is the Red Deer Justice Center, a recently completed $250 million project, which sounds like a lot until you remember this actually tendered in 2020. And, you know, today with everything else, it might even be a little bit closer to double that. So this project really is a showcase. And it shows what's possible with locally made systems that are specified with intention, which this isn't about idle theory or pie in the sky nice to haves, but about real world results on a high stakes and high profile public building in a rather, again, challenging climate no less. Our journey begins in central Alberta. So the Red Deer Justice Center is an 8-story provincial courthouse, actually the tallest building in all of Red Deer. Designed by none less than DIALOG Group in collaboration with local architects, Group 2 Architecture, with Alberta Infrastructure as the driving client, and of course Intuitive as the building envelope engineer. And as you can imagine, this project represented a major investment in the province's civic landscape. And it came at a time when the lifeblood of Alberta, its oil and gas industry, was frankly in the doldrums. Maybe some of you remember those old days. But there was still a sense of optimism, of course, particularly on a project like this. So with performance standards on the rise, not just around energy and carbon, but also for durability, reliability, and long-term public value, base building code compliance was never going to cut the mustard. So the strategic decision was made to target Canada Green Building Council net zero or zero carbon standards to reduce life cycle costs, improve the quality of the interior environment, and ultimately reflect positive stewardship of public funds. So for the clients and the architects, this meant that the building envelope had to be of central importance, as Jeff certainly, I think, prepped us for. And so it needed to make meaningful advances towards, again, operational efficiency, cost certainty, and climate goals. So the facade, therefore, had to be more than just aesthetically attractive. It also needed to be best in class on day one, and then consistently for decades and even generations to come. So this created an opportunity for more thoughtful specification process because this was a public sector project. The design team could seek, therefore, more holistic building cycle or building envelope solutions to reduce carbon over the building's full life cycle, and also to think more deeply about procurement, something we need to think more about, and I think we are starting to think more about. So now this particular project's procurement obviously happened again before the world went tariff crazy and before our most recent oil and energy price shocks, but it still had to manage, again, COVID-era supply chain dislocations that negatively affected so many of the projects we're all familiar with. So to the lasting credit of the design team at Red Deer Justice Center, they demonstrated to us all that a little foresight paid all kinds of dividends for reliable delivery of quality products, minimizing unpleasant surprises down the road, and creating the kind of built-in insurance against risk that we all strive for. So how did this project manage to have its cake and eat it too? Well, with a little Canadian know-how and a little planning. So it might seem, again, like ancient history today, but it wasn't so long ago that curtain wall specs only looked at maybe just a few narrow performance metrics, maybe just U values, maybe just solar heat gain coefficients, maybe condensation resistance, or if you're very lucky, embodied carbon. But those metrics, while they obviously still hold a huge amount of value in separating the wheat from the chaff, it's also not hard to see that we no longer live in the boringly predictable world where that's all that matters, which is fine. It just means we have to adapt. And that means that we need to focus more of our attention not just on what we buy, but where it comes from and how it's made and who it ultimately supports. So 100% Canadian supply chains are therefore more critical now than ever. We needn't even get stuck in the political weeds to understand why it's just a practical consideration for our projects in 2026 and beyond. In the last few years, if this industry has shown us anything, it's how fragile and frequently capricious global logistics can be, all of which introduce unwarranted and unwanted uncertainty and ultimately adding cost to new projects. So whether we're building hospitals, schools, or courthouses like Red Deer Justice Center, none of us can afford more delays or more items chewing into contingency funds, which is why we're seeing more and more specifications taking this into account. We all want reduced risk, more certainty, shorter timelines, and faster troubleshooting if and when things go a little bit sideways. And that's exactly where Canadian manufacturers like Glass Curtain, what we provide and what we specialize in. And this is really what we're talking about today, which is adding value. At Red Deer Justice Center, the decision to specify ThermaFrame 7 fiberglass framed triple glazed curtain wall for the 22,000 square feet of glazing cost only about an incremental 0.5% of the project's budget, while guaranteeing the glazing system was on time, on budget, and supported an additional 15 local manufacturing jobs during construction, all of which avoided, and with the positive ripple effects of all of that, as well as the additional life cycle carbon savings of over 4,000 tons of carbon in reduced shipping. So in this light, we can see that procurement is a design choice, one with economic, social, and environmental impacts. It's a choice to shape our domestic industry into one that's more resilient, more responsive, and better equipped for the ever-evolving landscape ahead. So, how to maintain glazing ratios in cold climates. I mean, you know, if we're giving this presentation in July, we might think, oh, that's ancient history. We don't live in a cold climate. Today was a good reminder that, of course, our buildings still need to perform to meet the challenge of Alberta. Right? But thankfully, Canada has several leading, world-leading solutions to lean on. So even when targeting net zero in a part of the world where we've got minus 40 degrees in the winter and plus 30 or higher in the summer, the design team at Red Deer Justice Center didn't back away from glazing. Instead, they made their envelope work harder and smarter by specifying locally manufactured triple glazed fiberglass frame systems, which limited heat loss and reduced carbon. The result was actually a relatively highly glazed or higher window to wall ratio, given the performance profile of the building and given the program of a courthouse. And all with a mechanical system that didn't have to be oversized to compensate. Demonstrating, and I'm sure some of you have been seeing, you know, the pricing for mechanical systems lately is not, you know, going down. In fact, it's, you know, kind of one of the toughest things to procure. So if we can downsize those, minimize the impact of that, there's huge benefits across the building for the long term. And we can also hold the line on architectural intent while still meeting stringent performance targets and in the most demanding climates. And of course, it wasn't so long ago that the best glazing solutions in the world had to come from overseas, whether Europe or Asia or elsewhere. But thankfully in 2026, we have world-leading Canadian technologies and Canadian options that deliver previously unimaginable performance, while offering something imported systems simply can't match, and that's domestic resilience. So at Red Deer Justice Center, the design team specifying Third Frame 7 had complete confidence that our triple glazed fiberglass frame curtain wall system was going to be manufactured and fabricated right here in central Canada, actually right here in Alberta, ensuring a predictable local supply chain with no customs or tariff delays and no need to translate foreign standards to our markets. This was a glazing system purpose-built for our climate, our construction realities, and our ambitions on projects like this. And this kind of homegrown innovation is becoming more and more important on every project as we continue to strive towards net zero, low carbon, and domestic resiliency goals. Ultimately, the technology solutions that we need to be trusted, which at its best means leveraging local capacities and relationships to create true community ownership, all while resulting in shorter lead times and the oh-so-important minimizing of topsy-turvy geopolitics risk. So especially for complex public infrastructure buildings like this, domestic manufacturing and know-how creates a kind of long-term trust and resilience and sustainability that's really a fundamental and increasingly non-negotiable part of responsible design and delivery. So what can we take from this project, and what does it tell us about where the world is heading? Well, Red Deer Justice Center demonstrates that high-performance facades developed and manufactured locally right here in Alberta are already succeeding. This isn't just about theoretical or future aspiration anymore, it's happening right now. What we're seeing is really part of a broader shift in how building envelopes are being procured and specified, not just as line items to value manage. We won't call it value engineering, there's no engineering involved in that, but as key levers for performance, predictability, and holistic economic development. The public sector has played and will continue to play a key leadership role in this domain, building momentum, creating alignment across the construction ecosystem, and forging a path that private sector can follow. As public sector design teams learn about Canadian solutions and specify with greater and greater confidence, as builders gain more and more experience, and as local manufacturers scale up to this challenge with new investment and innovations, policymakers get real-world proof needed to inform future standards to benefit us all. So that's where we are today, at the beginning of a journey to align high-performance building standards with domestic manufacturing innovation and climate objectives. Red Deer Justice Center is therefore a showcase of what's possible towards these admirable ends, and a future-oriented elevation of local supply chains and Canada's can-do spirit. In the next decade, we expect to see many more such projects, as well we should. In this frequently crazy world, we actually have a unique opportunity to achieve and create lasting value together. Thank you very much for your time.
Thanks, Peter. So equally as enthusiastic. It's a tie for sure. This next presentation, I'm super excited about, but I shouldn't be biased, so I'm excited about all of them. We have got Kyle Auch from DIALOG to talk about Glenbow Reimagined.
Okay, good morning, everybody. This is a really exciting day because we actually just achieved occupancy on the base building portion of this building after 6+ years of design and construction. So it's really quite exciting, and this is our first presentation for that. I do want to say that I stand here alone, but I do want to thank so many individuals that have helped to collaborate and coordinate this project over the last 6+ years, many of which are here today. So I want to congratulate you and also say thank you for all your dedication and hard work as we continued through this project. Let me start with a question, because our team really focuses on questions more than answers. And because of our work, it really does have consequences. In a world that is increasingly polarized, unable to see through the eyes of one another, how can architecture find space, multiple perspectives, and multiple voices in pluralism? And how can we, any of us, truly consider ourselves to be contemporary and not deal with the most significant issues of our time? The greatest of which are the health and sustainability of our planet, the respect and inclusion of all peoples. So I have to do this because this had a very large portion of what we were looking for to do in this project was to seek out all voices through the design and the construction process. So personally, I recognize my connection to these lands as far fewer than those here before me, and I, along with my family, are guests to these lands. Our personal commitment through this project was through the efforts of reconciliation, includes providing the space and platform within each of the projects that we work on for all voices, especially those that carry traditions and values embedded in these lands far beyond our own. So this project is more than a renovation and a retrofit. It's about transformation. And it's more than purpose, it's about reimagining. But sustainability is much about people as it is about the buildings that we're trying to reimagine. There can be no true sustainability unless we're also inclusive of others in our thinking. That's where architecture contributes to a greater cultural meaning. In the end, radical sustainability is in reusing, transforming, celebrating, and giving new meaning to our buildings and our cities, inclusive of all peoples. So this is going to be a short video that I'm going to talk through, but I have to do it because it really does kind of create the foundation of what we were doing with this building. And I'm glad the sound is working, Isabel, so that's great. So what this video is called The Conical Intersect in 1973 by Jordi Marasse. This is one of the art projects that he did inside Paris, right adjacent to the new Pompidou Center. So at this time, this building that was sitting right next to the Pompidou Center was an abandoned building that was set to be demolished. And through Jordi Marasse's eyes, he really wanted to show how buildings can be reimagined, transformed, and also kind of provide a transparency into the city and allow that city into the building as opposed to just the building existing within its context. So you can see a lot of this video. It's quite a lengthy video, but a lot of this video is of him demolishing portions of this building, something that this building always had, but nobody ever could see before. And we say that a lot through the Glenbow project as well, is that what we see today was always there. And we were there, really, our team was there just to kind of reimagine it and expose its true potential through a new design and inclusivity lens. So unfortunately, we'll keep going because I will not finish this presentation in time. But you can see how, I'll show you later how portions of this video kind of showed inspiration into the Glenbow project. So this was the existing Glenbow Museum as we all knew it was in 1975. It was designed by a local firm of Albert Dale and Associates, and it's truly a bunker. It's a failed attempt at brutalism at this time of the year where it's not a light structure. Brutalism really focused on that lightness of concrete and how concrete could interact with the city in a very light way. Whereas this building slammed itself into the earth and created more of a vault that was built for 260,000 works of art, including indigenous belongings and artifacts. One of the things I also wanted to point out, which I'm sure many of you know, is there is no front door to this building. Everything is completely closed off to the city, to its context, and most importantly, to its people. So I really can't say that this building took into consideration the city at that time and the people that were really trying to find a place and a platform to voice their own opinions. So this is just a brief overview of where the context of Glenbow sits. As many of you probably know, just a kitty corner to Olympic Plaza, where the New Arts Commons project is, as well as a significant relationship to many of the cultural and kind of heart, kind of buildings within the heart of Calgary. Culture is a continuum to us, and architecture Architecture engages site, program, context, history, and the future, and every building has the opportunity and responsibility to carry a stronger cultural meaning. So I do want to focus a little bit here on the sustainability aspects and targets of this building. There were three options for the original, or for the Glenbow Reimagined project. And before even this 6-year project began, there was consideration of demolishing the existing building on site and rebuilding new, which was very complex and complicated because the basement actually doesn't belong to Glenbow. It belongs to the CTCC, or Calgary Telus Convention Center. So that relationship made it very difficult for us to reimagine demolishing this building and rebuilding up on the same site. They also planned on moving the entire collections in the cultural building to a new location on site and then selling off this asset. But one of the things that our team really did at the first beginning of this project was investigate the potentials that lie beneath all of the surfaces that were continuously renovated within this building. And sustainability was at the forefront of that decision. By reusing this existing building, we prevented 56,000 tons of new carbon from being produced over the lifespan of the building. We kept 38,000 tons of concrete from reaching the landfill. And the new building and envelope, obviously we replaced the entire mechanical and electrical system, will help Glenbow realize a 41% reduction in greenhouse gases emissions annually, and then 38% reduction in annual energy use overall. There we go. Design of the early phases, we really came up with 6 design principles that became like the conceptual framework and backbone to our decision making. We wanted this museum to be radically accessible. It also needed to bring the back of house to center of house. No more hiding the storage spaces, no more hiding the collections from the public. We really wanted to expose as much of this building as humanly possible. It was going to be entrepreneurial. So how can this museum generate its own revenue as opposed to being so dependent on visitorship and people coming and visiting this city? We are going to create multiple experiences. One of the primary drivers for the concept of the design was that art was seen in multiple different vantage points and views. So when you experience this building, you're going to be able to experience the collection in multiple different ways, whether seeing under it, seeing above it, seeing around it. Everything is going to be transforming your perception of what that art is. Because that's the beauty of art, is we all see something a little bit differently, and it allows for a broader conversation to exist. Last thing, it was going to be an urban provocateur. We also wanted this to be a brand new way to build, in the case that it really means that the envelope and systems, which we'll talk about today, really impacted how this building exists on site now. So to really look at the facade, we also need to understand how the project is much less about the exterior skin as it is about the interior volumes. This is a very early sketch demonstrating the desire to open up the building to natural light and views. Every single floor in this building was only accessible from levels main floor to 4 to the public, and now this building will be completely accessible to the public on all floors from the main to the 8th floor. We used to comment that this building was built like a pancake, and every floor slab was its own kind of individual thing. And our opportunity here was to make it more like a waffle, which ironically, the structural system is a waffle grid, so it kind of worked out for us. So to successfully open up the building to natural light, we needed to start with the northeast stair, which is this volume right here. And this is really the Gordian knot that we had to overcome to open up this building. So where did we start? This is the existing building, and this is kind of the process explained on how we did this. So this is the existing building as we know it. We cracked the building open, literally removing every single piece of the facade and completely stripping it bare. We removed the northeast corner in its entirety, including the basement section, which allowed us to open up that Gordian knot. This is then where we had to stitch the building back up together. And this was a really exciting opportunity architecturally for us because we started to play with this idea of old and new. Everything you see in this building when you go and see it now is going to expose the old and expose the new. And you're going to be able to see why we did certain things, but also ask you more questions than give you more answers. That's really what we wanted to do with this building. And then we started to remove floor plates. And this was really an incredible opportunity for us based on the existing infrastructure and structure of the building. It was very, very particular and prescriptive on where and how we could do this. And these are the resulting volumes within the Glenbow Museum that you'll experience today. So now, a little bit back to that first movie that we saw about Gordon Matta Clark. It explained the concept that Gordon Matta Clark meets this Sol LeWitt. Now, Sol LeWitt was this man that designed the perfect grid system. And that's essentially what the Glenbow was actually built like. It had a perfect gridded system, completely cast in place, waffle slab, beam, and column. And we took this idea to take Gordon Matta Clark and Sol LeWitt and mix those two ideas together. And so now we start to see how we're making that connection between the city and this 1975 bunker that used to just sit in the site with no front door and no connection to the public, to the people, and to the buildings and surroundings around it. So this is one of our first opportunities where we actually started to remove large portions of the lateral system in the building, because all of the concrete walls that surround the building actually provided the lateral structure to the building itself. So this is another case where we had to remove and then stitch back together with new steel. This is a quick memory, I would say, of how the pillow window came to be, and I'll explain what the pillow window is in a minute here. So let's get into the facade specifics. So we really wanted this idea, like I said to you, about asking more questions than providing more answers. And so we thought of this word fuzzy. And fuzzy was the word that really guided our entire design direction throughout the entire design process with our partners Heavy and Ferguson to create this new undulating facade. So looking at this is kind of the idea of fuzziness explained through the artwork of Ai Weiwei, where a singular item can be very understandable and readable. But when you start to layer them, and you start to combine them in different ways and see them from different perspectives and utilizing light and shadow, they become a lot more unreadable, a lot more fuzzy. And this is really how we started that process of testing and investigating materiality and how these pieces could come together to create this fuzzy facade. I'm sorry about the quality of these, but these are very, very early sketches of the facades here. And just how, again, bringing natural light, opening the volume up to the street, to the people, and exposing the museum to the city, as opposed to the other way around, the city to the museum. And then this is where we started to layer in that fuzziness. What did we mean by fuzzy? How could we achieve that? And this was a very intensive investigation, again, with our partners Heavy and Ferguson, which involved a ton of 3D printing. We probably have, I would say, 200 to 250 of these 8.5 by 11 kind of swatches of 3D prints where we started to explore this idea of fuzzy. We went from geometric to soft to organic to rough. We really looked at a wide range of different opportunities. And then when we started to layer in this, like, how are we going to build this conversation, we also started to look at different materialities, like a pegboard concept. One of the things that Heavy had helped us develop was this idea that what if this facade was completely made of pegs? And the density and the length of those pegs was what really created that fuzziness. However, through this 3D process, we started to get really close to what we were talking about, blurring those lines and making sure you couldn't really tell the difference between line and form and surface and edge. And so this was our final fuzzy design. Now, this is a mock-up of what we had intended for the overall facade. But when we started to look at the opportunities here and play with the light as the sun moved around the building, we looked at opportunities to change the amplitude of that fuzziness quality. And that's where Heavy really came into play with us and really allowed us to experiment, which was really important to this process. These are small samples of the colors that we were looking at using, but ultimately we decided on going with just a standard white facade. This is part of the production process that we worked with Heavy with. This is a full-size concrete mold that were produced based on an MDF plug. And again, this is our largest amplitude panel. And there were 4 different types of this in the end, moving from flat all the way to, I believe it was 40 centimeters in total depth between the center line to the front and back. And this is us reviewing those tests and reviewing those plugs, reviewing all of the surfaces, and really taking the opportunity to see what this material that we wanted to look at really was going to do for us. This was, again, part of that production process. Ultimately, we decided to go with, we went with Cloudcrete, which is a product from Heavy made of glass fiber reinforced concrete. It is a sprayed on product that is individually hand sprayed for every single panel. And it really does create a very ductile, very strong and resilient material that we could then play with this difference of amplitude and changes in depth of panel as we moved through the facade and played with the light as it moved around the building. What we did was we actually did 2 full-scale size mock-ups of these panels with Heavy as well. Not only that, we also built the actual wall itself inside one of their shop areas. And this is where we started to see the true impact and effect that these panels could have on the building. And so we do have a time lapse, but it's a very long time lapse, obviously, because of we did this on a full day from 6 in the morning all the way till 10 at night. And you can truly see the changes and how this fuzziness quality really came to be. This is where that idea between line and edge and surface and form really started to take shape in our minds, and also we knew that we were on the right path towards getting this quality over the entire facade. I had somebody ask me earlier today if the perforated panels were GFRC, and they were intended to be, but they are not. We are still working on that process and still looking to find a solution on how to actually get that same type of effect, that a really organic, soft quality in GFRC. But at this time, because of the mechanical requirements, we had to have that 50% open facade. We opted for a metal panel in very certain areas along the facade. The opportunity for us to actually work with a partner to get as close as humanly possible to the finish and the color of natural GFRC concrete was an incredible task. This is the final production model of what we were looking at, and you can see that this is a change between 2 different amplitude sizes of panel. This was like kind of I think our 3rd and our 4th size. but you can see that we did still achieve what we wanted to do. The only thing that we really didn't want in the original design was that separation in the midpoint of the height and the width of the panels, but because of the structural integrity of metal versus the GFRC, that was something we had to kind of concede on. But when I show you the final photos, it's definitely not something that we couldn't overcome. This was a very interesting process because the original building was built with concrete, and the facade panels were made of precast concrete panels. And we wanted to be very clear that the success of this building is not, or sorry, the downfall of what this building wasn't because of what the skin was made of. So that's why we kind of challenged this idea of how can we actually just take this idea of concrete panels and replace them as more of a contemporary materiality and opportunity. The original building had multiple precast panels on it. It was a very slow process. This is an image of us starting to crane off the building panels, and we could roughly do about 5 or 6 panels a day. Whereas with the new GFRC panels, we could roughly erect about 50 to 60 a day. And so it was a very, very long, arduous process. And over the last 50 years of this building, a lot of the precast panel supports and the panels themselves were starting to degrade. So it was a really sensitive, time-consuming process to get this off. You can also see here the quality of the envelope that we were starting to be left with. We were left with less than an inch of rigid insulation that was completely delaminated from the facade, and also a very, very poor membrane. So we completely revigorated that. We took this facade from a 1-inch delaminated insulation to a full 6 to 8 inches around this entire building. One of the primary important things about this building is that we had to protect the collections, and to have a AA rated space within our environment is next to impossible with our fluctuations in temperature and humidity. But by securing this envelope as such a robust element of the design, we're able to get very, very close to that 5% differentiation between 40% humidity and 23 degrees temperature change. Looking at the overall site here, I just wanted to point out this was a really great opportunity because a lot of this building exposed itself as we started to demolish more and more of it. And a lot of the design had to pivot. So we started on the west, and as we kind of gradually moved around this building, removing the existing facade, but also then installing the new GFRC, we started to tweak and pivot and perfect the process that we were using with heavy to make sure we really got what we wanted. This was that 5th floor facade. This is going to be one of the largest transformations of the building because this existing patio, which is roughly about 10,000 square feet, was completely unutilized and inaccessible to the public. But now it will be the exact opposite and completely accessible to the public for year-round use. Again, some just more production shots of bringing that facade to the building, improving the building envelope, and integrating it back into the city. This is an awesome image that I love because it takes that idea of blurring the boundaries between light and shadow, form, image. And this is that pillow window idea concept that I was talking about earlier, where we had to remove portions of that lateral support system to push out this new window into one of the new volume, double height volume gallery spaces we call the salon gallery. Very interesting kind of juxtaposition image between the new facade and that kind of bumpy transition between the old and the new, and the existing and the kind of reimagined facade of Glenbow. And this is that northeast corner. So again, this was one of the most difficult parts of the building from very, very many aspects, including building code, demolition. We were competing with Calgary TELUS Convention Center, like I said, so they were still hosting events down in their basement as we were constantly chipping out concrete and removing concrete from this northeast corner. At moments on the main floor, there were meter-thick walls that supported this concrete throughout this northeast stair. But as you can see here, this is a new image of the northeast corner at the 8th level, specifically where the Glenbow has their new boardroom, also a rentable space to the public. But it is one of the most unique views of the city of Calgary that hasn't existed before, that we were able to reintroduce because of removing that northeast corner. Again, northeast corner, but again, directly south of that, this is going to be the new kind of restaurant or food service offering right on the northeast corner. So you can see from that kind of bunker quality building that we had originally, this is a massive, almost 3-story volume window, kind of framing a 6-story volume on the inside. So again, exposing so much more of this building, and revealing the scars of the time that it's been here in Calgary with us. None of this building is going to be covered up like it used to be. All of the columns are exposed, all the floors, all the ceilings are exposed. Everything is telling a story of how this building has been transformed from 1975 to 2026. And so when you get this opportunity to look at it, you're gonna hopefully go in, ask a lot more questions, and see a lot of things about this building that you never really knew existed in the past. This is that northeast corner again. You can start to see how this volume is starting to take shape. This is another opportunity to see how those GFRC panels start to interact with the perforated metal as well, and how seamless we got it, considering the different qualities of materiality that we had to deal with. This is the south facade. We really, in the previous building, it was all considered one giant block. That included the hotel, the TELUS Convention Center in the middle, as well as the Glenbow. We really wanted to emphasize that Glenbow had its own identity. And so this was an opportunity for us to emphasize that strong 8-story volume block and separate it from that CTCC and hotel block as well. This is one of the areas that we were able to remove a large portion of the floor. This is one of the scopes that we're currently working on as the integration and fit out for the theater space. This is roughly about 250 people theater space capacity, meant for primarily lectures and film, but also dance and things like that. This is an overall shot, so you can start to see all the opportunities that we really started to bring natural light in, especially focusing on areas like the staff areas. The staff in the original building had very, very limited light. So talking about health and wellness and how we're actually bringing that to the staff that work in this building. You can see the pillow window there on the east facade as well as the northeast. And these are just some of the shots that we were just recently able to get, really trying to focus in and curate that effect and impact as light changes the building as it moves around the facade. And it has really been such an honor and a grateful experience that I've had to be the contract administrator on this as well, because I've been able to see this building under almost every single condition. I was up there reviewing panels during an absolute crazy thunderstorm. I was up there when it was been blizzarding out, and the way that this building interacts with the environment is something that we can't replicate all the time. And I'm extremely grateful for where we've come. This is another opportunity to really show that fuzziness. And the last 2 slides here really try to emphasize that you don't entirely know exactly what you're looking at all the time. There's a level of curiosity built into this design, and it's really, really inspiring to see that there are ways that we can do this. It's really through strong collaboration and working directly with people that you trust and have the exact same values in the project as you do. Very quick, Isabella, I know I'm over, but I'm going to do this quick film. And many of you might have seen this already, but this is just our quick fly through of the building. just a kind of drone shot showing. We love the capabilities of these panels, gathering the snow, becoming part of the context, becoming part of the environment, and really changing 9th Ave, 1st Street, and Stephen Ave here. So we still have a little bit to go. There's probably about another year associated to the fit out of this museum. We're deeply heavy into that right now. But we hope at the end of this, we have a postcard that's representative of Glenbow in Calgary. Thank you.
Thanks, Kyle. I've actually had an opportunity to tour the Glenbow. So I toured it when my kids went there for school field trips, and yeah, words like bunker come to mind. And then having toured it recently, the transformation is an understatement to how spectacular that space is, and will only get better as it goes through its last phases of that project. One other thing I was going to say, Kyle, my new favorite architectural term is fuzzy. Yeah, I'm going to find a way to use that. So we're getting set up for the panel that's next. So let me introduce them while we're waiting, and they're waiting patiently in the wings. Is it Anine? Anine, okay, thank you. It's only the second name that's thrown me off today. So Anine Eskberger Wortman is going to moderate this panel from Gravity Architecture. And then we have Leo Lejeune from Stantec. Whew. Kelly Coles from CMLC. And Joe Schwartz from JRS Engineering. I think it's almost ready. And we're talking about facade delivery and procurement models.
Thank you, Lisa. Good day, everyone, and welcome to our panel discussion here today. We're going to jump right into it and have kind of a bit of a casual conversation about procurement, procurement models, and how that links to facade design. So we're going to jump right into it. Leo, given you have obviously very deep architectural experience, being a vice president at Stantec, was, being the lead architect for the BMO project. How does procurement models shape design, and who ultimately drives facade design from an architectural perspective?
Sure, happy to have this conversation. I think for any architects in the room that you'll appreciate in your own careers, that if you look back hundreds of years ago, the relationship between the architect as designer, sometimes they were also the craftsman, and they worked very closely with the team that was putting the building together. As the generations passed, and especially in the 20th century, we got to a stage where the division of assembly of who was responsible for what got more and more complex. And so I'll use as an example, years ago, I worked on a project at the University of Alberta in Edmonton that was a reimagining of a 100-year-old building. And we found the original drawings for that, and it was 8 drawing sheets. So you can compare that to the number of drawing sheets that's required in a complex building today, with hundreds and hundreds of sheets to pull off the same effect. What that reflected was that there was more design intent shared by the architect in the drawings, and they spent a considerable amount of time on site with the craftspeople putting the building together. And decisions were made sometimes on the fly with the craftspeople. Fast forward to today, what we're seeing now is the traditional model would have been design, bid, build. And so to achieve the desired effect, the architect was often discovering that they were having to detail every single element in every single corner to the nth degree. Thankfully, I'll say now we're seeing a full spectrum of procurement models where that each have their merits around design influence from the design team members. So beyond design bid build, we're seeing design build, we're seeing construction management, CM at risk, all the way through progressive design builds, P3s, and now more and more around IPD or integrated project delivery. So I think the advantages of the traditional model of design bid build would have been perhaps that the design team felt there was more control in what you were designing. The downside of that model was that you couldn't necessarily guarantee that what you were designing would actually meet the cost and budget set up by the owner. And so then you would be discovering after tender that something is completely over budget and have to rework your design. Open that up to other delivery models like construction management, for example, with the CM at risk model, and we'll share some examples here today, including the BMO. Then there are opportunities where you can, same thing, invite your contracting partners into the discussion and then talk about constructability measures and how your desired intent for a look or for a material or for a detail, you can actually have a conversation much like the olden days as to the desired best way to achieve that intent.
Thank you, Leo, for your very thorough answer. I'm going to build on that on the construction management model with Kelly. Kelly, knowing you worked with Leo on the BMO project here in Calgary, from a client's perspective side, with that procurement model, what would you say from a client's perspective side or an owner's rep? What lessons did you learn from that model, and what did you take forward with your forthcoming projects?
Well, can everyone hear me okay? This is a little odd. I think first of all, I think we need to note that CMLC was development manager on BMO. We play the same role on the current Workland Center project, Olympic Plaza, and a couple others. But being client, or I would say it's an expanded version of an owner's rep, we also on BMO had another client being Calgary Stampede. And so that, of course, adds another layer of complexity. But I would say what a CM model allows us to do, as Leo described, is as client have more access into the process that we might not otherwise have had. I think typically if we're thinking about design, bid build, you would have some input on the front end primarily and not so much through the process. As a somewhat savvy client, I would say, Leo's smirking right now.
Smiling, not
smiling. What I would, define as access into the process, Leo and team might define as a headache. But for us, it allows us to have a greater input through the whole process. Not just from a design perspective, but then layered on top of that, of course, from a operational perspective, and that primarily sat with Stampede, and I can get into some more details about that further along. But I think it allows us to keep an eye on it and think about design ambition, perhaps in a slightly different way than the designers, than the architects, not in a way that deviates from their vision, but in thinking about the whole design objectives for the project and the design vision, we as a client would think about the building contextually in a different way than the architect might. So contextually in the site of Stampede and BMO as an example, contextually in our district, CMLC as community builders has that lens as well. And so we have the opportunity through the CM model to kind of keep those things front of mind and be a full part of the design process.
Thank you very much. And just building on that, knowing that the BMO project had such a specialized facade design, how did you manage decision-making cadence on that project? Do you have specific tools or processes within CMLC that helped you guide the process?
Yeah, we certainly have our own internal processes, again, that kind of speak to like our desire to be involved, perhaps to a different level than another client. I kind of joke with my team sometime, if there was a dentist wanting an architect to build an office, a freestanding dentist office building, it would be an entirely different scenario than CMLC and Stampede wanting input. We have our own opinions, obviously, but I think we put a process in place with really great partners. Our design team was amazing, PCL SCM. We had Design Assist, shout out to Heavy at the back of the room there on a portion of it. And so we had processes that allowed us to meaningfully input, I would say, and I'm thinking about specifically, not this image, but what we kind of refer to as the barn facade of the building, to allow us to come and offer our thoughts and opinions, hopefully that we're aligned with Leo and teams, and on a regular cadence. So we could be on site looking at full-scale mock-ups, we could have those adjusted quickly, but instead of the design team working through a series of steps and then coming back to the client and saying, here's where we kind of landed, it gave us an opportunity to weigh in a way that felt right to us to get a product.
Thank you very much. I want to shift the discussion a bit to alternative procurement models. Leo, obviously you have experience with alternative procurement delivery models, but I want to know more about how does risk shift when you are using these type of delivery models. Can you speak a bit about these models and your experience and the current projects that you're working on?
Sure. Yeah, we've got experience in kind of that full spectrum of procurement and delivery models that I was referencing earlier. I would suggest that the majority, certainly of my work for the last number of years, has been falling into the category of construction management, or CM, both CM and CM at risk, both models. What the advantage of that one has been is getting that contractor trade input early on constructability details, as well as budgeting all the way along, so that there aren't surprises later on, or going into deep, painful value engineering exercises that I'm sure everyone in this room can relate to. The risk with design build is that you are relinquishing somewhat control around what you're looking for in the design, but the benefit is the cost certainty. You're working together with your contracting development partner, setting an overall tolerance for what the budget would be, and then working constantly against that number. So from an owner's perspective, they know what they're going to be able to get from a cost. With progressive design build, I think the advantage there is if there's been enough front-end planning work by the owner, and perhaps a consultant team behind that owner, that by the time you secure a progressive design build team, wherein you're only submitting your rates and your qualifications, the risk transfer there is that enough front-end work has been done to make sure that the owner is still getting what they want for the budget that they've set. We're also doing some work right now with the University of Calgary, for example, on an IPD model, integrated project delivery. This one, I think, so what's been great from a collaboration point of view is same thing. You've got the contracting trade partners with you at the table, right at almost at the very beginning. Yet the risk there is transferring from the design onto a collective ownership of the budget and a collective ownership of the risks from a technical perspective.
Thank you, Leo. I just want to fold in Joel here, because Joel has 30 years of experience just in the building sciences industry. And I want to pick your brain a bit about that early contractor involvement and early facade design, so it's not left to the last minute. Can you speak a bit about that and the involvement and the importance about that? Things like geometric realization, thermal performance, anything. We would like to pick your brain and hear your thoughts on that, please.
There's a lot of topic to cover in that answer, but I would say the traditional model, the architectural design would be the design intent. As pointed out, it wouldn't go into a lot of the details. It would show the building as a whole, the form. And then the systems, if there was a typical window system, would be handled through shop drawings. And that would typically occur in the design bid build model much later in the process. And when the buildings were, I'm going to suggest, simpler, a little more straightforward, when there were fewer constraints, performance requirements, that was more easily achieved. The performance that a window system had to meet, relatively straightforward. I'm going back 30 years. There wasn't a lot you were looking at. Buildings are evolved. People are demanding more of their buildings. They're required to meet higher performance standards, more performance standards. The systems are getting overall far more complex. And that model just doesn't lend value, in my opinion, to the final product. The actual design of let's say, a complex curtain wall facade, if it's left to once the budget has already been established, once the building design has already been established, there's very little room within that, let's say, curtain wall design for flexibility. So you're going to inevitably achieve scheduling issues, potentially cost implications, or quite simply just contradictions with the architectural design. My practice area is predominantly in British Columbia. There's the BC Energy Step Code, and as was mentioned earlier, there's thermal energy demand intensity targets that have to be met. Those are informed by the thermal performance of most of the envelope systems. So a curtain wall system will be expected to meet a certain thermal performance in order to meet that. If that design is basically done, the design of the curtain wall is done at the shop drawing stage, depending how much steel is required, depending on the mullion spacing, and a lot of other factors, there just may simply not be able to meet the performance requirements of the product or the project. So getting involved very early, either with sort of pre-design or preliminary facade design, when some of the engineering or structure can be worked out, you can identify if there are going to be thermal penalties, how those can be overcome. It can be rationalized much, much earlier with much less conflict later on in the project.
So this links to what Leo just mentioned about, collaboration. Leo, do you see facade consultants and engineers nowadays being more open to working collaboratively to solve these performance issues up front? Or what is your experience?
Very much so, yeah. The attitude from the industry for sure is swinging towards more collaboration, to your point, Joel, earlier in the process. And I think the architectural community, if I can speak on others' behalf here in the room, welcome that same input early on. Kelly made mention of the owner's input. All of those, the owner and the envelope trades team, the earlier we get that collaboration, the better. I think you see it in the end result. Kelly made mention of one of the features of the BMO Convention Center was the black, we call it the pavilion. It's that swooping black leg that comes down to ground to the plaza in front of the building. On that one, we had two sets of contracting teams involved. The soffit of the underside was by Flynn, and we had very hands-on work with that team, designing the details and the folds in the panels. And then that had to actually meet a different team where we engaged heavy industries. Kelly made mention of them at the back of the room for the actual blackened aluminum that is the face of that pavilion. And so getting both of those trades partners, where two sets of cladding had to meet on a single fine line, was crucial. If we didn't have those parties at the table willing to collaborate, willing to work through details, willing to meet on site, willing to put mock-ups together, we wouldn't have had the success of the building.
Yeah, just to expand on that, we call it the pavilion because initially there was going to be maybe a small building on the end of that giant arm on the BMO Convention Center. And I think it's an important point because this delivery model allowed us to kind of park what this was going to be that you see in the image here for a little while. And it's interesting, we still call it the pavilion, even though it's not a pavilion at all. It went through many, many, many iterations, but if this was a design bid build, that opportunity just simply wouldn't have existed to think about what this could be as we developed the design further and as Stampede continued to think about what this plaza in this area was needed to support. And so it ended up being what you see in these images, but that's why we call it the pavilion. And this delivery model allowed us to do that, to kind of park the thinking around what that really special piece could be on the end of the arm. And just thinking about what Joel mentioned, not from a performance perspective, but from a design perspective, we were able to kind of play around with things with the support of our contractors and the various trades. I'm just thinking about the barn concept, Leo, and how we actually did full-scale mock-ups, and then we worked with our those that were constructing it and suppliers to think about the ratio of colors and how to get the effect we needed. And that couldn't have happened in a simple set of drawings. We played around. In fact, I think one of them suggested some of the panels can just be flipped upside down to give them a slightly different color so that we didn't have the cost of an additional fifth color. And so things like that could have just simply never happened in a different kind of delivery model.
Thank you very much, Kelly. I just want to fold Joel in again. I have a question for you, Joel. Do you have any lessons learned to architects when designing facade designs? Is there anything specifically, that you would like to set out in the industry for us with your 30 years of experience in the building sciences?
Well, early, carrying on with the theme, early involvement is, I believe, critical. I respect the architecture of a building, and often that form and the intent is established very early on. And we want to be in a position where we can be yes people, assist with the design, help realize that, instead of, if we're engaged too late in the process, we're the no people. This can't be done because of this, or this beautiful element has to change in order to achieve a given performance attribute. And so truly early involvement before designs are worked through, as systems are being identified, considered, we can help achieve that vision. We can help overcome challenges in ways that still respect the architecture while still checking all the boxes of the increasingly number of boxes that have to get checked.
Thank you. Yes, it's really about collaboration amongst all the stakeholders in the project. And how early would you say is early enough? What is the process that you've seen?
Well, I'll say when I started 30 years ago, there was almost no involvement in the design process. My very first involvement on projects was really in the field, and it was making sure the contractor didn't add soap to stucco mixes and things like that. Then it evolved, and we were reviewing basically completed drawings, maybe sometimes a week before building permit. And I'm not joking. It would be like, here's a set of drawings, review them. In retrospect, I find that ridiculous. What kind of meaningful impact can you make? What kind of meaningful changes can be made? I mean, time has gone, budgets have been spent, everything has been established. So the earlier the better. I don't think there's a too early. I think somewhere after concept stage is the right stage. There can be increasing levels of involvement that we participate in. But buildings are complex. There's obviously the interrelationship with the mechanical systems, the envelope, the architecture, and being able to have the dialogue, being able to understand each profession's and ideally each trade's perspectives can ultimately mean that a better solution is arrived at. So before any of the design elements or major systems get selected or finalized, before they get built into the budgets, I think is the right time. It allows the greatest flexibility. I've been involved in some projects that have shifted dramatically, but very, very early on from what everybody had originally thought was going to happen, because we had the time to procure an innovative system and work through its issues and have it tested and vetted. But if we were involved later on, let's say in design development, that development permit has been established. We're not changing any of the basics without going back for amendments, and that's not a good look, and nobody wants to do that.
From a client perspective, I was just going to add, if we don't have that early input as you've described, for us it becomes a bit of a PR nightmare potentially, because we are publicly, issuing out to the world what we're going to build through renderings and generating interest and doing all these things that lead up to it, that for the most part you wouldn't have any sort of care about. So, and so anyway, it allows us to get some certainty around, can we do this, so that you are the yes guy and not the no guy? Because if you're the no guy, then I'm really in trouble when I've shared the renderings with the world. So, I mean, it's an important piece from a client perspective, not so important maybe from the rest of the team, but for us, it really matters. We want to be able to deliver on the commitment that we said we would. And so we are unable to do that without the early input.
And it can be a challenge sometimes for owners, because they oftentimes, not all the time, but will often see early involvement as an additional cost. It's sort of no line item, and then they'll see, okay, if we bring the envelope consultant on board early, what was zero is now a certain amount of money, and they'll look at it as additional expense. But ultimately, it will result, I believe, in cost savings for the project in order to meet all the criteria. So it becomes a challenge to sort of see through that. Early involvement can avoid a lot of problems because you're avoiding what hasn't happened yet.
Yeah, so there's more cost up front, but less surprises later.
Correct.
Kelly, we saw a beautiful presentation earlier this morning, the Workland Center. It's really an amazing building. I think it's going to really change the landscape here in Calgary. And you're doing that project also with CMLC. I'm curious to know, what has been your approach for structuring resources with a project with this beautiful facade?
I mean, a lot of the things we've already talked about. I think one of the really important pieces on the expansion, which is the new building part of the Workland Center campus, has been the focus on the facade. And in this particular project, the pre-qualification process, I think, is a really important piece in that. I think anybody would agree to that, is making sure that whoever we're bringing on board can actually meet the design intent. But then we also have a series of what we refer to as demystifying meetings, and so an opportunity for trades contractors to come and ask all kinds of questions. So that's kind of one of the things that we structure early enough on to be able to leverage that for not necessarily cost certainty, but I mean, information translates directly into savings, I think, meaning that anyone will price and risk for something they don't fully understand. So I think that that's kind of one of the resourcing related things that we do on most of our projects, is we give opportunity for lots of good questions. And then actually what it does is highlights things for us that perhaps we hadn't, that the three of us or whoever we represent, perhaps we haven't considered. Those that are building it will obviously have more insight into some of the challenges we might face than we initially might have thought of.
It's interesting that you mentioned this demystifying meetings, because that links also to collaboration. And yes.
Yeah.
And that, that's really where the industry is going with integrated project delivery and alliance procurement and progressive design build. It's really a more progressive, collaborative approach.
100%. And I think the theme that you're hearing through all of our comments is selection of partners is critical. I mean, you can select partners that are more or less willing to collaborate, have a tolerance to a greater extent or lesser extent for client intervention, let's call it, or need for information or whatever those things are. And so I think selection of the partners across the board on any of these types of projects is critically important for sure.
Yeah, and with the integrated project delivery, it's really, as you mentioned, it is who you're working with, because how the fees are set up in an IPD. It's the good, the bad, and the ugly. It can be really good if you have correct partners, but it can also go not so good if you're profit sharing and the project is maybe not on track. Thank you. That's very interesting. I'm going to ask a closing question here. Across your roles, where do you see the biggest change in the landscape in procurement and facade design? I'm going to start with Leo.
I think we've already been talking about it, and that is shifting forward the participation of trades and design partners and building science specialists much earlier in the process than we used to. The other thing that I would say, and it's kind of building on a comment you made earlier, Joel, I would suggest the owners in whether it's IPD models or progressive design build or even CM at risk, encouraging shifting budgets forward to support that model, and also tolerance in budgets for mock-ups. In a handful of examples, and I'll cite the BMO one here, many of the decisions that were made involved the owner and the development partners and the trades all standing around the mock-ups, both for that blackened aluminum, but also the large composite aluminum panels, 10 feet long, hanging in the air 50 feet up, choosing the colors, choosing the perforation size, would not have been possible if budget had not been pulled forward to support those mock-ups.
Thank you. Joel?
I do see the industry shifting to earlier, as we're saying, earlier consultation. I do see it becoming more collaborative. The earlier processes that I was involved in that were design charrettes and had multiple professionals involved were good. It was a good start, but it wasn't truly collaborative. People were bringing their, I'm going to call it siloed designs, to the table together. I see now a lot more of the dialogue, a lot more of, as you mentioned earlier, sort of breaking the ice, getting to understand where everybody's priorities are. And truly, I do see more collaboration on that side. I'm also seeing, and this doesn't necessarily go to the local procurement as one of the earlier presenters was emphasizing, but I'm seeing a lot more globalization of the facade industry. There's a lot more products from every corner of the world in these markets. I see more willingness to bring those products in, to entertain them, to evaluate them in order to achieve the budgets and the designs that people are looking for.
Thank you. I guess there's a sustainability to that as well in bringing in something versus using a local product. Sometimes very difficult to balance that as well.
Absolutely. I mean, it's a blanket. You pull it somewhere, it gets short somewhere else. It's almost impossible to sort of not have some level of compromise. So that obviously is an aspect that isn't great for local economies and local, support, as well as sustainability, embodied carbon and whatnot. But it's still a trend that I am seeing in the industry, where I am seeing a far greater willingness and even desire to look elsewhere. Sometimes local can be comfortable in their supply, and sometimes it's you can have anything you want as long as it's that one. And sometimes the clients are going, no, that isn't the one I want something else. I'm seeing that beginning to shift, but I saw it shift first from overseas, not domestic suppliers.
And Kaylee, before we jump to your thoughts on the future of procurement and facades, just building on that question that we were speaking with Joel about, do you see or do you have any experience with CMLC using foreign materials versus local?
For sure, but I think what Joel is describing supports what we've all seen over certainly the last 6 years. So in my 26 years living in this world, it's only been the last 5 or 6 that I've ever encountered the kind of scenarios of COVID and now all the global craziness that's happening. And so we've been forced into a position to come up with a plan B and a plan C related to primarily like supply disruption and, crazy fluctuations in cost. And so what we might have viewed as problematic from a sustainability perspective 10 years ago is now giving us some advantages in terms of sourcing things or coming up with alternates that we might have never considered prior to this point. So I think it's a good thing, and I think you're right. It's just a matter of like, is the client wanting to move this way or this way? But I think your point is a good one. It's like globalization allows us more opportunity should we choose to go down that route.
Yes, and equally it stimulates our local economy, like Joel made. Like there's an opportunity there for somebody in a local economy to go into that little market niche, should they wish.
And that is what I've seen. I've seen the local market beginning to respond because of a lot of the international pressures and what they saw coming in the market. So we are seeing that response now from the locals, let's say.
I'll add to that point too around another key shift where things are changing is the 3D visualizations that can be provided at shop drawing stage or by cladding teams. Blowing the socks off what we used to see 5 years ago or even 10 years ago. And a lot of that is coming from international circles, what's being done in other parts of the world, bringing that degree of sophistication here. And we saw it on some of the examples you're seeing on the screen where what used to be very simple 2D shop drawings, now we're getting the 3D, we're sharing our 3D models from the design team onto the envelope team. The envelope team in turn takes that and produces amazing visualizations and details that we previously wouldn't have seen.
Once again, it's that collaborative sphere that we're really going into. Kaylee, where do you see the biggest opportunity for procurement and facades in the next 5 years?
I think to leverage these relationships even to a greater extent than we have now that we recognize all the benefits of these things to a greater extent. I think we're now all seeing, we saw Kyle do, this amazing presentation prior to ours, Glenbow, and I'm thinking about Workland Center upcoming, that's under construction now, BMO, lots of great projects happening around the city, and good enough just isn't good enough anymore. So we all want to build better, bigger, and more unique. And so I think, just leveraging what we've discussed today, great partnerships, early involvement, covering those costs and thinking about them early on so that we can be bigger and better.
Thank you. And I just want to ask Leo, with what you just mentioned with, technologies advancing and having more complex models, more complex geometry, have you seen AI being, playing a role in facade design and procurement in your experience as an architect?
I would say yes, for sure. What I think we've all seen drastic changes in what AI can produce at the conceptual design stage, for sure. I can't say that we've seen it yet in terms of the technical execution on that side of the pendulum, but probably we will be surprised at what's yet to come.
I agree. Thank you to our panelists. This brings us to the close of our presentation. Thank you all for joining us. And thank you for our audience. It was really a pleasure to be here with you. Thank you.
So if you were part of a panel or speaking in this session, please come up for a photo and a thank you. Thank you so much to this panel. And please go network now and have lunch. And see you in a bit. Welcome back. Grab a seat. I hope everybody got some lunch and more importantly, some networking. I know I did. We have a few more excellent presentations. Starting with Robert Clement, principal from Populous. Ready to go? Yep. So yes, we're going to talk about the BMO, maintaining design intent through the design build and design assist process.
How's everyone doing today? Good lunch. Okay, my name is Rob Clement. I'm with Populous. I was the project architect for Populous. We were leading the design effort along with our partners for the BMO Center. Get into here. Okay, I hope you all get a chance to go see the building. It's a wonderful example of a convention center where you can exhibit it, or you can visit it. You can actually experience it from the exterior as well as on the interior. In addition to Populous, I want to recognize some of our partners. I don't think they're up on the screen. Stantec Architects and Engineers, S2O Architecture, PCL Construction, Flynn Exterior Cladding, Heavy Industries, Metal Designer and Fabricators, Ferguson Exterior Glazing, and our lighting designers, EOS Light Media. They were all instrumental in the design process and the actual execution of this project. So what I want to do is talk a little bit about collaboration. And ironically, Leo with Stantec and Kelly Coles with the city, we're up here talking about the same subject. So I'm going to cover a little bit of what they talked about, which is the design assist model. But I'm going to kind of get into it a little bit more in detail and how it actually informed the design process of the BMO Center itself. So again, I want to stress collaboration is one of the things that we really spend a lot of time at Populous participating in. And it starts at the highest level. So collaboration at the conceptual level requires buy-in from all the various client groups from the start. I think you might see Kelly in a couple of these images. You certainly see Leo up there. Without a great client group, it's very difficult to get a lot of projects off the ground. Again, it's partnering. It's those partners, it's those clients that really elevate the concepts of a project above and beyond. We're going to talk a little bit about the story. As the design team begins to create the narrative story, it's imperative that the full team starts to participate in that storyline also. You're all creating the narrative together. You're all building the concepts together. You're all moving forward the project together. And let's see if I can go back. And that's why that's so important is basically, as the team spends so much time going through the many, many design iterations, and this kind of shows you some of the collaborative process that we participate in. What you can see on the wall there is essentially a small portion of about 100 different concepts that we started working through for the BMO Center. And again, this is with CMLC, this is with Calgary Stampede, and it's with all of our partners. And the result is something you get like this. So today I'd like to walk you through three aspects, or three elements of the building design of BMO, and there's a lot of them, I can assure you, that really highlight the design assist process. So the first thing I want to talk about is just the building mass itself. And when I refer to the mass, I'm talking about the metal-cladded top structure. I'm going to hit on the concept process, the evolution of that design, the point where we bring the trade partners in and actually start making the design real, and then again, the final result. So again, this was the vision, this is the rendering, this was the vision that was crafted with the CMLC and Calgary Stampede teams. And this is the actual real product. The concept of the forum took root in the notion of memorializing the corral. This was something very important to Stampede. The image up there, the legacy. So for those of you who don't know the corral was essentially the old arena. I forgot when it dated back to, like 1960, I believe. That was getting demoed as part of the expansion. And Stampede was looking for a way to kind of memorialize those. So the idea of the notion of the forum is the forum starts to create a space around. So it's more about the absence of the corral and then using that as a new spirit to draw people into it. And really, that's what started the entire idea of the plaza, was this kind of abstracted notion of the corral. The materiality of the forum pulled from the local culture of the greater Calgary community. We were looking to involve the spirit of the West, the spirit of Stampede, of course, and of course the festive nature of the 10-day rodeo. I don't know if any of you have ever been to Calgary Stampede. It's a one-time. You got to go. Greatest outdoor show on earth. And essentially the Midway too. We got a couple images of the Midway. It's that idea of excitement. So this is one of the earlier renderings, and it really kind of pulls upon some of the iconography of the Midway itself, of Money Alley. And it starts to show this kind of fluid relationship of the building. And again, this is the convention center to the rest of Stampede Park. And it starts to make concessions also to the greater community itself. Materiality, we wanted to reflect both the past and future of the Calgary Stampede, the grit, the toughness, the durability of, and the timeless factors of it. So these were all elements we were pulling into this whole move, this whole gesture, this whole notion. Scale was another significant aspect, the human scale particularly. The form itself grows from the lower right-hand corner at the, what I'm going to call it, to the lantern. We're going to talk about that a little bit, but it comes down to the park, which is more the human scale. And then it kind of, it's like someone throwing a hammer, essentially. It kind of spins into I can't say it, into a form where it all of a sudden releases up at the upper left-hand side here at the ballroom mass itself. So it's a building form that is spinning kind of onto itself, and that's onto itself is the plaza. The next image, and these are really preliminary renderings. The next one really shows the relationship of that ballroom facility, elevated, I think it was 80 feet up in the air, that's overlooking the Stampede Park. That was something that was critical for the building itself to create that relationship back to the Stampede Park Fairgrounds. And of course, the idea of the dramatic cantilever kind of developed out of this notion too. The other critical thing that ties it back to the city and the community of Calgary is this idea of being visible from 17th Avenue. If you ever walk down 17th, you'll be able to see it in the distance. It's that notion of tying the park back to the greater city fabric. And architects being architects, we started kind of exploring the idea of how the building starts to stretch. It starts to reach into the park, how it starts to bend into the park, how it starts to respond a little bit to the sun itself. This is primarily facing south southwest, you have views of the mountains. You also have views of the park itself. And we like this idea of this interaction between the people in the fairgrounds and the building itself. So this is when the trade partners come into play. PCL was the construction manager. Flynn did the exterior panels, and Ferguson, I think I've heard them referenced at least once today, did the glazing. This is the northwest corner. The actual ballroom facade is just around the corner on the right. So what you do is you have a bunch of architects trying to bend and do things with an ACM panel, right? It's 10 feet wide, 2.5 feet tall. There's some restrictions. And that's when the merger between design and construction starts to happen. You know, the team is trying to create as much tension out of the form itself, and the contractor's kind of raising his hand saying, well, we got some problems here. This is one place we didn't want to compromise. This is one place where we started looking at maybe we had to bend and break the panels a little bit to get the desired result. So what you can see is a diagonal down there across the facade where the panels start to pull off the facade. And you can see it really dramatically here. We were looking for something that, this is what the contractor, or this is what Flynn was looking on the left. This is what we can do with the limitations. However, the steel was already going up, and we're already starting to pull those panels off. So we had to come up with a compromise. And this is really where that collaborative effort happened. In order to get some of those tolerances, and we're talking about several millimeters over a 1 foot span, you had to find a new way to actually bend the material to where you start to break the material a little bit. And this is an example of it. So upon that last corner, you're really starting to see all these panels start to bend and break down the diagonal. Another good example of where Flynn came back and helped us kind of figure out this scenario. This is the ballroom facade. We were going to have to do a similar fashion to what we did on the other facade, the opposite facade, where we're going to start bending the panels to make them work. Here we're able to facet the actual panels by the attachment of them. So it's really kind of a faceted facade to create the illusion of that bending look. And this is another study of the southeast facade. The most severe were on the back side. This is over by the what we call the patio at the very top of the canopy. But again, this shows you kind of the collaborative nature between the architects and the contractors. We knew we had some issues. We could figure a lot of it out on our own, but there were times when the contractor needed to step in and actually assist us, saying, you can do this, but you can't do that. And then that's where the merger came into play. And even in the selection of panels themselves, we had a lot of trouble trying to find the right coloration, the right reflectivity. Michael is giving the seal of approval here that we actually got to a point where we started finding the colors that we liked. And again, this takes work and time. And this is the final result. You can really see the dramatic bend. And if you look real closely, you can start to see the actual diagonal of where we start to peel that corner off too. So I want to talk about the lantern next. And again, where we started the concept, how the process evolved through design. And then once you bring the trade partners on, you start to get into something that could actually be executionable. Okay, this rendering shows a lot. This is the activated rendering of the lantern and the grandstand. I think they referenced this in the previous presentation. We also called it the pavilion for a long time. But what I want to focus on is the actual structural expression of the two pavilions, of the lantern and the grandstand. So the pavilion, I think, and Kelly Coles had mentioned it too, we didn't know what to call it originally. It was something that we knew what it was, but we didn't have a design for it. It took us months. I think probably actually took us over a year to actually come to with the design. We knew it wanted to be a beacon for the community. We knew it wanted also to be a backdrop for the BMO Center, and we also knew it wanted to be a bandstand for the park itself. So we had all these great ideas. We're just trying to find some sort of resolution for it. We sketched it over and over and over. We came up with some materials, again, showing the grit, showing the toughness, durability that Stampede gravitated towards. And we ended up with this kind of concept of an occupied space. But we didn't exactly know what to do with it. It was accessible to everyone. Yeah, kind of, but if the facility was closed, then it wasn't quite accessible. It was bright. We knew it had a lot of attention at night, but we didn't know what to do with it. We started programming it too, giving it some functionality. But at the end of the day, we knew it had to be iconic. And we knew it had to attract people. And the idea here is it had to be accessible too. One of the themes of the project was 365. We want to activate the project 365 days a year. We didn't want to just activate it during the 10-day festival. And it had to be 24/7 too. So we ended up looking kind of at a way of simplifying what we wanted to do out here. Simplifying it down to the point of just providing more cladding for the structure, and then figure out where we want to go from there. So here, we have an idea of, okay, we're just going to go back, and we're going to provide cladding, and we're going to start kind of understanding exactly what we need to do. We know we need to cover up the structure. We have the two posts. We also know we need to cover up the cross bracing. So we started cladding those, and we have the left one on the right, or the left leg on the left, excuse me. That's the one facing the road. I'm sorry, that's the one facing the plaza. The one on the right was the one facing the road. So we start to think about how we can program these in other ways where it's not someone walking in the door. So we start thinking about the lantern element, which is the one on the right. Maybe it starts to take on a different form. Maybe it becomes more expressive, and the one on the left would be just more of a bandstand, band shell for the actual park itself. So we start doing modeling of it too. And we know it just needs to be simplified. We know we're getting into an era where it's starting to become more expensive, more sculptural, and so we wanted to find a solution that would be cost effective. And that's when we got trade partners involved, primarily heavy industries and Flynn. Of course, they came back and said, how are you going to build this? And we're like, well, that's why you're here, right? And of course, they came to the table, well, we got to find a way to panelize it. It needs to be simpler. We need to break it down so it actually starts to become economical for us to recreate it and come up with a couple shapes, put it on a tool and die, and then actually bend it. So this is Heavy's, one of their earlier attempts too, to come in and say, okay, we're going to look at finding a way to panelize this thing and simplify it. And then Heavy went above and beyond. They started looking at, okay, what's the human experience here? And how do we make that stronger? Particularly with the human scale. You can see the image on the right. These things are massive. And there's this gravity towards this concept. And the material that we were looking at was the idea of the blackened steel. We had been using it on the inside of the building. And Stampede was attracted to it. They really liked it. So we looked at the idea of using it on the exterior for this also. And I think as Leo alluded to, it eventually became an aluminum product, but we wanted the weight of feeling the blackened steel on those panels against you when you're walking by it. And we wanted the angle and the position to put it in a precarious manner also. And what these provided us also was a way to start really looking at the details themselves. How big are the panels? Maybe the panels get a little smaller when you get down to the ground. Maybe they start to diminish. Maybe it takes on more of a human scale where someone actually can touch it, to actually feel it. And this is kind of another example of that. These are, again, three-dimensional, really meant to stress this kind of concept of steel, weight, and find ways to highlight the interaction with people. And of course, the mock-up. Heavy was great about doing mock-ups. I think Leo mentioned it too earlier on. It's critical for you and the partner to get out there and explore and understand how this thing is assembled. Where are the fasteners? How is this thing going to actually be attached? There's a lot of complexity here, a lot of additional steel, a lot of thinking through the details. is something too sharp? Is there, Kelly had mentioned too, it's the fact of when you have a child or someone's actually kind of up next to it, making sure all the joints are not too sharp, not too rigid, not too dangerous. And of course, the result, something that's very rustic, something that's very hand-wrought, something that's very weathered, and in a way kind of historical, which Stampede really gravitated towards. So the last element here I want to talk about is the canopy. So we'll talk quickly about the conceptual process. We'll talk about how the design evolved. We'll talk about then how the design further evolved with the trade partners getting involved. And we're going to talk about the result. Here, one thing I want to show is the activated element now. Of course, we have the lantern and we have the canopy. The canopy is the extension back onto the building itself. Both elements work together, and one thing I want to stress here is that even though I'm breaking all these elements into 3 different parts to kind of talk about one each individually, we're really talking about design as a holistic process. You can't just break them apart and do them separately. Even though we are doing one element of the project at one time and do another at the other time, there's always this larger vision, and I think this is a good example of where you're looking through and seeing the form of the building start to peel into the actual canopy and start to manipulate and become this pavilion / lantern concept. And I think Leo was showing this one earlier too, and this is the result. So let's talk about this a little bit. The concept initially was that of a gateway. It was something that everyone liked. It was very gravitational. Stampede liked it, CMLC liked it. There's the stadium that's being built right now just down the street. This was a way for people to come into the park. So it really was a gateway, not just for the BMO Center as an entrance, but to the Stampede Park, but also the community too. So this was something that we really knew was working at first. We wanted to build on the idea that the campfire, this was something that was kicked around quite a bit early on conceptually. It's this primitive notion of gathering, right? It's traditional, it's ancient, it's prehistorical. What do men do early on? They gather around a fire to cook. It also has that frontier aspect to it, that vibe. It has the historical ties not only to the community, but also to the notion of kind of human existence. And then you can talk a little bit too about the fire itself. And this is something we kind of gravitated towards, the act of fire, the art of fire, the inspiration for the activation of the canopy and for the lantern too. In these series of images, you can see the fire embers. It's random, kind of floats into the night sky. It's activating, it's kind of mesmerizing, and the image on the right really starts to talk about how the embers take on a different quality. It's not just a speck, but it can also be seen as kind of this long kind of element. But it's always scattered, it's always random. The one thing we wanted to do, before we go there, was that we wanted the activation, this lighting effect, to be concealed. We want it to be a surprise. So when you walk up to it, there's this element of discovery. It's like, I didn't expect that. And I'm going to talk a little bit about that. But that was something that was really critical to the design of this canopy, this activation. So the canopy offered a lot of challenges in the first place. It was basically an extension or a pull from the form itself of the mass. In this diagram, you can see how it's pulling in on the different 3-4 sides, essentially. And the steel itself was a challenge also. So we had to find a way to basically come up with a solution that could be repeatable. And that's where the trade partners came in. We started taking the same panel that Flynn had developed on the exterior of the building and finding a way to organize them and basically order those panels into a pattern that could be repeatable, reproducible. And most importantly is something in economic terms too. EOS our lighting designer came in and said, okay, let's find a way to kind of make this work, this concept work where you have these kind of random flames, random embers coming up the lantern onto the canopy itself. Let's start figuring out how we're going to orientate those, how we're going to measure those, and let's find a way to make it so, again, it's something that can be reproducible. So the solution was to find essentially patterns for 6 different panels. So if you go out there and you're going to see a combination of panels, but this was the solution we kind of went forward with. There's the 2 tracks, the one going back towards the building and the other one going up towards the upper outdoor patio. This was the final outcome. The process to get there was a little bit more complicated. Really, it was a complication in the fact that we did not, again, want to see the light fixture. We wanted to conceal how do you get that much illumination out of a panel if you can't see the fixture. And so we started studying perforations. The one up here is 9 millimeter, all the way down to 6 millimeter. Is it too small? Is it too big? Is it the density of the pattern? Is it the way the pattern's oriented? And then we put together 4 series of groupings to start understanding. So if you can imagine the groupings on the side, but these are the embers that are washing up into the sky. I think we ended up with the second from the bottom, I think is the one we ended up going with. But each one was kind of a revelation. And again, this is heavy. And Flynn and EOS collaborating on finding a good solution to make a project successful. And it took some number of iterations, basically, for mocking up the different assemblies. And again, this is what Leo had alluded to earlier. We really needed to see the actual mock-ups of the patterns to step back and look at those and understand how are they going to react when you actually see it when it's 60, 70 feet above your head. And again, go back to the earlier rendering. This was the concept, this gateway, not only into the facility itself, but also into the park. And then you get something pretty dramatic like that. I don't know if you guys had a chance to go see it, but go see it at night. It's really worth it. And again, you don't see the perforations until you get really up close to them, and then even then, they're not always evident. So on closing, I just want to say the design process for the BMO was really a holistic approach. I know I kind of showed you kind of 3 little snippets of it. But it's something that took a lot of time, a lot of effort, and a lot of collaboration from all of our trade partners, design teams, and also ownership. Without ownership of the concept of the story by CMLC and by Stampede, it's really hard to achieve a project as dramatic as this. I'd like to end with this. Great design and great projects require several things. Great clients and great partners. So thank you, appreciate it.
Excellent. Another excellent presentation. Now, we will have Mira Saba, who's going to come and talk about facade air tightness and quantifying air leakage rates in commercial facades.
All right. Hi, everybody. I'm really excited to be here. As was mentioned, I'm Mira, and I'm here to present on facade air tightness and quantifying air leakage rates in commercial facades. A little bit about me before we get started. I am a building envelope engineer, and I work at RJC Engineers. I'm a professional engineer, and I'm really proud to say that I am a certified thermal modeler. And so what that means is I do a lot of thermal modeling in my day-to-day, and I work with energy modelers to make the most, to make the architectural visions that we've seen all throughout today's presentations come true, and for the performance to live up to the expectations as well. Okay, so with a presentation of this size, I do like to put together an agenda just to go over what we're going to be talking about. I feel like you can tell I'm an engineer, very methodical of me. So the first thing we're going to be talking about is the advantages of airtightness testing to achieve energy targets and NECB compliance. Next, we're going to move on to airtightness considerations in design and tools to monitor airtightness in construction. And finally, we're going to be talking about the actual airtightness testing, the procedure, the limitations, logistics, and challenges. So let's start with that first one, advantages of airtightness testing to achieve energy targets. So before we talk about airtightness testing, I think it's important to highlight how the National Energy Code requires you to show compliance. So there are 3 approaches that you can take, and that's what's shown on the screen. You can either take the prescriptive path, the trade-off path, or the performance path. Essentially, the difference between the 3 is the amount of flexibility that you have. So for the prescriptive path, it's quite like an instruction manual or a recipe where the code essentially tells you, these are the minimum thermal characteristics that you need to meet for each of your envelope components. You need to have an R value of this for your walls, and so on. Your trade-off path provides you with a little bit more flexibility. Essentially, it allows you to trade, like a thermal characteristic of one envelope component for another. So for example, maybe you make your walls more thermally efficient, but you make your windows less thermally efficient. So that's the trade-off. And finally, the performance path, which is the one that we see quite often in the industry, it's because it has the most flexibility, and it's taken when the other 2 are too limiting. Essentially, with the performance path, what you need to do is you'll model your building, and you need to demonstrate that your building has less energy consumption than had you done it following the prescriptive path. So typically how this is done is energy modelers will make 2 models, what they call the reference model, which is the prescriptive path model, and then your proposed model, which is what you would actually like to build. And they'll get an energy consumption output out of those 2 models, compare the 2, and as long as the building that you would like to build consumes less energy than the other one, then you're good to go. You've demonstrated compliance. Regardless of which one of these paths you take, at a high level, the National Energy Code of Canada requires you to consider the following metrics: building envelope, lighting, mechanical systems, and service water systems. And because I'm a building envelope engineer, I'm just going to stick to the building envelope stuff, which breaks down further into thermal performance and air leakage. And I feel like all throughout today, we've heard lots about thermal performance. One of the things that happens when you have your proposed building, you run the energy model, and the energy model tells you you don't comply. One of the first things that comes up is thermal performance. We can add more insulation to our walls perhaps, or we can go to triple pane instead of double pane. Those are all ideas that get thrown out. But I think the one thing that doesn't often get discussed is actually air leakage, because the amount of air leakage paths that you have through your building envelope greatly impacts the performance of your building envelope. And I think it's because air leakage is one of those metrics that almost is described in a qualitative way. It's like you can feel that there's an air leakage path, but you don't actually know how much air leakage is actually going through that path. And so that's what I'd like to explore today. So you can tell it's very engineer. Like, I needed an architect to help me put this together and make it all beautiful. You guys do great at what you do. Air tightness, I want to just chat about that to start. Air tightness is defined as the control of air through a building envelope that separates your interior conditioned air from your exterior unconditioned air. It's essentially all your air leakage paths. And the air tightness of your building will dictate how much of that air that you spend so much energy and cost to heat or cool, how much of that air is escaping through your building envelope. Because the more of that air that escapes through your building envelope, the harder that your mechanical systems have to work. You're driving up your energy consumption, your building's carbon footprint, and the cost to operate. So I'd like to read this blurb right from the National Energy Code of Canada that states, "The air barrier system shall have a normalized air leakage rate of not greater than 1.5 liters per second meter squared when tested in accordance with the ASTM standard that's shown on the screen, at a pressure differential of 75 pascals. Now, I don't know about you, but the first time I read that, I was like, what? Like, what do you mean? That makes no sense to me. And so I thought a lot about what the best way is to actually, show you how much air that actually code allows to leak through your buildings. And so 1.5 liters per second meter squared is equivalent to 90 liters per minute for every 1 meter by 1 meter square of your building envelope. Okay? So what does that mean? That's 22 and a half 4-liter milk jugs being poured through a meter by meter square of your building envelope area every minute. Every minute. And what I'd like to tell you today is that modern building envelopes are actually performing far better than people assume and far better than code allows you to assume, as long as the air barrier is designed well and built well. The second point that I'd like to make today is that the energy code allows you to do one of two things. And I've lost my mouse. I'm like awful at technology, apparently. I don't know. Anyways, but it allows you to do one of two things. The first is take your default air leakage rate, which is that 1.5 number. I'm going to stop saying liters per second meter squared because that's just a mouthful. So you guys will just know when I say 1.5, that's what I'm talking about. You can either take the default 1.5 number, or you can actually do an air tightness test of your building and use the number that you get from your air tightness test in your energy model. And I want to say there are more benefits to doing that than just the fact that you can put that number in your energy model. Air tightness testing allows you to actually identify where your performance deficient areas are at a time when you can actually fix them, right? While the building's being built, as opposed to the building being enclosed and then having to take things off to address the problem areas. So there's a lot of other advantages in addition to what I'm talking about today to actually testing. So what I'd like to do today is actually walk you through a case study that I did and the air tightness testing data that we've done as a company to kind of prove this point. So air tightness testing data. So the data that I'd like to show is on the screen there. The first parameter that I want to look at is the y-axis, the left-hand side there. That is your normalized air leakage rate. So again, that 1.5 number that I was talking about earlier is shown in that red line across the graph. 3 important points to talk about. The first is the air barrier strategy. Okay, the air barrier strategy matters. And I think we know this. There are air barriers that perform better than others. And so the 2 that I looked at for today's presentation that are most relevant to commercial applications are self-adhered membranes, which is shown on the left, and taped water-resistive barriers, which is shown on the right. And what the data shows is that self-adhered membranes tend to perform better than taped water-resistive barriers. So that's point number 1. Point number 2 is, regardless of the air barrier strategy, there's a range of air leakage rates. So what that tells you is that the design and the construction, the installation of whatever membrane you choose also matters. We knew that. And finally, I want to talk about the actual data itself. So, with self-adhered membranes, even the leakiest of the buildings that we tested were far better than the air leakage rate than that the NECB allows you to assume. And so even the leakiest of buildings for self-adhered membranes was still 24% better than the required assumption from the National Energy Code. And for water-resistive barriers, it was still 13% better. And it can go all the way down to 81% better and 70% better from the tested data that we've collected across the air tightness tests that we've done. And so an average of that range is about 50% better. Okay? So kind of what I'd like to talk about today is that we have proven data that supports that common air barrier practices that are already being accepted and implemented in the industry, the default air leakage rate can consistently be beat. So essentially, what I'm trying to say is that your buildings may already be meeting the requirements of the National Energy Code, and the assumptions that you are inputting into your energy model may in fact be too conservative. And so we're combating that by adding layers and layers of insulation or increasing thermal performance when you didn't actually need to do that at all. So I'm going to walk you through this case study. This is an energy model that we had already put together. This is for a building that's located in Richmond, BC. It contains a 2-story office building with a 1-story warehouse that's attached. And what I did with this case study is updated the energy model, so for the current study, to compare the effects of adding insulation thickness to improving airtightness. And so the first thing that I'd like to highlight with this case study is just insulation improvements. So baseline case number 0, that's shown on the x-axis, the bottom there, essentially is just insulation between steel studs, okay? And an air leakage rate of 1.5. So air leakage is not considered in this graph. It stays 1.5 consistently. And then case number 1, I added 1 inch of exterior insulation to that wall assembly. Case number 2, I added 2 inches. Case number 3, I added 3 inches, and so on. And so what that shows is, with every inch of insulation, from the first data point to the second, there was a 1.1% reduction in energy consumption. From the first inch to the second inch, there was 0.6% energy consumption reduction. Second to third, 0.3%. So with every inch of insulation that you add, the impact to the annual energy consumption is less and less and less. So remember this green data line, because we're going to take it to this next slide. That green data line is the same one. That is still insulation thickness being added to the exterior of the wall. And now I've added a blue data line, which essentially is your air leakage improvements. Okay, so even with going to the first data point, I improved the air leakage rate by 20%, and 40% on the second one, and 60% on the last one. And if you remember, with self-adhered membranes from the data that we've collected, even the leakiest building was 24% better. Okay, so that first data point is very, very feasible. And you can see the annual energy consumption that is like a result of air leakage is much less than had you put layers and layers of insulation on the exterior of your walls. Actually, 3 inches of insulation, that last green data point, correlates to about 14% air leakage reduction. So you can see the impact of air leakage on your energy performance is substantial. Next item, airtightness considerations in design and tools to monitor airtightness in construction. So it all starts with good airtightness practices in design. And the first step to actually, defining good air barrier practices in design is establishing where is your air barrier throughout your building envelope. Drawing that line consistently, as you can see on the right-hand side, where is my air barrier plane? And the second is, these pictures are both taken from CSA Z5010, which is the thermal bridging guide. On the left-hand side, this is a diagram of buildings showing common thermal bridging locations, but it's quite relevant to air leakage as well, because these are locations, the interfaces, where we see the most discontinuities in your air barrier throughout. And it's because, half the time, these are areas where there's trade interfaces, the weakest link, as someone mentioned earlier. So your roof to wall transitions, your intermediate floor slabs, your wall to foundation, any building penetrations, anything that actually projects through your building envelope, corners, windows, doors, all areas that need detailing to achieve a good air barrier across. These are things that are well known already. So that's what I'm trying to tell you is we're already doing it. We're already doing it. These are some details that I just put together. Again, not as pretty, but get the job done. it's really important to start detailing these not that I have a 3D detail on there, but 3D details provide a lot of value, especially at tricky interfaces. Instead of having to deal with them on site as part of mock-ups, it is valuable to provide some sort of direction to the contracting team to be able to achieve these air tightness targets that we're looking for. I remember when I first was being taught what the heck a line of air tightness is. My boss told me, pick up a blue pen, start on one end of the detail, and if you don't pick it up by the end of the detail, then you have a good line of air tightness across your detail. So that's what I've done here. That's my line of air tightness across the detail. We have a continuous air barrier. Good to go. More examples of practices in design. Wall to foundation interfaces, curtain wall. Curtain wall is, its whole thing. We had 2 presentations on curtain wall today. And then we're seeing a lot more of these structural penetrations that penetrate through your wall assembly. Detailing an air barrier around these is tricky and is worth the time. These are photos that I've taken from site. Did my mic turn off? We're good. Okay. Air tightness practices in design. These are photos that I've taken myself from construction throughout. Again, window to wall interfaces, how to detail conduits and mechanical penetrations, wall to foundation interfaces, your perimeter sealant beads around your spandrel backpans. Again, all things we're doing. And I think the most daunting thing about air tightness testing is the fact that you actually can't complete testing until a good portion or all of your air barrier is complete. And so I think that in itself, it's just an unknown. It's a risk that people don't like to take on. And so what I'd like to say is that there are tools that you can use to monitor air tightness during construction before we actually perform these air tightness tests. And so again, tools that I'm sure you have seen in the industry, blower doors, smoke pencil testing, and our newest tool, which is the ultrasonic air leakage detector. The smoke pencil and the ultrasonic air leakage detector are both qualitative tools, which is okay, as long as you can tell that there's actually an air leakage path, you can address it regardless of how much air leakage. If we can monitor that throughout construction, we have an even higher chance of hitting that target come the air tightness test itself. And then finally, I want to chat about air tightness testing procedures, the limitations, logistics, and challenges. I've run like 25 of these tests myself, and it's been a time, so. What people don't know about air tightness testing itself is that the actual air tightness test is actually quite a small component of air tightness testing. The test plan and the setup takes up the majority of the time. And so having an understanding of, again, where that air barrier plane is and calculating the building surface area and building volumes is absolutely critical to the success of the test. We need to understand how many fans we need to actually pressurize your buildings to be able to calculate the air leakage rate of your building. And so there's a lot of logistics that go into that. Again, I kind of already mentioned this, but building size, right, like number of fans. And the other consideration that I don't have on here is where all of your exterior doors are, because we need to set up the fans between conditioned and unconditioned space so that we can pressurize your building. And so it really does matter where your exterior doors are and how far apart they are so that we can get power to all of these fans. The other consideration is weather and occupancy. We are trying to create we're trying to pressurize the building, so any wind pressures that alter the pressure that we're trying to create significantly alter the accuracy of the test results. So we usually wait for weather days that are under 20 kilometers per hour, wind speeds, no rain. I mean, it's just not fun to be outside in the rain, so, well, maybe you guys have a different opinion, but occupancy also alters this test. I will say most of the tests that I've done have been in occupied buildings, but as that next point says, all interior doors need to be propped open so that it is one uniform space. And so with occupants, somebody needs to use the washroom, closes the door. It impacts the result of our test. And so that's another logistical item with these tests. And then depending on the size of the building, we may need like building operation and mechanical and electrical support to actually complete the test. Like I said, a lot of fans. And another consideration that like I feel like goes over my head sometimes is like, how am I actually getting these fans to site? Like it's a lot. Like half the time I have to get a U-Haul to get all of these things to site. Or, you know, put it all in my car, my poor car. More test plan and logistics. Like I said, it's like half of the battle, if not all of the battle, is actually set up. And because a lot of the time we are doing these tests like mid-construction when the air barrier is complete before the building is like fully complete. You know, there's stuff like the conduits that you see in that photo that like by the end of the construction will be all good to go and you know, run. I'm not an electrician, you could tell, but run from end to end. But for the actual purpose of the test, that's an air leakage path from outside to inside that won't be there at final construction. And so those all need to be taped and sealed. Essentially everything that's intended to ventilate will have to be sealed. We are only testing unintentional air leaks. And so again, your mechanical penetrations, how you actually get to all of your mechanical penetrations to seal them is another logistical thing. So you may need a boom lift or scaffolding or swing stage to actually seal all of these penetrations so that you can complete the test. And then test day comes. Test day typically involves us setting up a door, right? Like I said, and setting up a door with fans at an exterior door location. And then pressurizing and depressurizing the building, recording the air leakage rate at various pressures to determine your whole building air leakage rate. And I do want to say, you know, if the test fails, it doesn't mean that's it. And I think that's the general fear with these airtightness tests. And so what we do when we don't meet the target that we've assumed is we actually just use a handheld smoke generator. It's like quite simple and it's honestly really fun to do. Maybe not fun for you guys, but fun for me. But you know, you hold up a smoke generator against components of your building envelope and you see where the smoke travels between the outside and the inside. That's your air leakage path. And so you can very easily tell where all your air barrier discontinuities are and then seal them and address them accordingly at that time, run the test again, keep going until we get the target that you need. So this allows construction, installation, and design to be refined at this time when it's still accessible. So to summarize, what are advantages of airtightness testing? The first point that I'd like to make is that you can meet the requirements of the National Energy Code of Canada without changing your design. So our data shows that airtightness testing is one of the highest impact steps that you can take to improve compliance with the National Energy Code of Canada. The second point that I'd like to make is that real buildings perform better than the default air leakage rate. And when you rely on the default air leakage rate, you're often modeling a building that performs worse than what you've actually built. But when you test, you unlock this advantage. You can meet the targets of the energy code with the building that you've already designed and already built. And finally, the last point that I'd like to make is that air leakage reductions outperform insulation upgrades. With basic standard air barrier designs, we can meet this. Reducing air leakage rate delivers more energy savings than increasing insulation thickness. So I'd like to end with this. If you're deciding where to focus your effort, your budget, your time, the message is straightforward. Put your attention to airtightness. Thank you.
Thanks so much, Mira. I thought you were very eloquent, and I will forever remember the image of the milk jugs. That made sense to me. So thank you for that. Next, we have Mike Vanderveen from Lumen, North America. And Joshua Taryn from the University of Calgary? No, we do not. Sorry. Oh, that's the next one? Oh, that's the next one. Gotcha. Yeah, sorry, it's just Mike. Mike from Lumen. Creating immersive outdoor experiences with glazing technology. Thank you.
Thank you. It's just me. I know it's going to be underwhelming, but don't worry. We will get through this together. My name's Mike. I am the Emerging Markets Manager with Lumon. I oversee our dealers and resellers throughout Canada and the US. I'm going to chat today a little bit about creating immersive outdoor experiences with glazing technology. Say that 5 times fast. We're going to go through the current state of outdoor living spaces, how we can kind of disrupt things, shake it up a little bit, and then a few case studies to show some of these examples. So the current state, our balconies today, depressing, sad, unusable. Go outside today, you can see it's a very unenjoyable time to be outside. Too hot, too cold, too windy, too rainy, too snowy. Depending on where you live, you only get a couple months or days out of the year that you can use it. And what we're seeing now is people are being driven more towards an outdoor desire for spaces for their homes, whereas in the past, people really kind of saw balconies, outdoor living spaces as nice, but not really super desirable. Definitely after COVID, we saw things kind of shift where people were home more, and there was a bit more of a demand for these spaces as essential. However, with that being said, we also know city centers are very noisy. There's lots of traffic, neighbors, things like that. And with the ever rising cost of construction, houses, balconies are getting smaller and less usable. So people are looking to rent or buy together or do some sort of new shift on what they can do. People are also spending more time indoors, again, because that depressing picture of balconies, they're not always usable. So we are seeing now there's a desire for people to be outdoors more, with their buildings very optimal on the dollars that they're spending to build, but also be quieter. So I've just painted hopefully a very bleak picture, but don't worry, it does get better after this, and that is with the use of frameless retractable glazing. So by adding that to outdoor living spaces, we're seeing that people are able to use them more while getting some of those benefits of energy savings, noise reduction, and reduced maintenance costs. So where does Lumon come into that? Quickly, briefly, Lumon's a design company connecting indoor and outdoor spaces made of glass. They've been doing it for about 50 years in Finland, very large in Europe, and then just recently about 15 years here in North America, operating all over the globe with our products. So, what makes this difference for the balcony? We've seen it where if they add glazing to the balcony, they're able to reduce the life cycle replacement on facades, decks, and things like that to a longer time span, which is saving money on the maintenance costs for these buildings. So we're seeing here where they maybe are replacing or doing repairs every 10 years. We can extend that life cycle out to 20 years, which is then saving costs on the stratas and other areas. Additionally, energy savings are becoming a large thing now with the building code, with green initiatives. And so we're able to see when you add glazing onto a balcony, you can get anywhere from 4 to 14% a year energy savings. And that's just because now you have glass that's an extra buffer on the outdoor living space, and that's going to protect in the winter. Your apartment isn't going to cool down as fast, but on the flip side, in the summer, it's going to heat up and slow the heating into the home. And the plus side of that is the passive solar gain on the balcony makes it quite usable for the homeowner in the cooler times, which gets them into that closer to nature outdoor enjoyment. This kind of touches on that point I just mentioned, where people are able to spend that more time outside. With the frameless glass option, people are able to feel like they're outdoors, but it doesn't feel like the wind is, cutting them to pieces. They're not getting drenched with the rain. Patio furniture is not blown off and landing, in front of the C train or something. It's very manageable, just opening and closing a few glass panels. So we can see here where people are basically able to extend that life cycle and usage of the balcony into, for sure, the shoulder months of spring and fall, but in some of the more milder climates, and I'm going to call Calgary a milder climate here, into some of the winter months. The reason I say milder climates like Calgary is because we get so much sunshine, it's able to warm the space and make it, a little more comfortable. In a recent study we did on a building in Ontario, we found that the noise reduction with Lumon system when fully closed was up to 13 decibels. So what we're seeing now as people are designing buildings to meet certain noise requirements, they're able to use Lumon system as an additional buffer for the inside of the unit, which again makes it a lot more enjoyable when you're sitting out there. You're not worried about so many, cars driving by, trains, sirens, whatever it is. So we'll go through a few case studies here and a bit more on the technical side of things. If I haven't lost you yet, this is probably where you might fall asleep. It does get a little boring, but don't worry. I'm trying to keep things on time here, so hopefully it's not too bad. The nice part about the single pane glazing on a balcony is the external testing that we had done by the CCMC. It's a non-thermally rated space, and it's basically a windbreak that's retractable. So what this means is it does not count towards floor area ratio, floor space ratio, and it's still considered by most municipalities an outdoor living space, which is good because it's definitely not usable in minus 30. It is, but it's miserable. And it shows that the product has been tested and is able to meet the required wind loading that you need to see for guardrails, but also for the upper glass above. So a few connection details that I'll show here. The big thing with this, again, because it's not 100% watertight or airtight, is depending on the wood and concrete connection, I'll show you up wood next, is there's a way for the water to drain out of the balcony if it gets inside, whether that's shimming the lower profile, like you can see here a little bit, on a concrete building, or having a curb to keep the railing up and installing scuppers, or draining the deck to a central drain to allow water to drain out. Another benefit of this type of system is you're not getting a lot of building facade penetrations. Based on the little bit I heard from that previous speech, air penetration in the building is bad, so we're going to do a little bit of that as possible, and that way, there's not a lot of areas where you're going to run into leaking, rotting issues, just because there's not a lot of penetrations. So you can see there with the wood, similar type of concept. This one here has a curb with scuppers on it, and then again, the same kind of three main points of penetration into the building envelope. You're going into the beam or slab up above, you're going into a post, a wall, or some sort of vertical support, and then down into the ground below. So not a whole lot of areas where there needs to be worry about design and waterproofing. Another benefit is the wind. Just depending on the design of the building and the location, there's a lot of wind factors to study. With early on design, you're able to fluctuate the building design a little bit to make sure that it minimizes the wind load on the balconies. And that way, you can see here, when we're trying to keep it below that 3 kPa threshold, we know we're able to design it where it's going to meet it. And the benefit is then, if we're over that 3 kPa, there's usually a little bit of design modification that you can do that's not going to ruin the overall look or facade of the building, but it's still going to get the desired outcome. So we'll go here into some renovation examples that we've been a part of. So this one in Victoria, BC, it was an entire building facade renovation. It was new decks, it was new windows, new doors, new siding. The only thing that actually remained was the brick there that you can see kind of in between the balconies. And Lumon was basically brought in because they had something existing already. It was, we want to keep this outdoor living space. We have this beautiful greenery that we're enjoying. We are not giving that up. We need something else that we want to use. So we see here, the whole building's been updated and modified with the same overall concept that was there already. And now they're also going to see the benefits of that because, again, they're not going to have to do that renovation on the building again for quite a number of years. So this building is one of my favorite buildings of all. I know you can't tell from this photo, but it's a very kind of bleak looking building in Denmark. And again, when they were looking for a renovation, they have that street there where cars pass by, but the walkway that you can see here doubles as unit access and a balcony. So when the architect designed it, he created these kind of little nodes where people can sit, they can enjoy the outdoor space. They have the little gardens where they can, you know, have some life in the concrete jungle. But then it also doesn't impede with people going past, and it creates that sense of community within the building because it's not a hard barrier with a dividing wall where maybe I can hear my neighbor, but I can't see them. And here it's kind of one big community. So we'll go through a few new construction examples. This is one project we've done with Mattamy Homes in Ontario, and they've done a variety. This one, they did just a few units. You can see here, it doesn't overall impact the look of the building, but they're able to get that use, and they find that that really drives sales in the building because it's an added feature and it's a differentiator from other buildings. And here we can see Soul House by Bosa Properties. I believe it was March of this year, February, one of these months. In the city of Burnaby, there was, I think, 21 sales that they occurred of all new construction in high-rise, and 9 of those were in this building. And they've really adapted that concept of inside-out living. So it's a big, big feature of still outdoors, but you're not worried about, again, the noise, the wind, the rain, and all those things. And now the benefit of this is, as well, you see this building in Germany, you're not overall taking from the look of the building. This is the Roots building. I'm sure some of you have heard of it, where it's mass timber construction, and you're still able to enjoy that view of the lumber from across the little dock that they have here. But again, the lumber is going to be protected from that ever, you know, ongoing war of maintenance against the weather and protection. It's an extra layer of protection without, you know, taking away from the beauty of the timber. Additionally, you can see here a few cases in hospitality and amenity spaces where, again, it's that control of the weather to make it a predictable, usable space year-round. One last one. This is a project that's ongoing right now in Canmore. And what's interesting about this one is it's a bit more of a luxury, high-end kind of short-term rental building. And they saw this, again, as an added value where people were able to come. And again, they can add to that kind of luxury aspect of the building where now the spaces and units are usable year-round. So next time you're driving out to Banff, swing past this building, take some pictures, and admire the beauty. So thank you.
I'm waiting for the flurry of activity to start behind me. Thanks, Just Mike. That was great. I appreciate doing things that make buildings more maintainable and better for humans. I think those are two great things. While they're setting up the chairs, I did want to mention we had a pair of eyeglasses that were found, blue framed eyeglasses. So we have them just up here where I'm sitting. So if you lost your eyeglasses, come see us. There will be some refreshments and networking at the end of this is the final panel for today. So please stick around for more of that networking. And the AAA sign-up sheets. Don't forget to do that if you're collecting credits for that. So the panel that's going to be on stage next, I can see them all waiting excitedly in the back. as the chairs are being set up. We have Joshua Taryn, who is actually with this particular presentation from the University of Calgary. And we have Steve Wurzba from the City of Calgary. Maxime, I don't want to butcher your last name. Olszewski from Astra Group, and Christopher Zahalik from LeMay, and David Leonard from Metaphor. Come on up. Talking about adaptive reuse, protecting heritage and modernizing facades.
Hi, everybody. Is this, you can hear me. Oh, all right. Deep seats, right? Hi, everybody. Thanks very much for sticking around for this. Let me see if I can find my phone somewhere that has my notes for all this. Did I put that down somewhere? Actually, let's see. Yeah, here we go. Maybe I'll just take a second to introduce myself very quickly. My name's Josh Taryn. I'm the Associate Dean Research and Innovation at the School of Architecture, Planning and Landscape at the University of Calgary. I think you'll see our new building somewhere in some of these photos. It's really interesting to be here, and we have a very interesting group of individuals who are, experts in facades. And there's a bit of a conversation we're hoping to have here. So bear with me as I sort of work through the notes of this. We're really going to be working through about 3 sets of questions. And while we do have some degree of scripting, I think also I'm very open to kind of seeing where the conversation goes. So please feel free to interact with one another as we go through this. I think that's probably a more engaging way to sort of work through things. But maybe to kind of start, we'll take maybe 15, 20 minutes on this. But really the question is about what you guys think are the most important components of building facades. So it's kind of a macro level question, and really kind of targeting the most important aspects in regards to adaptive reuse and historic preservation. So maybe I'll turn it over to you, Chris, and just sort of we'll go down the line.
Sure. So, hi everyone. My background is in heritage conservation primarily, and from where I come from on projects, a lot of where we start on adaptive reuse, on conservation projects, begins with truly understanding a project. So we like to take an initial step, and before trying to prescribe a solution, trying to really get into what we're going to do, talk about the end result, we start to look at what exists and what is the building made up of, what are the different components, what are the assemblies made up of. Traditionally, a building we often will focus on will be early 1900s, pretty common in Calgary, a lot of sandstone, and that would extend even to modern heritage. And so part of what we want to do is really try to understand where we're getting into a project before we start approaching a solution. And a lot of that comes down to materiality, whether that be material testing, compatibility with new assemblies, integration within projects, but also understanding how that existing building has a place within its site and its adjacent neighbors, and how that relationship, whether it's the existing building on something that was there previously, or how it has now informed something on that site. So between those two, that's kind of where a lot of times we'll start to really focus our energy before getting into it.
All right, my name is Maxim, and I'm happy to be here. I will speak from the lens of a developer. And my biggest, or I guess the first thing I look at is how do you integrate the cost per square foot, or the overall cost, versus the performance and longevity of the envelope. And me and David had many conversations, heatful disagreements, because it's really difficult to find a path that meets all criteria at the same time, because naturally you want the best looking, the best performing building, but it doesn't necessarily mean that your performa is going to support it. So for us, it's always that apex or integration between the cost and the total outcome, which is driven proportionately by longevity and performance.
Very, very tidy, very concise.
That's how Maxim is. Yeah, no, as Maxim said, we had the privilege of having a few heated discussions around what we were going to do with a couple of his projects. Maybe fun fact, we actually met when I was moved over to Metaphor there, and I looked across the street at this green building, and I thought, that building could use some work. I'm going to just introduce myself. And Maxim says, well, I don't want to fix my building, Dave, but I do want to talk to you about a couple other projects. And we started working on the Petrofina Place 800 projects there. So when we start looking at our projects, especially with a heritage concept like Petrofina there, we really needed to understand what the existing conditions were, what we actually had to start as a baseline, what we were working with. That started to then drive a lot of the discussions that we would have to have, particularly around the funding that was then going to be needed to meet certain targets. So it wasn't just about like for like, clean it up a little bit, do a bit of caulking and things like that. It was about improving the energy performance of the building, reducing greenhouse gas emissions, things like that. And so through that, the tug of war that Maxim and I worked on there was figuring out how not to totally screw up a heritage building, but still check the box that he needed for his energy stuff while also being able to pay for it simultaneously, right? So, no, I think it's a lot of fun. I think if you look at this stuff, it wouldn't be any fun if it was easy. So they are challenging, but you do need to be able to get your hands into it and really understand what you're actually doing there. So.
And I'm Steve Worsba. I'm a senior development consultant with the City of Calgary's downtown strategy team. And so I've been involved with our office to residential conversion program since it launched in 2021. And so that's the angle I'm coming at for this topic around adaptive reuse and how we've helped to facilitate that from the city's perspective. So that program, it was really launched just in relation to the extreme vacancy that was taking place in Calgary in the aftermath of the oil downturn in 2014, 2015. So it was really geared towards reducing office vacancy, but there's been a lot of positive outcomes and positive just sort of features of that program as it's gone through its phases and helped convert buildings in downtown Calgary. I think you'll see some slides that kind of have high-level stats around the number of units and the square footage of this project over time. But really it's hit on a few key things. So like I mentioned, reducing the office vacancy to stabilize our tax base and really improve property values in the downtown is a big part of it. Downtown vibrancy and just really increasing those perceptions of safety and real safety in the downtown is another huge part of it. Providing new residences for Calgarians. And then on the adaptive reuse side, it's really both an aesthetic and I think a performative sort of improvement to buildings in our downtown. Last year was a huge year for our program in terms of buildings coming fully through to completion. So if you're driving around or traveling around downtown, you'll see quite a few examples of these projects that are now finished. Maxims are many of them. So yeah, that's and Joshua, you mentioned at the start, it's a panel of facade experts. I would like to exclude myself from that category, but yeah, just here to sort of provide a specific perspective on how the city is sort of helping to facilitate these projects.
I mean, maybe we can try to fold this into the next set of questions, but it seems as though there's a lot of different criteria that need to be folded into whatever is being addressed. And communication, of course, is something that you're speaking to, and it does seem like across all the answers is about balancing those different demands across it. Is there a way in which you could sort of describe the way that you approach that balance, like whether that's like a particular kind of process or particular kind of principles that you use to kind of organize or prioritize those things? Like I would imagine you may actually have a different set of values from your different perspectives, like what are the highest priority items or ideas or principles that you might bring to things in order to bring balance between let's say, the myriad of things that you're trying to fold into a project? Maybe Maxim, maybe let's start with you, like from the development side.
For a hard question.
Yeah. Well, it's interesting, from given the prevalence of the number of projects, maybe it's not so much your approach that I'm asking about, but maybe an observation about the range of projects that you've seen. That, like, what are the highest priority kind of principles or items that you see sort of driving projects, let's say outside of cost?
Well, I think outside of cost, me and David had plenty of discussions about how to ensure, and let's zero in a little bit on the heritage component.
Yeah.
Because when you have an old structure that used to, as David explained to me in very elementary terms, breathe, am I getting this right? And now you're trying to bring it and modernize it and introduce a whole other layer that will meet the new criteria. It's like, how do you make both systems function at the same time? And that becomes a very technical question, because you're merging two worlds that shouldn't exist together. And that creates quite a challenge on the construction side, on the cost side, on the technical side. And it creates a lot of options. And I think, like, for us, it's been exploring those options constructively and not crossing anything off until we find a path of least resistance. Would that be a fair statement, David? Yep. And each project has slightly different methodology. What we've done at 806th project, it's very different than what we've done at Petrofina, and compared to what we've done at the Cornerstone project. All different envelope systems, but they all meant to achieve a very specific energy efficiency. And of course, I can't speak about air tightness. Maybe you can remember those numbers, but it's that good combination of, again, the efficiency and combining the old and the new that we really focus in on, and then bring the experts in the field and do the best we can with the canvas that we were given.
How would you, just to put it to, let's say you, Chris, what would you say is sort of like the highest priority kind of like design process principle that you think helps govern for successful projects you've been involved with?
So, most successful guiding principle?
Yeah.
Oh my goodness. I think the energy performance for us was a critical component. And again, that ties into all our financing programs, right? So bridging that gap, again, thanks to David, who participated in 2 of our projects, that was a critical component that we always focused on.
So from your perspective, how do you see that translating into, like, would you agree with that, or and if so, how do you see that in your own design or the design process of the projects you've been involved with? Or is there a disagreement? Do you think that there's something other than performance that you think helps drive the success of projects?
Permit timelines?
It's.
I mean, I'm not necessarily putting on you, Maxim.
Oh, yeah, okay, because you're looking at me. You want me to answer that? Because I'm like, you've got engineer.
Yeah, no, I'm sort of opening it to the panel. Like, please feel free to jump in.
Oh yeah, you go ahead, David, because I think.
For sure, yeah. So from our perspective, public safety. I think that's the number one thing for sure. Part of the scope that we did before we even got to drawing the building was getting on a swing stage, checking out the building. We did find loose bricks and have to address those and make sure that the building was safe, not just for the life of the building, but in the time that we were going to be obviously working in construction there. So it's kind of thinking through the state of the building, through all the different phases of where it's at, what it's going to go through, and then what's ultimately going to be, which is obviously when we're switching it from an office to a res building, that's going to be a different type of interior conditions that we have to kind of worry about, right? So
I guess just to add to it, like a lot of times in our heritage world, we're almost having a designated building, which sets it down a certain path. So it almost makes it easier in a sense. Having a designated building, you have an outlined importance of what has been evaluated on a building, what is that defined, character-defining elements, heritage fabric that must be preserved. So that almost sets a set of rules that we follow. A lot of times if it's a project that's not designated or more getting into modern heritage, as a lot of this adaptive reuse is starting to approach on, we almost take a similar approach where we're in that understanding phase. We really start to understand where that importance is. We've talked a lot about envelopes, we've talked a lot about performance, and I think when you're starting to take an old structure, looking to adapt it, whether it's keeping the exterior envelope, keeping other parts of the building, parts that have been identified as having that importance, you really start to want to study how the two will work together, start to establish a hierarchy between them. A lot of times if it's a designated heritage building, we'll want to put that front and center. It doesn't mean that what you're adding new shouldn't have an equally important part that's shared with that new building, but the two are meant to act together. And I think with some of our work, we really try to focus in on the materiality of what exists and look at how you can have that hierarchy created and have something that looks new, but also compatible.
And just to sort of follow up on that, like is a historical framework, do you think that it's entirely sufficient for that? Or is that only kind of part of the equation for what you're talking about?
I think it's only part of it. I think it's a good starting point. I think there's a lot of times where things have evolved over time. So maybe there's been something since it's been designated, for example. There's an implied value that's been added to the building or something that's contributed to the community that might not be necessarily called out. But what it does is it gives us at least a starting point. And I think there's a series of other elements within any design that I think have to come in. And I think we've talked about it a little bit here. It's been talked about today, but really having the right people involved and having that collaboration from multiple skill sets really is what allows you to start bringing all those different components together.
Steve, what are your thoughts on all of this?
Yeah, I think one more perspective we could add, like from our program, we're really looking at it as well from like a benefit to Calgarians. So when we're partnering and we're providing public money towards these projects, we want to look at certain things like access to natural light, how the building is working at ground level, that sort of street level activation, as well as like amenity space for residences in these buildings. And so we go through a comprehensive review of applications that come through to the city around how those elements are being delivered. And yeah, really speaking to the collaboration piece, I think we've improved over the course of the years going through this program of really having a set of guidelines that are clear and transparent at the start for developers to work with. That wasn't always the case of the program. In earlier projects, we did a lot of iterations with developers and with architects around, we kind of like this, but we don't like that. And I think that was a difficult way to go about things. And we've tried in working with our development partners and our applicants to improve that process to a point where we can sort of be mindful of those considerations around performance and around their pro forma and the financial side of things and say, this is what we want to see. Let's see your best iteration of this project. And just so still having that bit of oversight on those elements that are going to be important to residents when they're moving into a space.
So maybe just to kind of be quite specific about this, and we can sort of stay on you, Steve, for this, is how does one deal with explicitly amenity, policy, cost, and technical issues in pulling that together? Is it just sort of a general kind of condition, or could you speak to any one of those in particular in terms of how you sort of navigate that more specifically?
Yeah, I mean, amenity is a good example. I won't get too into the weeds into it, but in a lot of cases in projects downtown, you actually don't have to go through a development permit process where there's legislation saying you must provide this much amenity space per unit. There are standards in our bylaw around what you're supposed to have, but in the downtown core, there are exemptions for projects, even of this scale. So our program sort of operates beside that, and we have guidelines as opposed to rules. So we base some of those requirements, say for amenity space around, we'd like to theoretically see this much amenity space per unit, but it's still just a general recommendation, and applicants are providing what they can and rationale around this is why we think this kind of amenity is going to be beneficial for residents in this project. It's a higher quality amenity, or it's suited towards a specific target audience. And so we're just considering all of that when we're balancing projects and choosing what to support. In the case of amenities, for example. Yeah.
David, how about from your perspective on amenities, maybe?
For sure, yeah. So when we were looking at these projects here, it was looking at how do we implement an interior balcony on a structure that has never been cold before, or not as cold, I guess, intentionally not putting it outside the building envelope there. But when we started looking at these things, I mean, it costs a lot of money to do that. There's a whole pile of extra insulation, a lot of other details. In the one project that we were looking at there, we were going to basically add 200 roofs to the building, essentially, because you're now creating this condition that's going to have to rely on different drainage that had never existed before. And so when we start to look at it, in addition to all that, the daylighting actually got worse, because now by moving the envelope closer to the inside, you kind of created this kind of condition that would shade the balcony, and actually it didn't create a very good outcome in that case. So we could kind of demonstrate, and through the collaboration with the city on that, we said, like, look, it's not about just saving a developer money, sorry Max, but like there's this other component to it which also does result in saving some money and allowing a better quality space. And so in the one case, we were looking at whether or not we'd be removing certain portions of the envelope in order to accommodate new openings, things like that. And so we were able to utilize we didn't forget about it, I'd say, but there's this nice mechanical space that has like a 18, 20-foot ceiling full of nothing. There's no mechanical up there or anything like that. So actually we're able to repurpose a different space and actually use it as an opportunity to come up with something a little bit more unique that hadn't really been thought through up until that point in the project. So yeah, working with the team on all those different things, it became a very technical exercise supported by this idea that we're building these buildings for humans, thinking about daylighting and things like that. So.
Essentially, and Max, I mean, what's your take on the importance of amenity, or how do you maybe, like, even just looking at any of the buildings that sort of pop up that maybe you've had your hand in, how important has amenity been in terms of, let's say marketing the projects?
You know, having good amenities within the building, of course, will attract tenants. It will be additional things for them to be able to use within the building, additional value that they will receive as being part of that space. Our strategy has evolved a little bit because all of our projects are within the walking distance of one another. We decided to create Astor Living Club service. And ultimately what that means is, instead of putting a gym in every single one of these buildings, we have one good gym. Instead of doing multiple spaces that, a little community hall here, a little community hall there, we have a massive space on the 18th floor with beautiful views on Place 800. That's the space you're talking about. So when we introduce an amenity space in a tower that's located close to another tower, we're trying to complement every single other tower within the space, and then allow our tenants access to all these buildings and to all these amenity spaces. So they get a lot more value out of being our tenant. So again, going back to what Steve said, even though there wasn't really a criteria, the city still chose the projects that put the best foot forward. So a lot of times we actually had to go over and above the requirement. Correct me if I'm wrong, 4.5 meters squared per unit needs to be amenity space.
Around there, yeah.
One of our projects has doubled that square footage. So again, it just really depends on the building, really depends on the performa, depends on the city support. So you try to merge all of them together.
And Chris, maybe, I know we're sort of talking about like juggling this into the next sort of round of questions, but I wonder if maybe you could sort of speak to the kinds of conditions that make it easier to produce amenity space, particularly as it relates to envelope and the sort of outer portion of the building. Or are there certain kinds of, and not just spatial conditions, but also material conditions that you could see through a historic lens that maybe touch on the ability to produce amenity space?
Yeah, so I think there's kind of a series of things that go along with it. With a lot of heritage, we find that a lot of the materials are kind of more opaque. I think that's kind of a little bit in contrast to what you typically find in a lot of amenity spaces, especially when you're trying to maximize views, create spaces that people want to go to. And I think there's almost a bit of a balance that needs to be struck there, where you're trying to adapt a space to suit a use. And if that use is not directly what it originally was, I think that's okay. I think it's okay to acknowledge that the way spaces are used throughout time can evolve. And I think within the building, part of that has to also translate through. And I think specifically to heritage, I'll just kind of come back to it because I find this a lot, but within heritage spaces, they naturally draw people. I think they're so unique. There's something about it that feels welcoming to people. And whether that's 100-year-old just exposing existing materials or something throughout time in a unique space, sometimes the architecture of the building of what wasn't meant to be seen can be brought forward, or the materiality of it. It really helps to contribute to creating a unique atmosphere that can speak to those amenity spaces. And I think it's done very successfully in a lot of different places.
Yeah. Steve, I'm wondering if there are any projects that come to your mind that might relate to what we're talking about here in terms of like particular kind of materials or particular kind of constructions or that come to your mind that the city's been involved with.
Well, I mean, you'll see as the slides go past, there's a real variety of exterior treatments for these conversions. Some of them have the entire wall system removed and replaced with something new. Some of them have at least very visually minor changes in terms of new windows being put in. So it really runs a full spectrum of what you can see take place. And I think there's advantages and disadvantages to every way of doing it. A lot of buildings like Petrofina, for example, they have a really beautiful existing condition. That's a heritage asset, so you don't want to go and have a lot of changes take place there if you don't have to. You're maintaining something that's really nice. Some buildings can really do with a facelift, both visually and in terms of performance. Petrofina and just sort of kitty corner to it, the Taylor building is kind of an interesting example of two buildings that both were on our heritage inventory before they began the conversion process. Petrofina went that route of sort of maintaining what was there, working with our program as well as a separate city heritage program to formalize some protections around heritage elements of that building, and received sort of additional heritage grant along with our money. And so really three groups working together to preserve that building in a really effective way. And then across the street at the Taylor building, you'll see some pictures come back up. They had an existing curtain wall system that was in really bad shape, and there just wasn't an ability to maintain that when you're fully overhauling the building. So they had to go down a route of fully removing that wall system and coming up with something new. It'll be a new wall system that looks fantastic as a new concept. There's actually, I don't think we have pictures here, but there's a lot of brick and really nice elements involved in that building, but they went a different route, and so no longer sort of a heritage asset in that aesthetic sense. But I certainly would say, I guess there's not one right way to go about it. And when we look at it holistically in the downtown, for us, it's really about just sort of freshening up these buildings and from a visual sense, when it's the facade, like increasing the vibrancy in that way in the downtown.
I mean, just quickly before we move on to you, David, to kind of follow up on maybe some of the technical challenges on those buildings, I will say, like, it is notable when we're looking through these images, like you can see different cities very immediately in the buildings, and maybe just something to keep in mind as we kind of get closer to the end of the conversation is how to kind of elevate the aesthetic standard that this city has, especially when we're so good at tearing down a lot of our historical buildings and putting up things that maybe not currently, but in the past couple of decades have not looked so great. But sorry, that's kind of an aside. But David, so maybe on the Taylor building, could you talk a little bit about the technical issues that were related to that? I mean, that's a building I look at daily now. Really curious to see where it goes. And given that it's sort of in transition and under construction at the moment, could you sort of speak to some of the challenges on that
Sure.
project.
Yeah, so I probably can't speak directly to the Taylor one. We're not involved
You're not
in that
on
one.
it? Okay.
No, but
I'm just following my notes. I'm assuming. Yeah.
No, it's all good. Yeah, no, I'm kind of touching on Steve had said there with Petrofina. It was not a designated heritage building. Max wanted to do a office stress conversion project, and through the course of that, we decided that that was a good option for getting it designated. And so, in doing so, it allowed us to retain as much, if not almost all, of the exterior. So the windows, they were pretty old, obviously they had to go, but it made it so that it was more cost effective, more schedule effective, more sustainable. It kind of checked a lot of boxes there, and so it at the time it made a lot of sense, and I think still does. And but yeah, as you know, with like the Taylor building, it's a completely different strategy, and that's just something kind of have to look at for each project, obviously. Is unique.
So maybe Max, you could speak to them more.
$6 million glazing package. Thank you, David.
They're nice windows. What can I say?
The windows are a good place to put money in a project. You know, I mean,
that's exactly what I told Max.
I'm like, oh my god.
It's okay. Spending money on windows good. You know?
Money well spent. Yeah.
So Max, maybe you could speak. Can you speak to the Taylor and what the challenges are around that?
Taylor is not our project.
Oh no, it's not. Okay.
Sure.
Yeah, I don't think we have anyone directly from the Taylor, and I can't speak to the technical side of it outside of like they did, the structural and the other testing around it, and it wasn't something. It was a full curtain wall system that
it's got dropped completely off.
Had to go. Yeah.
Yeah, so it was just shot. It was just a matter of putting another fresh one in.
Yeah, I think we have a photo that shows it in current state, which is just fully gone. And if you go drive past it across from Petrofina on 8th Avenue, you can see they're most of the way through constructing the new wall system now. So
yeah. So maybe entertain me for a moment. Like, this may not be a purely facade-based question, but on the Petrofina building. It looks as though those are pretty nice residential units, like in there. Like, how do you guys determine the level of conversion that's going into a particular project? Like, is that purely a market calculation, or is it related in some way to the level of performance or the aesthetics that you're bringing the envelope to? Like, is there kind of a matchmaking process, on a design basis, or how did you guys determine what to kind of put on the inside of that building in terms of, let's say, the level of value that each of those spaces is getting?
So again, I'll answer that from a developer's perspective.
Yeah.
When we look at any site, we have a very specific price per square foot that we don't want to exceed. Because we know that price per square foot can be supported by the rents that are in this market. So then every site has its own different conditions. Your acquisition of a specific site could be a lot cheaper on a per square foot basis than another site, but you might have to do a lot more. So for example, Petrofina, even though we didn't have to redo the exterior full facade, the windows end up costing so much more. Mechanical systems had to be rerouted all the way to the back due to the heritage preservation. And then there was so much asbestos that we had to abate. So there was all of these costs that were extra. So to answer your question, our interior package, interior design is identical on all buildings in terms of the interior, while the exterior and all the elements, they change from project to project. And that also greatly varies with the floor plate. So Petrofina changes 4 or 5 times. So, and as you work through the building, we try to make it most efficient. And it just ended up happening that a lot of the units are 3-bedroom, 2-bath units that are meant to be shared accommodations or family-oriented suites. There's a lot of other social criteria that we integrate in our projects, including accessibility criteria. So 10% of all of our units in our projects have adaptable units. Petrofina specifically has 15 of them. So it's a very difficult question to answer without setting up a performer and laying everything out so you could see all these variables. Because then you also have to consider, okay, well, if the city contributes, here's everything that we can do with it. If city doesn't, then is this project even viable? So all of these questions you always have to answer, and all while you're trying to catch the market because costs are going up, rents are dipping a little bit, economic uncertainty. There's a lot of variables. The key is you have to be fast, fast to market, that helps.
Well, I mean, so maybe to kind of press you on that a little bit. I mean, obviously speed and being able to seize on opportunity is really, really critical. And Calgary in its history has always been actually quite good on being fast at things, but not always necessarily being good. So at the,
good.
Well, good, meaning like the city historically has built a lot of garbage. I mean, frankly, like that's one of the reasons why you can, by image, recognize different cities.
Or different architectural firms.
Sure. Yes, but in general, architects can only be good as the clients allow them to be, right? Be a good client.
Oh my goodness!
I
agree with Josh here, Max.
You're being. I mean, this is a tee up softball question, I think.
Yeah, of course.
But it's just to say, in many ways, Calgary is leading in adaptive reuse, whether it's the city and its investment in that, whether it's developers who are really leading the charge on that, and firms that are gaining a great deal of experience in the project pool that's available. I mean, we have not just a lot of vacancy, but we have a lot of projects that are capable of being converted, and they are being converted. So maybe the question to you is how is it that Calgary is leading in that area? So it's not so much a question of volume, but how is it in terms of process, or what is the mixture of things that it's allowing the city to sort of lead in that area from your perspective? Or how is it that you do it in a way that you think can be sort of an example for other cities and other developers?
This is actually one of your easier questions. Thank you.
Yeah, I told you.
I think it's everything about policy. Think of it this way. If you want to incentivize something, provide incentives. If you don't want something to happen, create some sort of punitive things. So the city did two amazing things. As they saw the decline in downtown, they came up with a creative solution, and that's the downtown incentive for redevelopment. But you also really have to consider that alone isn't sufficient, because every developer is concerned how long things will take, how will the process be, and how can they actually get the project off the ground. Downtown happens to be in the, and correct me if I'm wrong, enterprise area, so you ultimately could, depending on the project, bypass the DP if you're doing a change of use, which was meant to remove the restrictions that certain buildings just wouldn't be able to have the same articulation, right? And the ability to bypass the DP and work with the city directly to be like, here's what we're trying to do, here's the list, we hit all these criteria, all the safety measures are there. They won't budge on anything with life safety, but if a staircase is, 2 centimeters smaller than the new code, they'll be like, well, I guess that's okay, right? Fair statement?
Mm-hmm.
Yeah. And just got to make sure.
On the record.
So for those two things created an environment that created this opportunity. Here's all these canvases. Nobody wants to do anything with them. And then opportunists, jump up because they're like, okay, the risk justifies the reward now. Because we have city support, so we're not going to get stuck with this asset. We have financial incentive in case something goes wrong, there is sufficient buffer. And and it started out slow because there was a lot of applications, if I'm not mistaken, a lot of people were like trying to figure out how to get things off the ground. But once the ball started to roll, City of Calgary served as an example to North America. There's, I don't know how many tours we've done together across the projects, from delegations from like Denver and San Francisco and you name it, So when a policy solves a problem, you have tangible outcome, and you can see it working instantly. And that's the example of that. That's why Calgary became known as the leader of the adaptable reuse, I guess, movement, you can say it. But the thing is, the buildings are not getting any younger. You know, these issues exist in all major cities. And yeah, so other cities can follow suit. The key is don't overcomplicate it, because my goodness, you know, if you're gonna introduce so many different variables and you're gonna try to control this and that, it creates a lot of uncertainty, because money wants to flow into places where it's easy. There is certainty that this will work. There is certainty it will be protected, and that's what City of Calgary did.
Yeah, I mean, it seems like the clear message is produce policy that facilitates certainty,
Precisely.
right? And that's something that can be achieved through simplicity or clearing out a certain kind of space. So maybe as an open question, as we kind of move toward wrapping this up, what's to anyone on the panel, the advice that you might provide to someone who is doing any kind of office to residential and historical preservation, aside from investing in good windows and policy search? Both strong suggestions, right? But to the group, you know, thoughts on advice for someone who's thinking about this or you know, wading into this kind of area.
I can start. I think it really comes back to collaboration. We've been talking about that a lot. If you're here in Calgary, you can come talk to us. But if you're not, I would say I hope you have a good relationship with your municipality, and I hope there's people in place there that can try to catalyze things for you and have a sort of yes first attitude, and start that conversation early in the process, because, you know, whatever sort of legislation or regulations are in place, you really want to have a good relationship there to have a positive impact on the timeline and the final result. It all flows down from that timeline in terms of what you're going to be able to spend and what the quality of the outcome is going to be. So yeah, collaboration between the development partners, the architects, the code folks, and the city is really key, I think.
And my perspective is, Max hates this, but go slow to go fast. I think when you start getting into these buildings, being able to actually take the time to look at it, and it's not to just spend lots of time, you know, working through it, but you still need to be able to understand the limitations. Like I can't tell Max that we can or can't keep his brick until I look at his brick, right? And so
It doesn't take 2 weeks.
No. It only takes 2.5, but that's how it goes. But yeah, no, I think that's really important to make sure that you can explore the opportunities in the building, you can understand the challenges in the building, and you know, you kind of touched on it there. It's all about risk, right? And we're just trying to manage and mitigate the risk as much as we can. We all have worked on existing buildings. We all know the surprises that you find, whether you're looking for them or not. Yeah, I think that really helps to make sure the project's kind of actually set up for success to move through.
I guess I'll double down on speed. Might as well. Because here's the thing. The faster you get the project done, the more funds you can allocate towards delivering a better product. Supports more expensive windows, you know, and amongst many other things. And I think this is where the first project we've done, and I do have to give credit to the city, Cornerstone, it took 30 days for us to get a permit after we submitted architectural plans. 30 days. Where in the country are you going to get that? Of course that helps, right? If you're 2 years in development cycle, property taxes, electricity, all these other expenses, they all get inside the final product's performance. You can't escape it.
What's your thoughts?
I think from my perspective, it's to take stock in what you have. I think with a lot of these existing buildings, there's almost opportunities ingrained in the project, and it just takes not too much time, but a little bit of time to stop and look at what those opportunities might be. I think as these projects start to go forward and there's more and more adaptive reuse, retrofits, and a desire to improve performance of buildings, there's a lot of good materials on existing buildings. They might not be used in the exact same way, but there's a lot of energy, a lot of money, a lot of time put into these buildings, whether it's the structure, whether it's all of them, the envelope components. And I think there's a lot of creative opportunities, and with the right team and the right collaboration between individuals, there really is no limit to how these things can be reapplied.
Yeah, I mean, just, you know, from the perspective of someone who's just in downtown or looking at architecture, it really is an interesting and exciting time to see buildings transform in this way. Most buildings, like the number of eyes that experience it in any number of ways over time, is from the exterior. So it's really interesting and exciting to see a city transform without having to demolish everything, to save a lot of that embodied energy, to do it in a way that improves the operational energy performance of something, and to really sort of think about the way that we experience, you know, things. I would say, you know, if anyone's thinking about doing projects in downtown Calgary, do it around downtown West and 8th and 8th around our new building, so that we get to sort of see more and more transformation in that area. I think it's part of the proposition of us, you know, being down there, is that it would incentivize more transformation in that area as we bring more students and businesses around to that area. But anyways, thank you very much for the conversation. Really appreciate all the insights, and for bearing with me for taking this a bit off script. That's perfect. I'm matching it with it. So yeah, join me in thanking these guys.
Thanks so much. The words of wisdom that I want everyone to remember: put your money where your windows are. I heard that loud and clear. So that's a wrap. That's the end. It's been a great day. I am so appreciative for the opportunity to be, you know, emceeing and hosting today. So thank you. Thank you to everyone who laughed at my dad jokes. And thank you for your patience with my technology problem in the beginning. Yeah, it's been amazing. There are light refreshments out there if you want to network a bit more. And don't forget about your AAA sign-up sheet to get your credits. And I can't wait for Zak's to come back to Calgary for, you know, conference number 2.